Hey, there was a nice music here. I was dancing on backstage waiting when this our awesome TypeScript Global Summit 2023 will be started, and we all see each other here on this stage. And finally, we're here. Guys, I'm so happy to welcome. I can hear me. Okay, yeah, I'm back. I'm so happy to see so many people waiting for the start of this conference. I'm so happy to see my team on the big ground. And even our first speaker is nervous and waiting and ready with his large headphones, and everything is ready. So we're about to get started. Our very first TypeScript conference for Geekle community, and this is an honor for me. And I invite here the most important people who created all this is our team. Nadia, Nick, jump in. I miss you. I need you here. Hey,
Hello,
here's
everyone.
Nick. How are you, Nadia? How are you?
Hi. I'm great. I'm happy because today is the first day, and we prepare the so amazing summit for all of our entities, and we prepare useful cases, and I will be able to gain new knowledge and useful tools for all our attendees for their work. So
Yeah.
it's 3 days and 19, I think 19 the best speakers in this topic. Yeah, in the
Uh,
types.
uh, yeah, this domain. Okay, nice.
Yeah.
Thank you. And I'll give some like summary of this event. Actually, we were lucky to gather 1,500 plus registrations. I mean, plus is almost 160. I mean, 1,600. And yeah, that's a lot of people interested in this TypeScript summit. And we have 19 speakers with 19 topics, which natural. And we have 2 days first for beginners because Geekle is something not for like only experienced people, but part of our philosophy is when you are junior, we have no money to buy some fancy I don't know, courses or conferences. If you're a beginner, just come and take it for free. And if you are experienced developer and you can join here without need to go to some other country or other city, you just get at the affordable price this online conference with brilliant speakers, and you'll get to know what's new happened in the last 6 months, what new ideas your colleagues have from start teams. So that's what Geekle about. That's what this conference about, and that's why we're here. Okay, Nadia, give us more updates about how was the process? How did you manage to gather all these speakers and agenda? How did you work on that?
Yeah, thanks, Ed. I very happy work with sovereign speakers and moderators because all of them help me a lot during the organization of the summit. They are expert for this. How it's called correctly. TypeScript, and they preparing them very useful information such as upgrading. Today we have the main direction of the summit, upgrading legacy JavaScript codebase to TypeScript, advanced TypeScript features and techniques, type management and sharing common TypeScript issues and how to avoid them, and a lot of use cases. So our speakers really expert, and they're, I think, ready to share their knowledge to all of our attendees.
Thank you very much. Thank you for this information. And by the way, people, we always do this interactive community activity, and I'm waiting for it. Like, just write in comments, where are you from? Where are you now? What country, city, or room you are now? It would be really awesome. I'm in France, guys, Nick and Nadia in Ukraine and Kiev, I guess, both, right? So yeah, it's really it's really exciting. But some guy at school says, "Will AI destroy all front-end jobs?" Small question. Yes, this question like has an answer, of course, but everybody has like different answers, different like ideas on that. And maybe our moderators will ask this question that like all speakers. And yeah, Ukraine is here. Someone lucky, right?
But
And
about that question, we recommend you go and register for our AI in software development conference in July. So we will be answering this and similar questions on that particular event. So we'll be talking about using AI in software development, about different tools and approaches, and what's changing. Like this is a very, very crazy year is happening in the area.
yeah, absolutely. So, how exactly AI destroys all this software front-end development? You will know our another conference. That's a nice idea. Okay, yeah, I see lots of people from Ukraine here. Like, hey, brothers and sisters. Yeah, and also Portugal. Yes, Brazil and Skopje, Macedonia and Germany working in Stockholm. Okay, Istanbul, Lithuania, from all around the world. To the moon, someone say, and Madrid, Zimbabwe, South Africa, nice. Guys, I'm so excited. Israel made in Ukraine. Yeah, we made it sometime. Someday, sometimes we'll make it. Okay, yeah, lots of people, more and more coming here. Um, Nick, what offers, what special ideas, what can we share with community today? Give us something you prepared for that.
Well, yeah. First of all, I just want to mention that we'll have a long day ahead of us. So we have around 6 hours of sessions. We have 3 blocks. We have 9 sessions and Q&As also today. So we have lots of stuff. I hope you'll be able to watch as much as you have time for. And also, please be active on the Q&A sessions. We will have our speakers ready to answer your questions. So we'll have 3 of those at the end of each block. And second, of course, we already mentioned that we have tomorrow the same amount, at least the same amount of content, and probably even more. And we'll be having a senior track, more advanced stuff. And if you haven't already registered to this senior track day, you can grab yourself a full access ticket to this event for only $99 if you go and use promo code TS Live. We have only first 5 5 tickets for first 5 people who will get to the website and grab this offer. So please, if you were interested to join but didn't get the chance to get a full access ticket for the senior track, please go ahead. You can also go ahead and check our schedule if you click the link on the platform, and you will find what amazing talks we have prepared for you. And I'll also be posting this link in the chat in a moment. And of course, we are not talking all, like, TypeScript is the future, and we'll be discussing it today, but we'll also be covering JavaScript in September. So we have a dedicated JavaScript event that Nadia will also be doing. She already gathered amazing amount of amazing speakers. We have lots of speakers already. We have a good lineup. Please go ahead on the events.geekle.us/GS23 and take a look. We also have an offer for 20% discount. So if you go and use promo code TS Geekle, I'll also be posting this link in the chat in a moment. And I think we can start.
But I have one thing I need to share after I read more cities and countries, because this is really what excites me, right? So Cluj-Napoca, Romania, and also we have where's this chat? Yes, and we see Hungary, Albania, Sweden, Portugal again, Malta, Deutschland, Portugal, another one, Italy, Albania, India. People, you are amazing. We are the community, and we are real global. One more Portugal. Lots of people from Ukraine and Portugal today. And sometimes, I always wait for people from the opposite side of the earth, like from the United States or islands or Asia, but can't see for now. But maybe someone is shy. Yeah. Anyway, the last thing I wanted to share is our thanks to all speakers who contributed their time, their energy, thoughts, fingers to prepare this talk, to come here and give the one. To all community members who joined the program committee, people, thank you very much for helping Nadia, helping us, helping community to be really updated on new ideas, new technologies, new engines, and everything you have here. Thank you very much. Thanks for everybody who paid at least $1 to this project, because you are actually those who support us. We don't have super sponsors or big branded companies. We are driven by community. And we also help Ukrainian refugees, and we evacuate people from Ukraine or hot spots or borderline, or you know what happens there. Anyway, that's all I wanted to share. Thank you for contributing, being with us. And 2 minutes, I took like more than I had. So Nick, like let's invite Phil Nash here.
But first, let's invite our first moderator. We have Stefan
yes,
here. Yeah, so let's welcome Stefan.
Hi, folks. Hi, everybody. Thank you for having me today. I'm doing good. It's lunchtime here in Austria. I'm very hungry. So I totally forgot to get myself some food. So there you have it.
Well, I will call our lawyer and ask them if we have any restrictions on sandwiches in the street. If not, you're free to grab one and eat it like and moderating time for sandwiches. That's okay. Nice to see you here. Well, stage is yours. You know what you're doing. So we just disappear and have your time and enjoy it with the community.
Yeah.
Thank you.
All right, everybody. So hi, I'm Stefan. I'm coming from Austria, from Linz. It's beautiful outside. It's sunny. And I don't want to keep you any longer with my shenanigans. I want to welcome the first speaker on stage, and I'm very excited that I'm able to welcome Phil here, because Phil, it has been ages. Hey, how are you?
Too long. I'm good, thank you. It's so good to see you. It's so kind of weird to see you at a conference like this without going anywhere, but
totally. So to be honest, I'm just here because of you. I saw that you're speaking as well, and so I said, yeah, well, I'm grabbing the first moderating slot, so you can chat a little bit. And I know we need to keep it short because lots of people, I guess, are waiting for your talk. But hey, where are you calling in from?
I am here in Melbourne, Australia right now. It is gone 8 o'clock at night. It is dark. It is cold outside because it's autumn here. And yes, that's where we are.
It's so surreal. But hey, so it's already beer o'clock in your time zone?
Mm-hmm.
Okay. Oh, yeah.
It is dark. I just happen to have good lights here.
So, Phil, you are now with Sona.
That's correct, yeah.
And doing, I guess you have been doing the JavaScript stages of the world for the last decade or so. And now entering TypeScript talks. How cool is that?
Yeah, I've been a fan of TypeScript, but never kind of too bold to spend too much time talking about it now. And I'm excited to kind of burst in on that. And I hope I got some kind of interesting insights about it for you all today.
I'm very looking forward to that. And I don't think I should keep the audience waiting any longer. I'm just pulling up your slide, remove myself, and say, hey, Phil, it's so good to see you. Have fun in the next 30 minutes. And the stage is yours.
Thank you so much, Stefan. And hi, everybody. There we go. We have slides as well. Good stuff. All right. Well, my name is Phil Nash. I am indeed a developer advocate for Sona. It's a fairly new job for me, but I'm very excited to be part of Sona. If you don't know Sona, they make a few products that do static analysis on your applications to help you write a better, more maintainable, more secure, clean code. There's two things here. Sona Cube and Sona Cloud are basically the same thing. Just one runs and analyzes your products in the cloud, and the other one does so on your own servers. And then there's Sona Lint, which is an in-browser IDE, which I'll actually show you a little bit more of that later because it helps us with what I've got to talk about. And then this is me. I'm Phil Nash. I'm Phil Nash all over the internet. Do come and follow me. Find me on Twitter or LinkedIn, especially if you have any questions after this. I'd love to answer, help you out. Anything I can do to help us all write clean TypeScript. I will also point out, I can see the chat. It's slightly off to my right here. So I'm happy to try and get T-shirts to people at some point. Maybe we'll have to meet in person at another event at some time, but it is pretty cool, right? I do like interactivity, especially if we're like not in the same place, country, time zone, anything like that. So do shout out in the chat if you have any questions, or if you just have any thoughts or feelings about what I'm saying. Hopefully, some of these things will surprise you. So we are talking today about the top 5 TypeScript issues in everybody's projects. And I say everybody's because I've actually got some data about this. And this is why I bring up Sona in the first place. I actually dug into the data from Sona Cloud. So Sona Cloud is that online platform for static analysis of applications. And it turns out there are hundreds of millions of lines of JavaScript and TypeScript in Sona Cloud. Some of which is open source, and actually you can go and see. Plenty of which is other people's closed stuff. And I just looked at the aggregate data from that to see what's going wrong, what could be better inside TypeScript projects. And I check JavaScript as well because they work in the same kind of way. And so I was looking at the top. I actually extracted the top 10 issues, but we'll only go through the top 5 now for that's all we have time for. But when I say issues, I do want to kind of explain what I mean by that as well. You see, Sona and our static analysis is all about kind of clean code, and clean code to me is about writing code that's both good to maintain and easy to read and understand, but also that works well in terms of being secure and performant and all that kind of stuff. And so these issues, I mean here, are the sort of things that we can pick up by statically analyzing applications and projects and pointing out various things that could be done better, could be more maintainable, could be more readable, could be more understandable. And like I said, this is all about writing clean code. It's about writing code that is both going to run well in production, but also be easy to develop on as well. There's a few people that have talked about clean code and other ways of writing code in the past, and I have a couple of quotes here which I just absolutely love. One was from a guy called John F. Woods. He was a computer programmer back in 1991 on the C++ mailing list, where he said, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Code for readability. Now, the violent psychopath part is obviously a bit of a joke, but code for readability is absolutely the key part of that. And this is what they were talking about. This is a mailing list, and it happened to be a bunch of C++ developers talking about whether using the comma operator should be encouraged more. And I kind of looked at, as I was looking at this code, I kind of thought, well, that actually would parse as JavaScript at least. Maybe it's not the best JavaScript, but they were saying how the comma operator allows you to drop the braces around a condition like this and just have everything happen on one line. And somebody else in the chat, somebody else in this mailing list pointed out that just a single typo, mistaking perhaps a comma for a semicolon, completely changes and in fact breaks the code. And as JavaScript or TypeScript developers, you have probably spent some time searching for a semicolon or a missing semicolon that's causing trouble. And so the comma operator, that's the sort of thing that is going to make that violent psychopath come looking for you, I guess. A much more gentle version of that quote was from Raymond Chen on a Microsoft blog, where he wrote design for readability. Same, basically, in my opinion, as code for readability. That he said, even if you don't intend anyone else to read your code, there's still a very good chance that someone will have to stare at your code and figure out what it does. And that person is probably going to be you 12 months from now. And so both of these kind of point out that we have the future to think about when we're writing code. And that's what's important. And that's why getting these issues and avoiding these issues that I'm going to show you later through the talk is important, not just for ourselves, but for our colleagues and our future selves as well. And so, yeah, we're talking about clean code. We're talking about code that's going to run better in production, but also better to work with in development. And hopefully that's what we all kind of aspire to. Some code that is both a successful application, but also something you're happy to work on as well, not something you call legacy code and try and avoid. So what are these top 5 issues? What have we got? Well, I got a little countdown, a little table here, and I'm going to tell you straight up front, I'm not going to even count them down in order. Turns out the order is not as interesting as I'd have liked it to have been when I pitched the talk. And so we're going to skip about a little bit, not too much, just in order to get what I think is the most interesting thing right at the end. Because it turns out when you look at the absolute top issues, the ones that come up most commonly in projects like this, they turn out to be common issues that you probably understand and know about already. And so let's start. I did try to jazz them up, by the way. Hope you enjoy my animations on screen as well. We'll start with number 5. There it is. The top 5th most seen issue in TypeScript projects that we've seen, at least in Sona Cloud, is tracking use of to-do tags. Now, this is something maybe you use. To give me a shout out again in chat if this is something, if you use to-do tags. By that I mean a kind of comment syntax with a to-do after it like that to say, hey, we should finish this bit of code. Now this is why I led in with kind of, is this an issue? I think so. SonarCloud at least tracks the existence of these to-do tags within people's code. And what I think is quite interesting is that of all the potential issues, and there's more than 300 TypeScript issues that we track, the fact that people are leaving, that's committing code to their repositories with comments in saying, finish this off, basically, is maybe a little concerning. I don't know if you see this in your own applications, but do let me know if you do. And if you do find that, in fact, you actually have a growing set of to-do comments in your projects, that you should maybe consider doing something about that. I do think that I'm sure things like I'm honestly not trying to attack. I'm just saying, let's if there's to-do tags in your code, either it's time to remove that code if they're too old because you're not going to do them, or get them on that issue list to have a look at. But I'm not attacking anybody personally. This is the 5th top issue we've seen in TypeScript projects around the world. So, yeah. All right, cool. That's number 5. Nice and easy. We can go back to work tomorrow. Not tomorrow. Wednesday. Wednesday's the other day. We'll go back to work after the conference and decide to do a little look over our to-do tags and see if they're actually going to get done. So in number 4, let's take a look. In number 4, I thought it was really interesting. We actually, this turned out to be a React issue, disallowing binding and arrow functions in JSX props. I think this is absolutely, this is good sign for TypeScript, I think, that it is being used in so many React projects that a React issue would come so high up in this top 5 kind of list of issues. What I mean by this, and this is something that's like discouraged, but not the worst thing, at least by the React team themselves and the React documentation. What I mean here is by is this idea of setting a handler in a component in React and then binding that handler down here in the JSX itself. If you didn't bind this and just use this.handle click, then the context, the this for the handle click function would be the window object, because that's how scope and context work in terms of events on the front end. And so you have to bind it to the current context, to the current this, so that when we call this.setState in handle click, it actually refers to the component itself. So it is old usage of React. I appreciate that, and I wrote this out as a class component instead of a functional component. But the thing is the same for using an arrow function inside of an on-click handler as well. And the problem is that doing this means that every time this component renders, it's going to bind that function again, or it's going to run the arrow function syntax, which also is doing a bind under the hood. If you do that too many times, we're going to slow down our rendering of components. Now, it is an old issue, and it's even an issue that has gone away from the React docs. They don't even talk about it anymore. But it's, I think, always good to keep on top of mind in terms of performance. It's not something that's probably going to cause you issues at the start of a project or even the middle of a project. But when something gets complicated, and it turns out that because you're re-rendering, you're binding a load of functions every time you render, it's going to be an enormous pain to try and go back and undo all of that in the future. It's much nicer just to bind the function either in the constructor if you're using a class-based constructor, a class-based function, or using a use callback function, use callback hook in a functional component. It's just better to kind of be ahead of that, I think. Building in performance when things have gone slow is much harder than building it in from the start. So anyway, we have comments, we have React getting into the top 5 issues in TypeScript. We get to number 3 now, which gets a little, oh no, number 2, haha. More about comments, funnily enough. And I actually think, so sections of code should not be commented out. Now, I don't really have an example for this. It's just about commenting sections of code out. It's unnecessary. It is in fact clutter in your application. Obviously, commented out code is not going to cause difference in the runtime of that code, but it is more about when you're coming to read and understand that code, that comments or commented out sections of code are going to be confusing. My problem with this is if I ever come across some code which has commented out code in it, I find myself also trying to read and understand what the commented out code does, even though it's not being used in that file at all. So it's adding kind of additional things for me to think about without actually having any functionality. And that's just a bad thing. If you are trying to save code that you previously had in place that has been replaced with new code, then that's what your version control is for. That's what Git or whatever you might be using for version control is for. You don't lose that code when you delete it or replace it. It's back in the history of the file. And that's all we kind of need to consider for this. Don't comment sections of code out. It's just going to make it harder to read that file in the future. Leave it to your version control system to handle, I'd say. Agreed, as in the comments there, if it's commented out, it's not useful, it shouldn't pass code review. Absolutely. These are things that shouldn't pass code review. And in this particular case, they have been committed, and we're seeing that's the #2 issue that I've seen in TypeScript across all those projects. So I'm going to do a quick JavaScript break because I do think it's interesting to see whether there's a comparison between the two, at least the two top 5 kind of issues. And so I'm going to run quickly through 4 of the JavaScript issues just to quick fire round for you, just to show you what JavaScript's talking about. And that's because also #3 in JavaScript is sections of code should not be commented out as well. So that was 2 in TypeScript and 3 in JavaScript. People commenting out code all over the place, apparently. Just use your version control. Now at the bottom in #5 in JavaScript, it's unused assignment should be removed. That is any assignment where the variable gets reassigned to something else later and wasn't used in the in-between, or indeed is used to do some sort of weird assigning to something outside the scope whilst also returning from a function. That's how I've kind of 2 ways I've seen it. Basically, like if it's not being used, if you are assigning something and then assigning something again, that first assignment was useless and it's cruft. It is taking up time and your cognitive ability to understand things. If it is weirdly returning and assigning something outside of scope, that's just confusing as well and it's hard to read. In at #4 is triple equals and double not equals over double equals and not equal to. Hopefully this is something we all understand. Triple equals and not equals use equality of type as well as value, whereas double equals and not equals to are going to try and I've lost the word. Change things types around so that they can try and make an equality out of them. And it's far too confusing to think of how double equals and not equals kind of does that. It's very annoying. So yeah, triple equals and not double equals is the way forward, not for JavaScript. And then one for JavaScript is using let or const instead of var. Like I said at the start, none of these things are necessarily, well, those equal signs might break your program and you're not expecting it, but let and const instead of var are probably not going to cause you that kind of problem. However, let and const are just more expressive than var. Let tells everybody else reading this piece of code that you expect this to change later. Const tells people reading the code that we do not expect to reassign this variable sometime later. And var is just telling you nothing. So for the communication's sake, if nothing else, let and const are a better option than var. Cool, let's go back to TypeScript. I'll come back to what #2 in JavaScript is later, because we'll go back to TypeScript and see out #1 before we get back to #3, because that's the order I like to do things in. #1 gets a bigger pop of confetti there, but it's about unnecessary imports should be removed. Once again, this is not going to break your code. In fact, TypeScript is smart enough that if you don't use an import, when it compiles it, it doesn't bother using the code that is unused. That's cool. Thank you. Thank you very much, TypeScript, for that. But much like commented out code, unused imports are just cluttering our code and make things harder to read. So that's an easy one. Just, do not import and then never use a thing. Get rid of them before you commit this code. And so this brings me to actually my favorite of both lists in TypeScript and JavaScript. It's number 3, my favorite top 5 issue for what goes on in our TypeScript applications. And the funny thing is, this one's not really something we can pin down to one line of code or anything. This is cognitive complexity of functions should not be too high. Woo! And like I said, this is not just TypeScript; it's number 2 in JavaScript as well, and it's absolutely a huge issue for us. And I probably didn't need this much confetti for this, but we can move it on. You might be asking what's cognitive complexity. This is a measure that we actually use at Sona to talk about how complicated code is, how hard it is to understand. Now, you might have heard of a term called cyclomatic complexity. Cyclomatic complexity is something that's been used in the industry for decades, I think. It's been around for a while. And cyclomatic complexity gives functions and classes a score based on how many paths there are through that function. And so, for example, in this sum of primes function, we sum up all the prime numbers that are below the max number that's passed in. And so with cyclomatic complexity, you score 1 because it's a function, and then you score another 1 because we start a for loop. We score another point for a second for loop as we get further down the code, right here. Then we get a conditional, which we score a point for, and then later another conditional, which we also score a point for, giving this function a cyclomatic complexity of 5. So it's not super complex. It's fairly understandable, but you can see that there's 2 loops, nested loops, 2 conditionals. It's got a bunch of stuff going on. Funnily enough, this function here, get words, which you pass in a number and it returns 1 or a couple or a few or many or lots, scores the actual same cyclomatic complexity as our sum of primes right here. It's 5. You get to score 1 for the function, and you get to score 4 for each of the cases in the switch. And to me, whilst it's absolutely true that there are indeed 5 paths through this function and five paths through this function, its understandability, how easy it is to read, is not the same. Get words here is much easier to read. And so that's why we came up with this idea of cognitive complexity. I say we, this is well before I joined Sona. And so cyclomatic complexity measures the number of paths through a function. It also kind of gives you a number of tests that you'd have to write in order to fully test every path through that function. Whereas cognitive complexity is a measure of how easy it is to read a function. And cognitive complexity is worked out differently. It's still a score, the same as cyclomatic complexity, but it creates a score by incrementing or adding to the score every time there's a break in the flow. That is something like a loop or a conditional, as we saw in those previous examples. But it also holds in the back of its mind a nesting score. And that is every time we go into a loop or into a conditional, we're going to increase this nesting score in the back of our minds. And then if we hit another break in flow, it increments the score by 1 plus the current nesting score. Now that sounds a bit complicated, but I can show you how that works back in our example function here. Here we don't start by scoring for being in a function. That's honestly a little silly because we're full of functions here. Getting a score of 1 for every function makes no sense. So in this case, with cognitive complexity, we're going to score 1 point for our first conditional. Our first loop. That's the first for loop there. And now in the background, because we're in a for loop, we also increment the nesting score. So that starts as 1 as well. Then we get to the second loop. Now we're nested and we're breaking. So we score 2 for that one. And then the conditional inside the 2 nested loops scores 3, 1 for being conditional and 2 for being nested twice. Then our final conditional, the if prime there, scores 2 because that's back only nested once. And that gives this cognitive complexity score of 8 to sum of primes. Meanwhile, our get words function scores 1 because there's a conditional, because there's a switch. And because we understand that a switch in a bunch of cases is fairly straightforward to understand, we don't need to score any more points. And so this get words function is clearly more or takes less cognitive work to understand than this sum of primes function. And the fact that this one scores 8 and this one scores 1, I think makes a bit more sense. And so cognitive complexity of functions should not be too high is the issue that we came up with there. And when I say too high, the actual rule that Sonar, at least by default, looks at is a score of 15 or more. 15 or more is actually quite a lot. And so I have an example. In fact, what I have is an example of the, this is the code that is actually spraying confetti onto my slides. This is a Reveal.js plugin. And on the end of a slide transition, we then try and work out if we should throw confetti at the slide. We can see with a little red underline here because SonarLint is complaining that this cognitive complexity of this function is 16, and we just want it to be 15 allowed. Now, I actually think this kind of threshold of 15 is somewhat arbitrary, but what it's supposed to do is, once we get to a certain point, make you come and have a look at a function. And in this case, this function is quite a long one. Like it's good kind of 87 lines long or something. I've hidden some, there we go. There's a bunch of settings in there. They're not super complicated. They're just long. But we have a bunch of different things going on. We've got some hitting the DOM at the start. We have a big conditional based on what kind of confetti we want to do, and 3 different ways to throw confetti on the screen. One of them includes an animation frame. One of them just has a lot of options. And so SonarLint is actually really cool, I think, because what it's done here is if you hover on this and then go into the quick fix section, you can actually go to show all locations for this issue. And that's what these numbers are. It's showing everywhere that it's showing everywhere that cognitive complexity is increasing in this function. I see the comment about light mode. I think light mode is just easier to watch in a presentation than dark mode. I would normally be in dark, don't you worry. So these numbers are showing us where we're increasing the cognitive complexity. So we've got this big conditional around the outside, which gives us a +1. And then we've got a ternary here, which is +2. Everything is nested in that first conditional, which is a bad start. We've got a couple of conternaries who are scoring 2 points each. We've got another conditional, which is setting off the rest of stuff. And then we start doing else ifs. There's ternaries nested in an else if, which is scoring 3 points. And then, this kind of request animation frame, that else. There's a bunch of stuff going on in here. And so the fact that this function is quite long, we're 87 lines long, that's a bad start. That's kind of hard to understand. But also we have a bunch of these things happening inside the function as well, which we could be refactoring to make the whole thing a bit more understandable. Like, for example, this ternary here, we're getting a count. So we're looking at a data attribute on an HTML element, parsing it as an integer, or returning a default here of 200. And we could absolutely just kind of pull that out of there and create a function. That's good stuff. Keyboard had gone to sleep. Create a function called, I have, talking about whether we're all going to lose our jobs to AI. That is Copilot there helping me out and creating me an integer data attribute or default. And so this is going to take the element, the data attribute, and a default, and return basically what we were doing below. And so I can change this particle count now from a confusing ternary to integer data attribute or default, and then the current slide, and confetti particle count and 200. So absolutely AI is taking my job there. If we do that, we've actually see that the underlining on the on_transition_end function here has gone away because we've actually reduced the cognitive complexity to 15, and that's not over 15 now. So that's a good start. And but like I say, this kind of arbitrary threshold allows us to go and say, maybe this has got a bit too complicated. Can we simplify it, and can we simplify it more? So obviously, we have this integer data attribute or default function. We could also, we're also getting a list of an array of colors here. We could have something similar for that. We also extract things like the different ways of producing confetti. And actually, if we did all of this, then we create a function that looks a bit more like this. This on slide transition now still has our big conditional around the outside, but we actually get our defaults from a function which is a bit more expressive. We're getting array from a data attribute or a default. We're getting an integer from the data attribute or a default. And then our 3 kind of conditional here, if we have small confetti, then we'll do the small confetti. If we have a large one, we get another thing out of our data attributes and call on large confetti, otherwise medium. And then we just have a bunch of other functions that we're handing this off to. It's a bit more obvious what's happening in this now kind of 20-line function, as well as these other shorter functions that we can understand better. And so this kind of refactoring has decreased the cognitive complexity of the entire function and the entire file, and we're much lower than 15 now, but we're much happier because we've got this much easier thing to read. So I'm going to go back to the slides and just finish up, because I do think cognitive complexity is an interesting one. Like I said, it's not making mistakes or leaving things behind in comments. This is actually about the way we write our functions and write our TypeScript. If we consider cognitive complexity as something we should always take on board, then we're always considering ourselves in the future when we have to come back and read this again in the future. And so those are our top 5 issues. Number 5 was to-do tags. Again, number 2 was commented out code. And those 2 comment ones I think are interesting because, like I said, they're just cluttering the place. Unnecessary imports clutter the place as well. And whether you believe or agree with the React kind of one is up to you. But cognitive complexity, I think, has been a really interesting point that comes out of here. Now, I am running out of time, so I'll leave you with some tools, and I will send some links around with these slides later. If you want to check out SonarCloud or SonarCube, SonarCloud is free for open source projects, and SonarCube itself is an open source project, which is free if you want to run it. SonarLint is free, and you can install it in your IDE. And ESLint is with its TypeScript plugin is also really useful for these kind of things. And then we have a plugin for ESLint called ESLint plugin Sonar.js, which will also give you cognitive complexity as a score in your projects. There are some of the links. There's a paper that Sonar actually published on cognitive complexity, which I've read a surprising number of times for somebody who doesn't normally like reading papers. So I highly recommend that. Raymond Chen's blog post about reading code more than you write it just makes you feel and think about yourself in the future as you have to come back and write these things. Then there are the JavaScript and TypeScript rules for Sonar. And finally, I have deployed or I have produced the Reveal.js confetti plugin if anybody else wants to throw confetti onto their slides when they give a talk like this. So that's it. I think clean code is going to make us all a lot happier, and cleaning as you code, taking these kind of issues on board and changing them as you come across them in your projects will ultimately leave your projects in a better state. Refactor those complex functions to make them easier to understand in the future, code for readability, and most importantly, just code for your future self. It's going to make you and your teammates and your project a lot happier. So that's all I've got time for. Again, thank you very much. My name is Nash. I'm a developer evangelist, a developer advocate at Sonar. Come and find me online, and I'll obviously be back for questions again later. And thank you very much.
Fantastic, Phil. Oh boy, that was so great. Thank you very much. I enjoyed it. So I enjoyed it, especially because I thought, so I don't know if you saw me, but I was nodding all the time.
Sadly, I can't see you.
Nodding along to the entire story. And what I loved most about it is that basically most of the issues are ubiquitous to programming in general. So you could take the same rules and the same guidelines and apply it to whatever other programming language. And
absolutely. It's funny. I think the cognitive complexity itself was written with Java in mind in the first place. And I think that's been applied to a whole bunch of other things. But absolutely, those other projects, problems and things like that. Well, the React one is very specific, but,
give you that, yeah.
but many other ones, absolutely.
Which is kind of fun. If you look at the others, which are very generic and broad to programming languages in general, which also speak to the idea that programming is more about communicating with other developers rather than communicating with a machine, because then we would all write assembly, wouldn't it?
It's exactly it. It's about people reading it and you reading it, people understanding it.
There's a beautiful paper out there. I'm going to send you that. That is really, really bringing that point home.
I'd love to,
and of all those issues, all about people communicating with each other. And then there's React spine attribute, which is like, oh boy, what did that cost?
Absolutely, it shows its absolute prominence in this in our world at least.
Absolutely,
and it gets in there. Yeah, amazing.
Thank you so much, Phil. So you are here with for the Q&A later on.
I will be back
so
for
we're
Q&A,
going to see each other again. Fantastic. Yep. So for the folks who are watching right now, don't forget to ask your questions to Phil in the chat as a comment. We will answer them in the Q&A session afterwards. And with that, Phil, see you later. See you in an hour or so. And I'm going to put down Phil and put on Deepa. Hi, Deepa. How are you doing?
Hey, hi, Stefan. I'm doing great. It's afternoon here, and I'm really doing great.
Where are you calling in from?
I am calling from India right now.
Fantastic. Oh, boy. We are really spanning the entire globe today. That's great. So good to hear. Cool. Deepa, I'm really interested in what you're going to present today because you are going to show us some of the underrated features of TypeScript. And I also heard that you are writing handwritten notes and sharing them with everybody else on GitHub.
Yes,
which is brilliant.
Right. Yeah, actually, cool. I write notes on like JavaScript, Angular, all web technologies, and it is really useful for so many people. Like so many people have said that it have really helped them in their journey. So it's really great.
Prior to the conference, I took a little peek at your GitHub repositories, and I found it astonishing that they are handwritten. Because I honestly I can't write myself anymore without trying. Needing to decipher my own writing a day later. And it was very clear, very structured. And I had the feeling that you can express much more than just by writing it down in plain text in a text editor. Or something. So,
no, I have started writing technical blogs as well. Like I also enjoy writing that as well. So I'm looking forward to create more courses and more technical blogs.
Fantastic. From now. Really. So now I'm really looking forward to your talk. Did you already put your slides on screen?
No, I'll be presenting it now.
Cool. Let's give you a few seconds so we can put up your slides as well. One, two clicks. I'm closely watching the monitor. Oh, and by the way, we got lots of applause and lots of comments for Phil's session. Everybody was talking obviously about type coercion versus value checking, which is always a great topic, isn't it? And I have to agree with Phil that I'm also a light mode presenter. So people, if you are at the real world in-person conference, people at the very back are going to love you for having a light theme when you're going to show programming examples.
Yeah. Should I share my screen now?
Yeah, you can share your screen, because once you share your screen, I'm going to put the screen up, put myself down. There you go. Fantastic. So, and with that, Deepa, thank you very much for being with us today. The stage is yours.
Okay, thank you, Stefan. So, hello everyone. Myself, Deepa Chaurasia. I am front-end engineer at Vite Systems. And today I am going to be discussing about underrated features of TypeScript. So basically, like why we use TypeScript at the first place, to make sure that our code is type safe, to make it more reliable. So today I'm going to be discussing some of the features of them only that is going to help you.
Deepa, one second, sorry. I'm sorry to interrupt. We are seeing your screen, but we're seeing the backstage. We're not seeing your slide. Can you please try to reshare with your slides?
Wait.
Sorry for interrupting you.
No problem.
And this is totally understandable because you usually have lots of windows open, don't you? Alrighty. So now we are again seeing the Geekle backstage. There you go. There it is. Fantastic. Alrighty. And I'm off screen and let you continue. Thank you very much.
Thank you so much. So again, hello everyone. I'm going to be discussing underrated features of TypeScript today. So what we are going to discuss today, first we are going to discuss generic function signatures. Then we are going to discuss type guards, then interfaces, enums, and union. So in like while we are writing a function, we want it to have a specific type, like we want it to be a generic. So for that, what I am going to be discussing generic function signature itself today for it. So first of all, why do we need generic type at the first place? So for that, we will see here, in our code, I have created a, so for in a code, I have created a job run type. So in job run type, we are having the job, then we are having a state, and then we are having a on complete callback function. So it is right now, if you see that our job is of any type, and then in on complete also we are passing a parameter, and the parameter is also of any type. So if you see here, then I have first declared a job run type. Okay, and right now this job could be of any type, like I am not specifying anything here, I am not putting any constant here. It could be literally of any type, that's why I have declared it to be like this, any. But generally when you're writing the code, it is not advised to do it like this. We are going to be discussing that why it is not advised to do it like this, why do we need to write it in a specific way only when we are talking about the generic functions. So in this, if we see, I have created this job run function type, and then inside this I have created a function enqueue job. Inside this also I am passing this job which is of job run type. So these are the jobs that are going to be run anyway, and it is also of any type. This is also of any type, and we can write our some logic here, and then we are returning this here. So it will be of job run type. And inside this also, if you see, then we have this job name, and then we have this state, and then we have this on complete callback. Inside the callback, if you see, then also we are using this job is of any type as well. So now if after that, what I am doing here is I have created this send email job, and in send email job uh, I have created this send email job property. Inside this object, and inside that I am passing the recipient email property and then the subject property. And then I am calling this enqueue job function itself, and I am passing this property, job property I have created inside it. Okay, so it looks perfectly fine, it will work perfectly fine. So if I am calling this this run is storing an instance of enqueue job. So if I run it, if I call the callback function on complete, and I'm passing the job here, so if you see, so it will work like absolutely fine. But if I am trying to call anything here, like if I want to know that, okay, what is inside this job, what we have called here, like what is inside it, there's no autocomplete here, there's no information of the properties that is present inside the job itself. So for that, what we require is generic function. So our code should be generic. If a developer is writing the code and he is working on a specific, like he is writing some code like this, that he should be able to figure out that what property I can assign here, what property I cannot assign here, what are the constants here. That is specifically very, very necessary if you are writing the code. So for that, what I can do here is, first of all, I can give my job run a specific type. So let's say I'm giving it a J type. It will be of the J type, okay? Yeah. So if our job run, let's say it is of a job J type, so I am passing this J here as well. And then I am going to make that change here as well. Then it is enqueue job is giving us the error. It is saying that generic type job run requires one type argument. Now that we have defined that inside that job run, it will be of J type, it will be of a specific type. While we are using it inside our function, there also we have to define that, okay, it should be of specific type, what type it is. So I am defining it here. So I'll just copy it from right here. and I'll paste it here. So you see, here I have defined that it will be of J type. Wait a second. So wait a second, like it is throwing this error. I resolve it right now. Let's write it again. So first of all, we are having this NQ job. So it is we are passing the parameter of job J type. So it is passing the it is of job run. So what we are doing, we are creating a function NQ job. Now it will be of a specific type that we have defined earlier. Like we have defined that our job run will be of J type. So we have defined it here itself. So we are defining it like this, and then this AI is doing it work and it is defining it on its own. Then it's of job run type. So basically, it is going to be of job run is going to be of J type. Yeah. So it will be of job run will be basically of J type. So we are going to define that on complete. So first we have to define that, okay, it will not be just of a specific type. It should be of a specific type. So I'm going to define here J, and this job will also be of J type. So it will be of J type. Yeah. So I have mentioned it. I have mentioned the T here because it can be of any type. Like it's not necessary that it will be like I have defined that it will be of J type. You will see later why it is like this. And here inside InQ job, I have mentioned that it is of type T. So like it can be of any type, but we will see what significance it is having here itself. So we are returning the job here. So if I pass the this of string here, then you will see that it should throw the error. So if we see here, then we have this job, this state, and this any. Then we will set it to also J type. Sorry, T type. Then we have this send email job. Inside this, we are passing the two parameters, recipient email and subject. In recipient email, I am sending the, I'm setting the email, and then in subject, I am also setting a string. Then we have const run. Inside run, we are passing a function. Inside function, we are passing the J type, we have defined it. Then I am passing the callback function on complete. Inside this, I am passing the job. So if we see here, then job will be able to, then here also job will be able to access the recipient email and subject as well. So for this case, what we do is we create like what we do is what I intended to explain is like we have to specify a specific we have to specify that our function is of a specific type, and it helps to make our function more reliable and helpful. Yeah. So next we have generic function signature. Typescript generics is a technology that allows you to make reusable components. It generates a component that can operate with many data types rather than just one. So generics ensure type safety without sacrificing performance or efficiency. So our why we use generic at the first place, most important, it is because of type safety without sacrificing performance or efficiency itself. Then next, how to use the generic functions. So here you can see I have created this interface generic ARR length. It is of any type, like I can pass any type here, and here also ARR is of type array, and it is returning a number. So we can see here that get ARR length is of generic ARR length function type. So inside this, we are passing ARR of any general type. Then we are having this number, what we are defining here is inside this function. If we pass any array inside this function, if we pass any array, that it can be of any length. So inside get ARR length, I have passed I have passed the string. So if it can be of string, it can be of number, it can be of boolean as well. So you see that here I have expressed the length of the array itself. I'm sorry for my throat. I don't know why. Then we have type guards. There are 5 major ways to use a type guard. First is instance of type guard. Second is type of keyword. And then we have in keyword. Then we have equality narrowing type guard. Then we have custom type guard with predicate. First is the instance of guard. So what instance of does is instance of is an operator that checks if an object is an instance of a specific class or a constructor function. So here you can see I have declared a variable a. It is of string type. Inside this we are passing the hello world function. Now we are checking whether this a is an instance of string or not. It is an instance of string, that's why it is returning us the true. It is returning us true. Next we have type of. Type of is a keyword that is used to differentiate between different types in TypeScript. So first we have a. It is of string type. Inside this we are passing any string, and what we are doing here is we are checking that whether this a, what is the type of this specific string. So it is of string type, so therefore we are seeing the string as an output. Next is in keyword. In is a JavaScript operator that can be used to check whether a property belongs to a particular object. So here I have created an object name, and inside that we are passing two two properties. First is first name and second is last name. So we are checking that first name is present inside this name object or not. So here we have seen that, okay, first name is present inside an object, that is John. That's why that's why it is returning us the true. Okay, so in is a JavaScript operator that can be used to check whether a property belongs to a particular object or not. Then next we have equality narrowing type guard. Two variables must be of the same type in order for them to be equal. If a variable's type is unknown, but it is equivalent to another variable with a known type, TypeScript will use the data the well-known variable gives to restrict the type of the unknown variable. What I am trying to explain, let's see with the example. So first we have function sample. Inside this, I am passing this two parameters. First is the x parameter, second is the y parameter. In x parameter, we have number. It can be of number type or it can be of string type as well. But then second, y is only of string type. So what we are checking here, if x is equal to y, in that case, your type of x will be string. So what we are checking here is like if y is string also, okay, and if x is also string, if they both are equal, then TypeScript will automatically find out, okay, this is also a string. And if they are not equal, then it will be saying that it could either be a number or string. So basically it is just TypeScript ability to automatically find out whether a variable is a number or a string on the basis of data you are giving it. Next, we have custom type guard with predicate. So the least effective method of employing type guards is normally to create a custom type guard. There are no restrictions on what may be checked when you write your own custom type guard. However, if the custom guard is written improperly, several mistakes may result. Therefore, accuracy is very crucial. So here we have mentioned, like here what I have done is I have created this tires interface, then I have created this battery interface. Then inside this type car, I am passing that this car will be of tires interface as well and battery interface as well. Then I am checking, then I am passing this car and then checking that return be tire.color is not equal to indefined. So I am kind of doing it like this, like type car, then color black, brand MRF, and it will check that whether is tires and inside is I'm passing the battery, it will check that whether it is present inside it or not. So basically if you are writing your own custom type guard, you have to be very careful towards it. Next we have interfaces. It is a structure that defines the properties and methods for objects with names and types. So like we create a generic function. So generic function is also for type safety. Similarly, we have interfaces as well. In interfaces also, like we create a function. We create like we take several properties. This and we define the type of the properties already. So it is a structure that defines the properties and methods for objects with names and types. The interface is available only in TypeScript code. When it compiles JavaScript code, its existence disappears and doesn't make the final source code heavier. We use an interface in our code when we want type checking, but the code should not be bulky. Okay, so let's see here in an example. I have created an interface product. Inside this, we have name, price, quantity, and say total, 4 properties. So name is of type string, and then price is of type number, and quantity is also of type number. And next, I am having this variable item1, and it is also of product type. Inside this, I am passing this name, price, quantity, say total. So if I have defined an interface that my name will be of string type, then I have to pass it of string type only. If I have defined it here that it will be of number type, then it should be of number type only. Similarly, all of this should follow the constants that we have defined in the interface earlier. So we can access the properties we have defined inside this object like this only. So that's what I have mentioned here. So basically, interface is basically to define the type of a property, and we are fixing the constraint here, so that while a developer is writing a code later, or we are writing a code later, we already know that okay, it is of specific type, and only this specific type will work out. If we are not giving that type, then it will throw the error. Next, we have interface as function type. A function type has two parts, parameters and return type. When we declare a function type, we have to specify both parts with the following syntax. So let's say we have this add type here. Inside this, I am passing the two parameters. First is the x and y. Both are of number type. So it will return the number itself. So here we can see that we have passed these two parameters, both are of number type. We have already defined that what type of parameter we want, and we have already defined that the result it will give, what type of result it will give also. Next, we have enums. Typescript enums allow you to define a set of named constants. Using them can make it easier to document intent or to create a set of distinct cases. So basically, when you are using enum, it allows you to create a set of property. It basically, if you want in your code your like variable name to have a specific uh, specific like documentation intent, for documentation intent, and to create it, to maintain it efficiently, then in that case we use enums. It saves compile time and runtime with inline code in JavaScript. Then it allows for the creation of memory efficient custom constants in JavaScript. So basically, it also supports the memory efficiency, and it saves the compile time and runtime as well. Then next we have the numeric enums. So in numeric enums, what happens is here, if we see, we have this enum direction. Inside this, we are passing this up, down, left, right. So above we have a numeric enum where up is initialized with 1. So all of the following members are auto incremented from that point on. In other words, direction up has the value 1, down has 2, left has 3, right has 4. So in numeric enums, it automatically keep incrementing afterwards. Next, we have string enums. So inside this, if you see, then enum direction is having this 4 properties, up, down, left, right. So while string enum don't have auto incrementing behavior, string enums have the benefit that they serialize well. String enums allow you to give a meaningful and readable value when your code runs, independent of the name of the enum member itself. So here you can see that it is like, if I have set it in a specific type, so while I am using it inside my code later on at some place, then it will be much more convenient. Then enum members also become types as well. So here if we see, then we have this enum shape kind. Inside this we have circle and square. Then we have interface circle. Then we have interface square. Okay, inside this we have this kind and radius. Then if we see, then that C variable that is of type circle, inside this I'm trying to access this kind, then it is going to give through us the error that shape kind dot square is not assignable to type shape kind dot circle. So enum members also become type as well. We cannot assign anything to anywhere. It will be according to what we have defined only. Enum times.
Deepa, a quick reminder, we have about 4 to 5 minutes left. So just that you know how you can plan your talk.
Yeah,
Right.
sure.
Cool.
I'll try to make it quick. Then enum types themselves effectively become a union of each enum member. With union enums, the type system is able to leverage the fact that it knows the exact set of values that exist in the enum itself. Because of that, TypeScript can catch bugs where we might be comparing values incorrectly. So here that's what it is happening here. We have this foo bar, and then inside this function we are passing this parameter, and then this comparison it will automatically give you the error that this comparison appears to be unintentional because the type e.foo and e.bar have no overlap. Then next we have reverse mapping. In addition to creating an object with property names for members, numeric enum members also get a reverse mapping from enum values to enum names. If you see here, like inside this a variable, I am trying to access this a, so it will be like enum.a. But inside this next variable, if we are trying to access this enum, like if I'm trying to do it in a reverse way, if I'm trying to do it with enum a, then it will return this capital A itself. So this is called reverse mapping. This also is in TypeScript. Next, we have union. So TypeScript may combine one or two separate types of data, such as numbers, strings, and so on, into a single type known as union type. Union types are an effective means of expressing a variable that has numerous kinds. So using the pipe symbol between two or more data types, they can be merged. I'll show you it. So here you can see that we have so many types, like there are many types. We can do it inside like this using the union. So we have, let's say we have this demo one variable. Inside this we are creating this of two, like it can be of number type, it can be of string type according to your requirement. So here I have passed the number. So you can see that exact numeric value is demo one. So you can see it here, we have 49, and I can also pass the string inside as well. So in the second case I have passed the string. So that's how you use the union. Next, code size difference. So once TypeScript code is converted into JavaScript code, the code size will change. So the use of string literal unions will reduce or have no effect on the size of your code. However, using enums on the other hand will increase the code size. So we want to keep this in mind before before using unions in our code. So yeah. Thank you, everyone. I hope you have learned something new. Yeah.
Fantastic, Deepa. That was on point. Sorry for interrupting you a second earlier, but fantastic. I enjoyed the talk a lot. Thank you so much, especially seeing string enums, which I usually tend to avoid nowadays, in this new kind of context that you can use this as a discriminator with the kind property. That was quite interesting to me. So I knew that it was possible. I never used it actively, and seeing the kind of thing is always nice. So cool. All right, Deepa, I'm sure you are with us in the Q&A afterwards.
Yeah, definitely.
Yeah,
I'm
cool. So for everybody who has questions for Deepa about the techniques, about the things that she just showed, just put them in the chat, put them in the comments. We are going to collect them afterwards, and then we have a broad panel discussions with all participants. I'm really looking forward to that. So Deepa, I guess we see each other in half an hour.
Yeah, sure. Definitely.
Thank you for your talk. Alrighty, and with that, we move over to our first recording of today. So the next speaker is Arman. Arman works at Rabobank. Arman is a senior software engineer who has started his TypeScript journey a couple of years ago. And his goal is to utilize TypeScript to its full potential. And I'm using TypeScript now for 6 or 7 years. I'm very curious what the full potential is supposed to mean. So folks, give it up for Arman, who is going to start in just a second.
Hello everyone, and welcome. Thanks everyone for attending my talk today. My name is Arman. I'm a software engineer with extensive experience with TypeScript and on various projects. So I've gone through the journey from Pascal and Delphi, C++, Java, and finally TypeScript and JavaScript. At one point, I was a co-founder and CTO of a successful software as a service startup company. In the last 5 years, I'm focused on mostly fintech and banking industry, building banking experience for well-known banks. And yeah, a long time ago, I was also a semi-finalist of ACM programming contest. So we all love TypeScript, which is a superset of JavaScript, and it's gained popularity and because we enhanced type safety, improved tooling, and so on. but the focus of our talk today will be finding the ways of utilizing TypeScript in a way that it produces more clean and concise code. But yeah, because it's crucial for software development. Why clean code is good? Because clean code enhances maintainability, making it easier for developers to understand and modify the code base. Also, it improves readability, making the efficient code reviews or easy onboarding of the new team members. Also, and finally, of course, reduce the likelihood of bugs and errors, resulting in more robust and reliable applications. So what we'll be covering, we'll be mainly covering 3 topics. One will be mastering the generics. We'll dive deep into the concept of generics and how they improve reusability and flexibility in TypeScript code. Then we'll be leveraging decorators. We'll learn about decorators and their power of modifying the behavior and adding some functionality to classes, methods, properties, and so on. And finally, third, we'll cover conditional types. We'll discuss the benefits of using conditional types in to simplify complex logic type and enhance the code readability again. While we'll cover those, we'll learn and review it based on examples. We'll see lots of code samples. We'll go from the basic example to more advanced and then to the real world example. Also, along the way, we'll cover best practices. So this is not a theory based. We can all read theory from documentation or from the internet, but while looking at the exam codes, understanding this code, we can kind of grasp the concept of those 3 TypeScript features. Let's start with generics. So in this section of generics, we'll explore the powerful concept of generics in TypeScript. Generics are a way to create reusable, flexible components, for instance, class, interface, and so on, without sacrificing type safety. So by using generics, we can write code that can handle different types of data, meanwhile maintaining the type information. So let's have a look at the example. Yes, as we said, in this example, we'll look at the function that uses generics to handle different types of input while maintaining type safety. So the identity function, a basic identity function, is defined with a type parameter t. You can there in those brackets, and this allows it to work with any specified type while maintaining type safety. But more on this later. Then the type takes a single arguments parameter, and its type is t, and it returns value with the same type t. And inside the function, we're not doing anything. We're just directly returning without any modification to CMARC, but we can have any logic there. So by using the type t there, the function can work with any type of arguments while ensuring that the input and output types are the same. So if it takes, I don't know, string, it returns string. If it takes some object, complex object, it returns the same object, the same type. So this is the example how how to use the identity function with various data types. So the identity functions here showcase the flexibility, the type safety provided by generics, and it can work with different types. So basically, we reduce the coped duplicate, for example. Yeah, but more on that later as well. So this is the basic example. So generics is this t, where we put t like a variable, and then inside, then we can return the type, or we can even extract something, but more on that on the second example. So let's see how generics can be applied to classes and interfaces. In this TypeScript code, demonstrate the use of generics to create flexible and type-safe stack data structure. So yeah, if we look at the code, this is a simple class called stack. Is defined with a type parameter t. In the first line, you can see this allows it to store items of any specified type. So we have a private items property is declared as an array of type t. So yeah, it's this will be used to store the stack's elements. Then we have a function method, push, which takes item over type t, an argument that adds to the array. Then we have a pop method that removes the last item from the items array and returns it. Yeah, effectively popping the item from the stack. And if the stack is empty, the method returns undefined. So yeah, and if we use that class further, although we created 2 instances of the same class, for example, number stack and string stack, they're both classes, but they accept values of different types. A number, for example, for the first one, and string for the second one. And then it also pops back the type. And if we check the type, it returns number or undefined or string or undefined. And this example showcases how generics can be used to create reusable and type-safe classes and interfaces that work with any specified type. Also, let's jump into the real use case, the code that I see quite frequently at daily work is a library for handling API responses. Can use also generics to ensure that that it's flexible enough to handle any kind of response. So first of all, here, by the way, here we'll be using the generics in both interface and function. So let's start with the interface. So we have this API response interface is defined with a type parameter t again in the beginning. This allows it to represent an API response containing data of any specified type. So data can be anything, any data type that we pass when we create interface. Then the interface has 3 properties: data of type t, success of Boolean, and optional message of a string. Then, so basically this interface. And then here we create a function. The API request function is defined also with a type parameter t. This allows it to work with any type of specified type for an API response data. And the function takes a single argument string, then it returns promise that resolves to an API response with the specified data type t. So here we also take generic t, and then we return promise that returns an object that is confirming the interface. And we pass that t further to the interface. So the data up there can be over type t. Yeah, then remaining of the function is inside the function we fetch method using HTTP request for the given URL. Then response then is parsed to JSON, and the function basically returns an object conforming to the API response interface, the one on top, including the parsed data, the success flag, and status text. So yeah, this is quite useful and quite frequently used code. So this API response and API request can handle any API call. And yeah, I mean, the concept of generics looks simple, but if you truly understand it and use it wisely, it's really beneficial. Coming to the benefits, what are the main benefits of generic? Are improved code reusability. So because generics allow us to create a single component such as function, class interface, or anything that can work with different types of data, reducing the need for duplicate code. So we define it once with generic type, and then we can reuse it for number, for string, or for whatever. So we have less duplicate code. Then the second is enhanced readability. With generics, the intent of the code becomes cleaner as the relationship between types is explicitly defined. So making it easier for other developers to understand the purpose of the component. Like in the last example, I think it shows it. And better type safety. Generics enable us to maintain strong typings throughout our application, reducing the likelihood of errors due to incorrect data type. So yeah, I mean, we can be, if we type as much as possible, we get the bugs or possible errors due to data types earlier in our IDE, not later, like in production. And the key practice, like a takeaway from here, is generics can greatly improve code reusability and type safety, but overusing them can lead to unnecessary complex code. So we should use generics only when they provide clear benefit without sacrificing the readability. Yeah, so overusing it is also a bad idea. So we should use it wisely. So here that's done for generics. Let's jump into the second concept of decorators. This is a bit more advanced than generics. So we'll explore decorators, a powerful feature of Typescript that allow us to add functionality or modify the behavior of classes, method properties without actually changing their code. So yeah, let's cover the type decorators. They can be applied to class constructors for the class decorators. They can be applied to method declarations for method declarations. The same for property, applied to property declarations. And lastly, it can be applied to the method parameters for the parameter decorators. So so decorators basically are used to simplify code, improve readability, and it helps to encapsulate the logic of behavior modifications. So more on that on this example. So basically, TypeScript itself doesn't have any built-in decorators, but popular front-end libraries and frameworks, for example, Angular, they used it a lot. And in this example, we'll look at the decorator read-only, which is, we'll basically emulate and rebuild this decorator read-only. So so basically in the framework, when we use read-only, we use like at read-only. And to create a decorator, this is the standard syntax. We create a function that takes 3 parameters: target, property keys, and descriptor. Then inside, for example, for this one, inside we inside the function, the writable property of the descriptor is set to false, which prevents methods from being overridden. Then we create, for example, my class, and class has a method named called my method with some that simply logs some message, and then the read-only decorator is applied to this method and makes it read-only. So basically, if we have this decorator read-only in front of the method, then the method becomes read-only. So basically, the read-only function is applied to it. And then, for example, after creating an object, we attempt to override it with my method equal to some function, and it results in a runtime error as the method has been made read-only by a read-only decorator. This example shows how decorator can be modify the behavior of the class, of a method, in a clean, reusable manner. So imagine if we had to like write this descriptor, something logic inside the class, then we had to write it again. But here we just declare the decorator once, and then we just add that. And to understand it more, to understand it better, let's view a bit more advanced example. So with building a custom decorator. So let's create a custom decorator to address a specific use case. So for example, consider this following log decorator that logs any method call. We don't care about the method itself. So we create the log function, decorator as a function. So it takes, again, 3 parameters, target, property key, and descriptor. Inside the function, the original method is stored, so to original method variable. So we don't want to lose that, the actual method. And the new function is assigned to that descriptor value. And in the new function, it logs a method name and its arguments. Then it calls the original methods with the provided arguments, of course, using the apply function there. And then after after the original method is executed, the result is logged and the result is returned. So afterwards, for example, we have my class, which has, again, add method, which is simply a plus b. And then we add this log decorator. And then when log decorator is applied to this method, which causes log function to be executed each time the method is called. So basically, when we call add, for example, here, we create object, we create instance of my class, then we call add 2 plus 3, and then this function not only returns 5, but it also prints the following, like calling add with arguments 2 and 3, and add returns 5. Those 2 logs would be logged. So this custom decorator helps us add functionality, logging in this case, to a method without actually modifying the original implementation. So you can see we have my class and we didn't modify it. We just added this decorator and its logic has completely been modified. So by using this custom decorator, we can simplify our code and improve readability. So it's, again, makes it easier to other developers to understand and maintain. And let's jump into a real use case. For example, decorators are being used in Vite framework to add authentication valid logic to route without modifying the route's handler code. So let's just quickly run through this code, because this is the actual code from web framework. And let's have a look at it. Oops, sorry. So the auth function, again, is the decorator factory, the function auth. Then it accepts the require role argument and returns the decorator function that takes 3 arguments. Again, target, property, and descriptor. Then decorator function replaces the original method with a new function that first checks if the current user has the required role. If not, an error is thrown. If the user has the required role, then the original method is called with the provided argument. And then here we actually create an API controller class that contains method delete user, and that should only be accepted with user that has admin role. So we have a decorator auth admin, and then this auth admin decorator is applied to the delete user method. This ensures that only the user with admin role can use this method. And the key takeaway from here is decorators are powerful way to add functionality or to modify behavior without changing the code of the classes. methods and properties. So we should use decorators to encapsulate only the reusable logic and keep our code base clean and maintainable. So also here we should be balanced. We should not put everything to decorators. We should only put highly reusable, the logic of the logic that is repeated many times in the code, then we put that one. For example, in our case, the logging, then checking the admin role, and so on. But we don't overuse it. And lastly, the conditional types. Conditional types are powerful. Conditional types are a powerful TypeScript feature that allows us to create more expressive and flexible type definition. Conditional types can be used to express complex type logic in a more readable and maintainable way, simplifying our code and improve the type safety. But what is conditional types? Conditional type is this. Normally, T extends U, X, and Y. So the T is the type that is being checked. Then U is the type that is being compared to. X and Y are the types to be returned based on whether the condition is true or false. And just like ternary operators. Let's have a look at some examples of using these conditional types. And let's start with a basic example. So here's an example of using conditional type to determine the return type of a function. So we have here a return type. Alias is defined in a conditional type, and it takes a single type parameter T and checks if T can be inferred as a function type. If so, it extracts the return type of that function, which is R, and returns R. If not, it returns to the never type. So yeah, so basically, if it's a function, then it returns what that function returned, the type of it. Otherwise, it returns never. And for example, here we have two simple functions, which is add and another add. One returns number, another one returns string. And then when we apply, so basically then add return type and is applied to, the add return type alias is created by using the return type. And then we can see that in this case, the return type resolved to a number for the one, and for another one, it returns string. So basically it checks the function, because one function returns number, it returns number, another function returns string, it returns string. So this is the basic concept. Then this example also demonstrates the power of conditional types in expressive complex type logic in a quite readable manner, I think. Then let's deep dive into a bit more advanced usage. We'll look at the example of where condition type demonstrate their flexibility and expressions in handling type manipulation scenarios. Let's see. We create a utility type called unwrap promise that extracts the resolution type of a promise. So unwrap promise type checks if T is a promise. If it is a promise, then extracts the type that promise resolution using the infer keyword. In previous, we also used it. And then if T is a promise, then it returns, if T is not a promise, then it returns T unchanged. So basically, it unwraps, if it is a promise, then it unwraps it, returns the type that the promise resolved to. If it's not a promise, then just returns type. This is a small utility function. Then we, for example, use function. For example, we create a simple async function that returns a promise that result to string, and when we use that unwrap on that one, and we use return type, so we have a combination of this and previous one, then we have a type string. And let's move on. So a bit more use cases. These condition types are also used to create utility types for advanced type manipulation, such as here for tulip, for excess types of tuples and the keys of an object. Okay, let's go one by one. So the tuple element is a utility type that takes a tuple type T as argument and returns the union of its element types. We can see, and T is an indexed access that type that retrieves the union of all. So basically, if it takes, for example, we create my tuple and we apply, for example, we have string number boolean, then it returns those 3. And the same for the keys. You have this slide, so you can have a look at this example. I will not go deep into it, but basically here is a little bit more complicated usage of conditional types here. And what are the best practices or takeaway from here is conditional types can make a complex logic more readable and maintainable. And we should use it to express type relationship and manipulation in a clear and concise manner. So yeah, that's it. We have covered over 3. Then let's wrap up what we have covered so far. We have explored some advanced features of Typescript, such as generics, decorators, and conditional types. We have discussed how they can be used for writing code cleaner and how it makes our code more concise. We covered some of the real world example scenarios and the best practices. And hopefully now you're better equipped to tackle some real scenarios. You're ready to make your code more concise, more readable, less duplicate. And in general, these 3 concepts, they seem to be simple, but the more you dive deep into the usage of it, because it's so simple and kind of generic, easy, then you can build amazing things with it. In the examples and scenarios, we covered just tip of that iceberg, but yeah, the more you do research on it, the more you read it, the more you use it, the more you use it as the more you practice with it, the more you use it, the more amazing results you achieve. So thank you very much. Hope you enjoyed it. I'll be happy to answer your questions. So thank you very much again, and I'm looking.
Alrighty, hi everybody, we are back again. So this was Arman's talk, and now we are going to open up our Q&A, and I want to welcome every speaker that has spoken so far back on stage. So we start with Phil. He's in the earliest times when he needs to go to back. So welcome back, Phil. Great that you're here again.
Good to be back. It's getting darker.
It's getting darker, yeah. So it's getting brighter here. So we are reaching 2 p.m. So it's now going to be the hottest today, and it's a beautiful spring day. So you should come over, by the way. So if you have nothing to do on the weekend, just fly, I don't know, 20 hours.
Thereabouts.
Cool. And next we have Deepa also coming back on stage. Hi, Deepa.
Hi, Stefan.
And now directly from the video, now he's on stage in person, one shave later. Here's Arman. Hi, nice to meet you, Arman.
Hi. Likewise, nice to meet you guys.
So, by the way, Arman, where are you calling in from?
From Amsterdam.
From Amsterdam, fantastic. So how's weather in Amsterdam?
It's raining as usual.
As usual. Cool. So first of all, for everybody who has been here, thank you for your talks. I have watched everything, and it was very interesting and very exciting for me to listen to your talks on clean code, concise code, on development technologies, on advanced types. And also the people in the chat have discussed a lot, and we have collected some very interesting questions. So, I mean, I could go through basically pick one question and ask the speaker directly, but I would rather have you engage in a little bit of discussion around this topic, if that's okay for you. Maybe throw in a little bit of my questions as well, because I'm always very curious when I meet TypeScript developers. So one thing that popped up in my eye immediately were some questions from Deepa's talk, and I'm going to show it to you, around naming interfaces. So Deepa's interfaces sometimes were lowercase, sometimes were uppercase, sometimes did have camel case notion. And I wonder, so one question is, would it be an error? I guess the audience would be very interested in that. And then another question would be, what's your preferred style on that? So maybe Deepa, since it's directed to you, maybe you start.
Yeah, like most of the times I prefer like using the uppercase as well, only like it really maintains the code readability well. But yeah, like I think uppercase would be great. Camel case might be an issue, but I think we should not use it often. But yeah, uppercase, I think that we should use more often.
I wonder if Sona has an opinion on how to name interfaces and functions and whatnot.
Yeah, absolutely. I mean, I think it's all part of like any linter or code checker or things like Sona will have their opinions on that kind of thing. And yeah, absolutely. I think it's Pascal cases, capitals, and then camels afterwards, right?
Yeah, exactly.
Yeah. Always too many names for these things, but Pascal case I think, for interfaces, for types, for classes. And then camel case for everything else is, I believe, the rules that we like to put down, but also tends to be how I like to do things as well. Yeah. So at least I agree with my own tools, so I'm happy with that.
So the fun thing is I've been doing lots of JavaScript, and prior to that Java and C#, and now I've done a lot of Rust in recent years, and they prefer to use lowercase snake case for their function names. And it was really tough getting into this new naming convention, if you know what I mean. But then again, once it's stuck, I'm now cluttering all our TypeScript code bases as well, also with snake case. And I don't know, I can't figure out which one I like more, which one I think is more readable. And so now I'm, after, 25 years of programming, I'm in this weird state that I don't have an opinion on how to case your function names again.
I've been through that, as I used to write JavaScript and Ruby next to each other, and Ruby again is snake case for.
It's also snake case, yeah, sure.
Yeah,
Rust takes a lot of influence from Ruby. That's true. Yeah. So I guess one idea would be to say, well, go with whatever the tooling tells you to do. Go with some regular convention. Don't spend too much thought on it, because somehow the community has already figured it out in some way.
The only thing maybe to add from my side is I think it's quite popular to have the capital I for the interfaces.
Oh, yeah.
So I think it's the thing of the past, and well, of course, it's the matter of taste, but I really prefer not to use I, because it's like repetitive and it's everywhere. So I agree with Pascal case. I think it's the best.
I guess the capital I comes from the C# and .NET side, if I remind myself correctly, which is a very good reminder that some people do that in TypeScript code as well. Given that basically the same crowd started TypeScript that did C# for a long time, I guess it just makes sense. But this brings me to another question the audience has asked, which I guess is also something that we can discuss together here, is if everybody in here is aware of the difference between a type and an interface. So what are the differences? Are there any? What would you prefer, and why would you prefer it? Maybe we start with Phil because he's already scratching his nose.
Do you know, I tend to prefer to use types, and that means I forget what the difference is. I believe it's down to you can extend interfaces. Is that right? That's actually one that as I say, I lean to types pretty much all the time, just because I find them easier to kind of handle myself. But probably better ask somebody else.
Yeah, what about the others? So maybe Arman next. Arman, are you with us? Can you hear us?
Sorry, I was finding the unmute button.
Okay.
Well, actually, I also can't remember right now, like what's like all the points of difference. The thing they differs in terms of syntaxes, and I tend to use both. And yeah, it's just after using it so many times, it just gets natural just using one of those. But in like most of the cases, I tend to use types more. And when describing like the API kind of the responses, requests, and it's more of a interface. So yeah, I would say interface is more of declaring, like the name says, interfaces, and while type is basically using locally, like like creating additional type like string number, and then you need some additional. So that's more of a logical separation, conceptual, but in practice, of course, you can use both in both cases.
And what about you, Deepa?
Yeah, like an interface also, like interface and type both does the same work only. So most of the times, if I am writing the program, so most of the times we use interfaces because we can like use it very easily in our code. But yeah, it totally depends on our choice, like what we want to choose between us. Both does one and the same thing only.
So, it is my understanding there is one really big difference that Phil already mentioned a little bit, which is declaration merging. So you are able to write an interface and then just create the same interface again, and TypeScript will pick up both and create one interface out of it, which is does make a lot of sense if you have it in one file. But if you have a global interface, like let's say form data, you can slap on new properties as you see fit, or the window interface and things like that. And I found out that when I was consulting folks on the TypeScript code bases, that they had some naming conventions that were similar to the global interfaces from the DOM, and they were clashing all those times with the global. So having a type there tells them immediately to pick another name, to write something else. So they are always kind of the safer bet if you just work within your boundaries of a project. But if you have, just as Arman said, if you are declaring an interface to the outside, maybe you want to have them as open as possible so you can merge together from different and various sources. And I've always found this interesting that TypeScript has this feature, because I can't think of another type system that has it first. But then again, it makes a lot of sense if you look at what they are doing, that they, for example, prepared jQuery to be extended with plugins so you can slap on more interfaces, and people just need to redeclare the same interfaces as there was, and then the same functions are there again. So it's kind of made out of what TypeScript's goal was, mainly trying to make JavaScript in any way usable. Cool. We have a couple of more interesting questions. So we spoke about enums. So maybe if one of the speakers or all of you could explain what the specific use case for enums would be compared to alternatives, because it's a broad programming language. TypeScript has many ways of expressing oneself. So why would you use enums over, let's say, string union types or something? Who wants to take that one? Anybody interested? Yeah.
So like when we are using union, in that case, like your code might code bundle might increase. Like in case of enums, code bundle might increase because when we compile it, then in JavaScript, a more sizable bundle creates when we are using enum. However, if we are using the other, like if you're using union, in that case it will be way more better, because it does not increase your bundle size. So if in that case, like we prefer enums most of the times, because to make our code more usable, because it is more easier to access a variable through the enum, because it is usable, universal. But if we see the bundle size, then in that case, like enum increases the bundle size, but also it is very useful, so we can't really avoid it.
I have one anecdote, if you will, regarding that. So we had one huge Angular code base at one time, and we're using enums to somehow connect the Java backend with the Angular frontend. And we're using enums to, have some feature flags switched on, and we were reacting on those feature flags in our template code in Angular. And for that, you kind of need to have enums so you can carry over the data structure, because just as you said, Deepa, they are creating some actual code later on, which means you can have it as feature flags or whatever in your templates. You can't do it with just a type that evaporates after compilation. So the good thing was we had enums to have kind of the same feature as a string union, and you were able to use them in our templates. But the bad thing was that this enum was 30,500 lines of code big, which is quite a lot, which basically killed the TypeScript compiler. So the TypeScript compiler said, hey, you know what? I tried parsing it. There you go. I'm not interested in it anymore. It might work out. It might not. It's totally up to you. Don't take us for granted. It was not exactly that message, but that was what it basically said. So it didn't give us any type safety anymore, because it was just not able to parse 3,500 lines of enum.
That's one of the advantages of enum over union string. You cannot have union string of this size.
Beautiful. It's a hidden any. So
yeah,
you just need to get it big enough. And again, I also wonder if Sona has an opinion on that.
I actually don't know in terms of that. I rarely use enums myself, and I think that's because of the sort of additional code, which I always try and keep additional code out of my code bases, mainly because a lot of my JavaScript's front end, or my TypeScript's front end stuff, and I'm always got one eye on the output size. But it's always easy to go and check to see if no, we don't really have any rules on enums, which is quite a good thing, I guess. It's I'm wondering like what you did with your enormous enum though. Did you just turn that to an object and hope for the best? Or?
No, we had tons of discussion regarding this one template. If we somehow could create the content that it needed, it also resulted in a huge template. If you could make it somehow dynamic and somehow get pack everything you need in a function and produce the content for that dynamically, and then go for a const enum or a string union, because string unions are easier to parse apparently, because you just need to look them up. And that worked out quite well. So, but yeah, so it basically stalled our compiler for 5 minutes with every compile cycle until it told us, well, no, not going there anymore. I was one of the, so that was a project where I was trying to increase the TypeScript and compile performance of this Angular project for over 4 months in total. And this took me at least 3 weeks to get this one right, because, just as we said, Phil, it was all about, communicating with other developers. And if this was their way of communicating, if this was the theory they were building and talking about, taking that away from them, pretty much never.
Yeah.
So
also another maybe addition for enums is basically it's good for a defined set of like related name values, while string union is just you want to say that you have more than one possible values. And this is, well, basically for small code base, it's not different much, but for like I've been working on huge monorepo with huge code base, and using enums extensively there really like give some extra content. For example, it's like there is like a for instance a request for the status of like a credit score, and you have like some values that doesn't give much of a meaning. But when you have enum with like the name that gives more context, as you read the code and as you parse, as you work with this service that parses this credit score, you get more idea. So you have like less questions to other developers. But for the small code base, it's just a different way of writing, let's say.
I agree. And again, that's again communicating in it. So absolutely true. All right. Speaking of which, so this is also a question that I find quite interesting. There are people who are migrating from JavaScript to TypeScript, and they wonder if, when migrating, should they prefer using generic types and decorators over other techniques? So maybe there's some added benefit taking those generic types and decorators that Arman has showed in his talk. When you are transitioning your code base from JavaScript to TypeScript, or what would you prefer? Because as they also told me, that's the next question, they've had an experience like this, and it was very hard to create types in interfaces when migrating. So I'm curious on your migration stories.
Oh, well, I was lucky to work with TypeScript for a long time. But yeah, I think the way it should be done is incremental. In the beginning, you have everything of type any, so you just disable this, the things, the pre-commit that complaints about any. Then slowly, and yeah, slowly. The main thing is to do like the basics, just to have at least the interface of types and so on. And then once like that part of it done, that's like the basics, the basement. And afterwards, if you see the repetitive logic, then you instantly understand that should be like a decorator. And also when writing the types and interfaces, also when you start noticing like you're creating the same for instance interface of type again and again, but with slight differences, then yeah, it's the time when you just use the generics or conditional types. That at least yeah, from my last migration, that's the takeaways.
Yeah, I got to agree with that. Incremental is the only way forward. If you try and jump headfirst in, turn all your JS files to .ts files and turn on strict mode, you are going to have such a horrible time. And that doesn't even bring into account types, generics and decorators and things like that. No, I mean, in times where I've tried to migrate JavaScript to a TypeScript code base, I think the kind of tactic has always been to kind of turn on allow.js in your TS config and just kind of move things over incrementally. You can have a side by side JavaScript and TypeScript set of stuff, and again without strict mode on, without complaining about implicit any's and things like that. And then once you've got everything from JavaScript to TypeScript, then you can kind of start turning up the kind of strictness mode and changing and improving things as you kind of come across them. That seems to be the best way to me. And it's, yeah, that's the way to clean up kind of any code base, really, is to just kind of work on the bits that you actually have to change and actually working on at any one time. And the more you improve those, the system as a whole is going to improve. And it turns out you probably end up working on most of the system over the course of a year, a couple of years, however big the thing is, and you'll all end up gathering it all and changing it and improving it over time. And then, as Arman says, like if you notice things where a decorator would stand in better here than repeated kind of other uses, then even better. Like it's just incrementally adding those bits as you see fit. And you get there in the end. Or maybe you don't. Maybe you'll never complete a full migration, but that's also not necessarily a problem, because if it's the bits that are changing that gain the confidence of TypeScript, then you're in a better place already.
I 100% agree with you, especially on the last bit. If you never touch that piece of software, then why bother making it strictly type? Because apparently nobody bothers anyway.
It already works. It's fine over there. Yeah.
Absolutely. So how about you, Deepa?
Like I haven't like when I have started, I've worked on Angular only. So there we are working on Java, TypeScript only. So I haven't really come across any situation like that.
Yeah. So the blessed ones who never had to migrate. I'm I envy you. Yeah.
Also, another advantage, or like how to say, motif for the migration is when you finally migrate to TypeScript and you have types for everything with decorators and generics and everything, then you can fully use the full advantage of TypeDoc. So basically, you can have like a soft that, because it knows all the functions, it analyzes your code base with the types, and then it generates technical documentation. And if it is properly typed, you get automatic live documentation of a pretty good quality. And the document is live because it's generated from code. There is an alternative SJS doc, but since you don't have types, it's quite limited and not quite useful. But for TypeDoc, it is.
One thing that I found out in terms of migrating just recently, which I absolutely adore, is the comment directive TS expect error. So if you have a model which has lots of properties and you haven't yet added all your properties in there, but you want to work with the type already, you can just slap in a TS expect error because the types don't quite match, which makes TypeScript swallow an error. So it tells you, well, I expect an error, so I'm not complaining. I'm letting you through. No red errors, no red squiggly lines. But the moment you added all properties back again, the error isn't here anymore, which means TS expect error will give you an error. So then you know, all right, this one is now finally migrated, and you can go hunt for those lines, and you know exactly how much effort it still is if you're introducing your models. It's a pretty nice technique, and it just came about it recently, so that's really something that I can recommend. Alrighty, cool. Let me quickly look at the questions. There's one more for Phil, which I think is quite interesting. So there's also one more for Phil, which is about JOT tokens and storing them in local storage. But I guess this was a different talk, was it? So that sounds like the WTF talk from...
yeah, it's a long time since I gave that talk.
I remember that one, though. But
yeah.
I was just curious. I didn't think I heard that this time. But the other question that was actually quite interesting was about type coercion. So we spoke already about it in the chat. So one thing that they did not catch quite well is the issue of using triple equals versus doubles equals. Which one is the right one? Which one is the wrong one? Which one should you use?
My apologies. I blasted over this one quickly, and obviously I wasn't clear. But triple equals is the good one, is the correct one. Stay off the other one. There's a wonderful thing online which I'm going to try and find a link for, and I'll post it in the chat when I do. Which shows like a matrix of like various things and what the double equals and triple equals does for equality for them. And it's brilliant because the triple equals is just like, if it's the same thing, like if it matches up, it's right down the center line, like that's equal, everything else is not equal. And you're like, yeah, that's sensible. And then the double equals one is just a patchwork of various things which turn up to be true when they're compared against. And yeah, absolutely, stay away from double equals. It's not fun. It's far less performant because when it's doing type coercion, that actually makes the JavaScript interpreter do a lot more work. And yeah, So I blasted over that too quickly. I apologize. Definitely triple equals or bang double equals. You know, the not double equal. If you're using three things, you're correct.
So always hope for having 4 times equal sign to make sure that we even check the similarity of the value, or I don't know, the memory layout or whatever.
The object ID of the value.
Going one step further, you know.
There is
cool.
one. Can I add something to this?
Yeah,
sure. Yeah, because the triple equal would be the exact match, So both value and the type matches. For example, number one equal to number one, double equal. But if you compare like one double equal, then like one inside the string, or then it gives true. So yeah, it's weird. It can give weird errors.
Yeah.
And it doesn't compare the, I don't know how actually compiler works, but it it doesn't compare types, but somehow it converts to a common type and then compares the values. And I think one equal to true would also be true, like double equal.
Yeah, maybe. Because you're checking truthiness. Yeah, I don't know on which side it needs to be. This is also something that you need to take into account. There's actually a beautiful document in the standard that tells you how this works, but I could live without it, to be honest.
Of course, it's beautifully specced out. So that's the thing with these things. Like, here is just a set of things that nobody would ever implement, but here's a spec for how to implement it. Go right ahead.
Beautiful. Alrighty. Oh, cool. We are close to the end of this session. So before we close it down, I want to ask every one of you on one last TypeScript tip for the audience today, if you like. So maybe we start with Deepa.
I would say, like, if you're writing the code, always try to, like, as we have discussed while we are declaring the enums, then we should keep in mind what case is better, it's uppercase or what, and then also use interfaces. That is also very beneficial. Like almost all of the people use it only, but if like sometimes when we extend the interface to another, so it is very useful, so use interfaces more.
Cool. And Phil?
Like, it feels a bit bad that I'm sort of plugging my company stuff, but I do absolutely believe in that, especially as you're kind of getting to grips with TypeScript, that using a tool like Sonalint built into your editor or installed into your editor can not only kind of correct you as you go wrong with things, but you get to learn from it as it does correct you. If you get a red squiggly underline for any reason, I mean, that's what TypeScript's trying to help you with as well, right? When it's giving you a red squiggly line under stuff, it's because you've done something wrong, and then learning how to get out of that situation is going to help you out there. And so Sonalint's one, but actually I did come across a VS Code plugin recently called Prettier TypeScript Errors, which also kind of it's absolutely beautiful. Helps to kind of syntax highlight and make TypeScript errors more readable. So if you're trying to learn from the things that your editor is telling you, those two plugins are going to help you along the way.
Beautiful. Absolutely. Arman, your tip.
Tip. Basically, I think this is like the beginner's track. So if you're a beginner and you're new to TypeScript, and you probably heard lots of things, and if you wanna like digest and use, I would suggest take one. It can be interface or enums or generic types. Then just focus on one and try to implement it in your code, or like deeply understand and just use one for a while. And then, and then after a while, after you mastered one concept, then switch to another. On the other hand, if you try to do everything at once, then the learning curve would be long and difficult. So
absolutely. Alrighty. Thank you so much. Thank you for this fantastic first round of talks. I really enjoyed it. So I'm always happy if I find like-minded persons who love chatting and talking about TypeScript. So thank you everybody for being with us. So say bye. See you next time, hopefully. And I hope we see each other in person at some time in the future. That would be terrific. Alrighty. Bye-bye.
Thanks so much.
Bye.
I'm removing everybody. And with that, I want to close down my shift, my first session of TypeScript talks. We have plenty of other talks coming up. So with that, thank you very much for having me. And in the best Austrian fashion, I have to tell you, I'll be back later this day. I'm going to talk about the lies we tell ourselves using TypeScript. And I will also be in a Q&A session on the other side of the interview table. So see you back in a couple of hours.
All right, welcome back. That was a very short break. And yeah, you may have seen me on the intro, but allow me to introduce myself. My name is Nick. I'm Director of Events at Geekle, and I'll be the moderator for the second block of today's junior track, TypeScript Global Summit 23. And so before I start, I want to mention one more event that we didn't mention during the intro, because our amazing community manager, Nadia, have prepared one more event that's going to be very soon this June. We will have a Vue.js Global Summit. And of course, for all of you using TypeScript, Vue.js is one of the obvious choices for using on their front end. So we have already a good lineup of speakers. We have more than 20 speakers for this event. It's going to be on 6th and 7th of June. We still have an early bird tickets available there. So definitely go check it out, that event. I know the Vue.js is like really hot topic this year. Lots of event, and this is like a third event on Vue.js already. And so let me introduce the next speaker. I'm happy to welcome back on the stage Ali, who's been presenting on our event countless times, and we still will be seeing him on our future events, including the Vue.js one as well. So yeah, Ali, welcome. How are you doing
Hello,
today?
everyone. Thank you for inviting me. And glad to meet you again.
Yeah, so you'll be doing mostly live coding session today, right?
Yeah.
Okay, so your topic is designing an entertaining game with TypeScript hands-on approach. I guess without any further ado, let me add your screen to the stage and you can start.
Okay.
Yes.
Enter screen. Okay.
Here you go.
Can you see my screen?
Yes, you can.
Okay, awesome. Thank you, everyone, and glad to meet you again here. And today we are here to talking about design a game in TypeScript, and it is about working with Canvas. Canvas is a tool in the browser for drawing graphical things, and I'm software engineer. I'm programming for around 10 years, and my education background is pure mathematics, and you can find me on the GitHubs on base max usernames. Have to connect with you. Let's start. For here, we are going to use jsfiddle.net, a website that can easily help you to write your HTML, CSS, and TypeScript, and it can easily compile and run the web view for you, so you can easily watch the preview. It can help us to speed up the process. Okay. The game today we are going to design is Tic-Tac-Toe. It is a game, and if you type in the Google Tic-Tac-Toe, you can see the games. It is an easy game, but what we are going to do today is to design this game in Canvas. You maybe find a lot of implementations of these games in the internet or GitHub, but they are mostly use the HTML and CSS and the DOM elements. But here we are going to use Canvas, and Canvas is a graphical environment in the browser which we can easily design anything we want, drawing line, drawing shape, drawing rectangle, drawing circle, and cube, and any kind of the shape we need. So it is a games, and it can be a two-player games, and when you click, you see the O is winners and I lost the games, and it is how the game is working. Okay, let's do a start. First of all, what we need is to design and create a canvas. Okay, in the DOMs and HTML, we have to create a canvas tag which is going to be our canvas tag on the page. So we set the ID for the tags, and the ID is board. So it's going to be our game board. First, in the TypeScript, we define const canvas equal to document get element by ID or query selector. It sends get element by ID, and the ID is board, as you can see in the HTML file. Okay. And the next is, because we are using the TypeScript, it's good to use HTML canvas element. So we are saying to the TypeScript, this variable is going to be HTML canvas. Okay. After that, we need to define a few cons variable. A variable for line color, we can define yellow for now. And the next thing is to define the size of the canvas. We need to define a size. Maybe we need to design 1000 or maybe 1500. It's dependent. We can change it, or 700. So we are going to design the tic-tac-toe. So the game board is 3 row and 3 columns. Okay. So we have to divide the canvas size, which is a rectangle, the size with 700 and 700 to 3 row and 3 columns. Okay. So we need a canvas sections, which is canvas size divided by 3, or maybe you decide to design a tic-tac-toe with 4 row and 4 columns. It's depends on your choice. And the next things, we need to define a canvas, a context. The context, we need to get the context from canvas. Okay. But because we are going to use TypeScript, in the TypeScript, we have an operator, which is a, as you can see, this symbol. But this symbol say to the TypeScript, our value is not going to never be null. Okay. Maybe when we get a context of a canvas 2D, it can be null. And it's depends on the canvas and the type of, maybe you want to get other context. When you have a symbol here, we are saying to the TypeScript, this value, I mean, the developer is saying to the TypeScript, this value never will be a null or undefined. So it is safe to use the TypeScript feature while we are writing the games. And the next is, we need to, yes, we need to define the board. Okay. But first of all, we need to mention term player. Here we are going to have 2 players. So we will have 1 for the first player and the second, or 2 number for the second player. So we will compilate this to do, okay, after defining the functions. Here we are defining the functions. So the first functions is going to be initials functions for the board. Okay, so we define the functions, and the name can be get initial board, and we need to get a default value, and default value is going to be a value which is for the rows and items of the board which is not filled yet. I mean, the player not selected that items in the board. Okay, so we need to default value, and which is can be a string, and output of the function can be a 2-dimensional array of a string. So here is a function, and inside the function we are going to define a board which is a string 2-dimensional, and we are going to use a for each from 0 to 3. It's depends on the number we have, so we can use the game size, which is 3. Okay, and x++, so we can board push empty array, and next use another for each for, yes, it's good, yes, default value. Okay, and next we need to return the board variable, board. Okay, good. Next functions, we need to define a function for adding a player. So we are going to define, it's better to write the comment, initials board with default value. Yes, good. And add a playing to the board. It's good to write the comment where we are designing the program. Add playing piece. Here we need to get a parameter mouse, and we need to use the interface x number, y number. And the output that function will be void. Okay, it's good to see it's working for us, but I prefer to write it myself. First, okay, we have a function here, and we are getting an argument, which is a mouse variable, and we have x and y points. And here we are going to define, look at this. We have a canvas, and when you click somewhere on the canvas, we are going to get the locations where you click it. Okay, so we will have a x, y, which is offset from the page, top and left. We are going to convert your offset positions to integer x and y. Okay, for example, here will be y will be 15th and x will be maybe 300. Okay, and we are going to convert that points to 0x, 0y. So it is what we are going to do in the functions. Before compilate these functions, I will prefer to write an event for the canvas element we have. Okay, so here we need to define events. And in the events, it's better to write the comment. Add a playing piece to the board when user clicks. Yes, and we need to add event listener mouse up on the canvas. And inside the event functions, we are going to first we need to change the turn player. If turn player is equal to 1, we will change it to 2. Otherwise, we will change it to 1. So after each click, we need to change the turn player. And the next, adding a playing piece to the board, we are going to call this function, which is still not compiled. And we need to get the positions from the events. We can even use functions. It's depends for your choice to use our function or not use. Anyway, we have event variables, and we need the functions to get canvas mouse position. We are going to use these functions to convert event to the x and y, and we will pass the x and y to the add playing piece. Okay, so inside the get canvas mouse positions, we are going to get an event argument, which is a mouse event type, and the return value will be interface x, y, which they are a number. Okay, good. So inside, yes, it's good. The copilot is working as well. Inside this function, we are going to get the binding client rect and return it as an object. So we will return the x and y object that are offset positions from the tops and the left as an object, and we will pass x and y object to the add playing piece. Okay, and inside the add playing piece, now we need to detect and convert the x and y offset to the x and y, which is starts from 0. So the first row, first column will be 0, 0, and the first row, second column will be 0, 1, and the last column of first row will be 0, 2. Okay, and the last row and last column will be 2, 2. It is the way we are going to follow. And okay, here we need to define two variables. And the first variable is going to be x coordinate, which is a number in the Typescript, and also another one for y. Here we need a function, we need a loops, which is a x from 0 to game size, and another for okay, it's good to refuse and optimize the code, but which is Copilot suggested. Here we need to calculate and multiply x to section, canvas sections, and also for the y to, and next check if the mouse click was inside a sections of the board. For this, we need to write if conditions and just to check to make sure. Here we have the mouse variable. If mouse x is more than x coordinate and mouse x is less than or equal to x coordinates, it should be correct. It should be correct. And even we need to check the y. If they are inside the canvas container, so they should be selectable. And inside that, we also need to close the for. Inside the if, we need to just clear the section after yes. And now we need another function for playing, and the name can be clear playing area, and x, we can keep this here, and right comma clear the playing area. We are going to call these functions here and passing x coordinate and y coordinate, and after that we need to draw an x or an o. It's depend on temporary. If it is 1, so we are going to draw x, otherwise we are going to draw o. And we need to pass x coordinates and y coordinates, which is a number which starts from 0 to 2, which is less than game size. So here we need two other functions, draw x and draw o. Functions draw x, functions draw o. Okay. Inside the clear playing area, first we need to, because we are using canvas, in the canvas we need to choose filling style, and here we are going to use fill style equal to FFF, which is white, so set the color to white, and then clear the sections. Yes, good. And context fill rect, and now fill rect needs x, y, and section canvas sections. Canvas sections. So it should be similar to x, y, width, out, height. So we will refill that area of the game. It is similar to clearing, because it depends on your game you want to play. Anyway, there is kind of the feature you must know about. And about the drawing O and drawing X. Draw an O, draw an X. Okay, inside the draw O functions, we need to get X and Y, which is the number. And the return can be void, because we not have any kind of the return value. Inside the function, we need to get half section size, which is, it can be canvas sections divided by 2, or a multiply. It's depending on your choice. Next, we need to get center x and center y. And finally, we can get the radius. It still depends on you for the radius. We can get canvas sections. Yes, it is a better way for calculating. And the next, we need angle, which can be used. You getting help from the pi number and angle. For drawing AO, we are going to use the pi, which is a number, constant number in the mathematics about circle. So we are going to draw a circle or a symbol similar to big O notation. So first of all, we need to set a color. For example, red can be. And also we need to define context, line width equal to 10. Next, we need to start drawing and context, begin pass. After using begin pass, we can start drawing. For example, draw a circle. And here we can use arc function, which is for drawing a circle. We can use center x, center y, and radius after circles, start, angle, and angle. Finally, we can have a drawing. For the drawing, we will use a stroke function, which is a function inside context. Yes. Good. Okay. Here is for drawing O. And for the X, it is similar. We need the X point, Y points. And inside the functions, what is the sign? Yes, we have time. Good. We can have an offset. It's depends on the game, but we can keep it. We need to define the stroke style, which is the color. We will change the color at the next step. Don't worry about that. First, we need to start drawing, and the next drawing inks. And yes, in the start drawing, we can use begin pass. And after that, first we need to move to the top and the left of the playing area. So we need to use move to. Move to is a functions in the constant. So we need to move to the top left corner of the sections, okay? And context move to x plus offset, y plus, yes, it's correct. We are going to move that part of the context. And next, we need to draw a line to the, yes, it's correct. For that, we need to use line to function, context line to. In the line to functions, we need to pass the parameters. The parameters where we are going to draw the line. So we have the x and y. So for drawing the line, x plus canvas sections minus offsets. Yes. X plus canvas sections minus offsets can be x, and y plus canvas sections minus offsets can be the y. So we are going to draw the lines, and for a line we need the x and y. And for the line you only need x and y and the stroke size. After that, we need to move for a x, we need to draw two lines and a line. So by drawing two lines, we will have a x symbol. So after drawing one line, we need to move to another point and drawing another line. Okay, so move to the bottom left corner of the sections, and that's context. Move to, let me to check this, x plus offset, y plus section, canvas minus offsets. Okay. Good. And after that, we need to draw line to the, yeah, really, GitHub Copilot is smart. And context line to x minus canvas sections, x plus canvas section minus offsets, x plus offsets. Good. And finally, we need to draw. For the drawing, we have to use struct functions, which is the functions inside the conver. So context struct, it will be draw the things we did for us. So here we have a draw of x functions and a draw of functions, and the function for adding player piece, and the function for get canvas mouse, and the mouse events for the canvas, and don't work, draw of O, draw of X, clearing playings, and okay, we also need another function for drawing line. At the beginning of the games, we need to draw the line, which is the line you can see here. Okay. So we need to function for drawing lines. In the drawing line functions, we can line start for the length of the lines can be depends on the canvas. So line length, canvas size, I need to check this part, but yes, it's good. Next, we are going to draw a few lines. So first, we can set up the style, color to yellow, okay, line color. It's better to write ourselves. Context, line width equal to line width, which is the argument in the functions. And we can cast it to Typescript. Struct style. Okay, so context, line cap equal to round. Yeah, context struct style equal to struct style. And finally, we need to start drawing and context begin pass, and then we need to for y from 1 to y equal to game size -1. Good. And another for okay, we can change this to no, we can just use another for each for the x. Okay, good. Here we need to context, move to line start, y, multiply canvas section. Canvas section is the important parameter here, and it is canvas size divided by game size. Okay. After moving to the point, we need to draw a line. It's dependent on the positions. So first we draw y line, and the next we draw x line. Okay. So context line to line length, y multiply canvas sections. Good. We can copy it for the x lines, y lines, and here we can have x multiply we need to swap it. X multiply canvas sections as a X and line length as a Y. Line start. Okay, line start and line. Good. So first we will draw the Y lines and next X line. 3 line, 3 line. That's our for rows and columns. Okay. And finally, for drawing the things, we need to call a struct function for context. Okay, good. Just sorry.
Okay.
Okay.
I guess, yeah, you have just 1-2 minutes to wrap up because, yeah, this is 30 minutes have passed. So I'll let you finish with some.
Yeah, it's almost finished. The game is almost finished.
Okay.
Okay. We design an initial board and we need to define this in the board, and default value will be a string. Okay, good. And just before the events, we need to define a few initialize the board. And first thing is we need to define the canvas width. Equal to canvas size, and the height equal to canvas size. And finally, context translate. Translate is an important function which you can read about the translate methods in the Mozilla.org website about this. It is about the size of X, size of Y. So after that, we need to draw the lines. So for drawing the line, we need to call the functions for, and the size will be tens and line color, which we need to define the line colors to a hex. We can define any kind of the color. Anyway. I know my time finished.
Well, do you have anything to show as the result?
Yeah. Yes. Yes, you can see it is the game. So we have a game board and we can play, and you can see we are drawing the O, X, and it's refresh. Yeah, good. It is how the canvas game is working, and after every save on the Typescript code, the previous page will be re-rendered. So after each click on the canvas, it will be convert the event locations, and we will get the location of X and Y using these functions. And finally, we will pass the values X, Y object to the adding playing piece. And in adding playing piece, we will detect and convert the X and Y offsets to the X, Y number, which is a start from 0 to the number of the rows and or columns we want. So these functions will be defined and find a X, Y, which is a loop index, and finally we will clear the playing area at that point, and we will call the drawing x or drawing o functions. Depends on the situations of the turning player, which is the ones or two. And after each clicking on the canvas, we will change the turn player from 1 to 2 or from 2 to 1. And it is how we are working. And what is the importance about the canvas is the translate functions and line to line style, line width, beginning pass, stroke, arc for drawing the circle, and move to for move to a positions, and line to for drawing the lines, and fill rect for filling rectangles on the screens, and fill size for defining the color. So here is the how canvas is working, and by using canvas you can easily design any kind of the game you want. And yes, here is the Typescript and the canvas. Thanks.
All right, thank you for presenting this hands-on session. The code on the screen that you were just showing, the result code in Canvas, was a bit small. Do you have this demo link available for our attendees to take a look?
Do you mean for sharing the source code?
Yeah. If someone like to take a look
Yeah,
at the demo.
yeah, I'm going to share it on the GitHub.
Yeah,
Yeah.
please provide the link so we can share it with our attendees. Thank you so much for presenting. You did the chess game, you did the tic-tac-toe. I guess the next is something like Endless Runner from Google Chrome.
Yeah, it's cool. The game is cool because you can use your math, use your programming, and use graphic styles, and anything is fine to do.
Yeah. Okay. I'll see you in around 1 hour from now for the Q&A session. But for now, thank you for your presentation.
Hope to see you again in the QA.
Yeah.
Bye for now.
Bye. Okay. Without any further ado, I want to present our next speaker. But first of all, I want to mention then, if you like this session, we have a banner. If you're watching it on a platform, you will just see a banner that's showing the speaker, and you can leave a like on that banner. And if you missed some session, or if you will be watching this recording, you can go to our schedule page that you can find in the description or in our dashboard, and also leave the like on any session that you liked and found interesting and valuable. So please go ahead. It will help us understand which were the best sessions and what kind of content we should definitely continue making for you. And so, so we've been talking about Canvas, and I already mentioned Vue.js about our next event, but we will be also taking a look at Vue 3 and TypeScript. We have Adnan Kreiker here with us, and so welcome.
Yes, thank you, Nick. Yes, my name is Adnan Kreiker. I'm a front-end developer, and I work for Edition GmbH. I'm a big TypeScript and Vue enthusiast. And thank you so much for having me here, and thank you guys for attending. I'm so happy to be presenting here today.
Right. Yeah. Please share your screen and let's start.
Yes. So, but first, I'm going to be talking about why you should use Vue 3 with TypeScript. So I accumulated the top reasons why I think so. So the first most prominent one is we are able to catch errors while we are coding instead of getting bombarded by errors at runtime. And it also integrates well with other tools to enforce good guidelines, such as ESML. And it also gives you that extra confidence when refactoring your code or extending it and adding new features. But on top of that, types are also self-documenting, so you get the documentation as well. And there's been a lot of talk about DX in the past years. And yeah, when you think about DX with front-end, I definitely think of TypeScript and its great IntelliSense and autocomplete. And also a great benefit is that you would witness the importance of TypeScript as your project grows in size and team. So this is the table of contents for today's presentation. At first, I'm gonna show you how to spin up a new Vue3 project with TypeScript. Then we're gonna set up VS Code. I'm gonna talk about how to type Vue reactive functions, how to type props, emits, and also I'm gonna be talking about some new features in Vue 3.3, which is still in beta. And these features are generic components and typed slots. And if we get enough time, there's a bonus section for typing third-party or getting the benefits of typed third-party libraries in Vue 3 applications. So let's start coding. So I go to my command line to initiate a new Vue 3 project. We simply run npm init view at latest. And we can name the project Vue 3. And we say yes to add TypeScript, no to JSX, yes to Vue router. We don't need state management for this app, neither testing solutions. And yes for ESLint, and no for prettier. And that's how simple it is. So I'm not gonna actually install anything because I already have my demo app. So this is the demo app I created for this demonstration. So in this demo app, I'm gonna show you some real world examples of how to leverage the full power of TypeScript with Vue 3. And I hope you can get something out of it, whether you're a junior dev or a senior one. So let's take a look at the first section, which is going to be catch type errors across files. So let's assume this gentleman joins your backend team and he wants to do some refactors in the code base right away. So he wants to open his first merge request by editing the user response. So let's say we are getting this user type from our backend, and this lovely cat adds a new property to it, which is meows, and it's going to be of type Boolean. And yeah, and now we get errors on our object here. But luckily we are using TypeScript and it says the property meows is missing in the type. We can simply just correct this by adding the missing property with its correct type. But do we also have to check every file for this that's using this user object or type? And fortunately, no. We simply run npm run type check, and TypeScript will actually look for type errors across our files. So we wait for a bit, and yes, it shows here we have this type user component in this type error component I created. We jump to it, and we see also that we need to update the type here. So we just do this, and bam, our code base is saved for now. So we have to be careful with this new gentleman. And next, I'm going to be talking about Vue reactive functions. In Vue, to declare a reactive data, we especially in the, I'm talking about the script setup, which is the latest syntax in Vue, and it has the best TypeScript support. We either use ref or reactive. So let's take a look at some code. So why would we use ref or reactive? Let's say we declare this age variable here, and we want to use it in our template. But the problem is when this age variable gets updated, its value would not be updated in the template as well. We can solve this by using the ref function. So there's been so many confusion about why should I use ref? When should I use ref? When should I use reactive? I would say for most of the time, I am using ref in my code base, but I'll mention some caveats for both of them. So let's say we have this count ref here, which has a value of 0. Typescript is automatically able to infer its type of number. But if I want to actually access its inner value, I'm going to have to use the dot value property on it. But this is not the case with reactive. In reactive, let's say we have this movie object, which is of type reactive. I can just access movie.count, and I don't have to use the value. This is the first difference. Another difference is that in ref accepts all type of data you think of, while reactive does not work with primitive values. So that we have to keep that in mind. And ref also can be used to reference components on the template, so you can manipulate them in your script. Ref can do that. And yes, that's pretty much it, all you need to know. And let's talk about typing, how to type actually the ref. So as I demonstrated here, Typescript auto-infers the type for simple variables like this one. But let's say we want to actually explicitly type it. We can do this by passing the generic argument with the type we want. And this works the same as you. But this gets handy when we have a variable that changes its value. Let's say we have this user ref, which has an initial value of null. So after our fetch user function runs, it fills up this user variable with this returned object. But Typescript is complaining here. It says that this type of user is not assignable to type null. So in this case, we have to explicitly annotate it here by using user or null. And Typescript would be happy. And I want to mention something. If we don't add a value to an initiated variable, the default value would be undefined. So we need to be careful about this. So the way of typing reactive is simply by adding it, treating it like a normal object, and how we annotate it. And it looks like it caught something fishy. Let's take a look at it. It says type of property release date are incompatible. So in our movie type, the release date is of a type date, but currently I'm using the getDate method on it, which returns a number. So good job, Typescript. And yes, this is how we use how we type ref and reactive in Vue. Jumping to our next point. Now we are going to be talking about computed properties. So what is a computed property? It's a declarative way to describe a value that depends on another value. But let's see what that actually means in code. I have this ref that represents weight in kilogram. Let's say I initiated with a value 100 at first, but I also want to convert this value to pounds. The Vue computed properties are perfect candidates for such tasks. So, and also Typescript is able to infer the correct type automatically for that. So whenever this value weight updates, Computed reevaluates and reruns this calculation automatically. And now I'm going to demonstrate a simple example I made in the template. So we have Dojo here, and his weight in kilograms and in pounds. So this slider component is attached to the ref, the weight ref. Whenever it increases, the weight in pounds also increases. Right. So now let's see a bit more complex situation when using computed properties. Let's say our code can take multiple paths. So in this case, the random number, if it's greater than 0.6, then it's going to return the string 1. Otherwise, if it's smaller than 0.5, it's going to return the string lost. So yes, it seems fine. And let's take a look at the result, which is going to be the value of our computed property. I forgot to mention earlier that we actually access the values of a computed property using the .value modifier, same as ref. And if we hover over the type of results, we see that it's either won, lost, or undefined. So this says that we should annotate it. If we annotated it, we would have found out that there is something unexpected going on here. Not all paths lead to returning a string. So in this case, we should return something, and Copilot is smart enough to return draw. And now, if you look at result again, it's of the expected type, which is a string. And now, let's talk about emits and props. So props in Vue are similar to React. They are used to pass custom attributes or properties to a child component. And emits are special component events that the child component emits to the parent to inform it that an event has been triggered. And these events can also carry data with them. So in this example, I have a parent component, which is this wrapper, which has this inner text here. And I have a child component, which has a text field. What I want to achieve is when the user types something in the child component, I want the parent component to update its inner text. So let's see how we can do this with Vue and TypeScript. So in our child component, we have this define props compiler macro. This is the way to declare properties in Vue. We don't have to import this. This is auto-imported, and it vanishes at compile time, so it won't add any extra baggage to your code. So we declare const props equals define props, and here we pass the props we want to use along with their types. We can pass optional props by appending them with question mark. And we look at this define emits compiler macro, and here we declare the function signatures for our emitted events. So we have the first argument, which is the event name. Some people call it E. I prefer to call it event to make it more explicit. And the value is optional. You can have it without a value, but in this case, we are using a value. And we have this return type, which is void here. We have our text field here. The value is going to be the input value we get from the props. And on the input event, we attach this emits special event. So, and it's the cool thing, it's when you use emit and we click on the options, we see we have the typed options. We can ignore this, there is just from my extensions. So this is the update value event we have here. And we get also a hidden parameter. You can use it in this callback. So this is, we get this information by using Voller, which is a VS Code extension. It's recommended to use it with Vue 3 if you are using TypeScript. It adds great DX to your code. And we want to let TypeScript know that, hey, this element has a value property on it, and it's a text input element. So we use typecasting in the template here. And this is actually a new feature in Vue 3. It was not present in Vue 2, the ability to cast in your template. So if you hover over the value, it has the correct type, which is string. Pretty cool. Now let's take a look at the parent component. So here we import our child component, we mount it on the template, and Voller automatically informs us that there's a missing required prop, which is input value. So I'm gonna bind this prop here, input value, which is gonna take the value of this ref that I declared here, text content, and also we're gonna be listening to our custom event, which is the update value. And this event is gonna update the value of our text content. So we're gonna say text content equal event. Notice that we do not use dot value on the template because Vue automatically unwraps it for us. And the type of the event is actually the correct type as we annotated it in the child component. So let's take a look back at our demo. So we have the initial value of this, and if you update it, it correctly updates in the parent component as well. And now we're gonna talk about component template ref. Let's say that we have a parent component and a child component, and I want to be able to trigger a method or retrieve data from the child component directly from the parent without using props or emits. This can be achieved in Vue using the ref. Now we have this simple alert component. It only has a script. It has a number of alerts, which is a ref with a value of 0. It has an alert function, and this function simply alerts the window and increments our ref. And then we get this define expose compiler macro. So normally, by default, every value or function on a Vue component is not exposed to the outer components. So if you want these function and these ref to be accessed from outside the component, we have to pass them into the define expose compiler macro. So now back to our parent component. So we import our alert component here, then we mount it on the template, and we assign a ref to it with the keyword ref, and we can name this whatever we want. I named it child alert component, and this child alert component should have the same name as we declared here, and it's going to be a ref. And here's the cool part: is we pass the Typescript utility type, which is instance type, and pass it the generic argument of our imported component. And this makes it able to infer all the properties that exist on this component so we can access them safely. And notice that I initiated as null since this script setup function runs before the component is mounted. And so the component would not have a value initially. All right, so here we have a button on the parent component, and I attached an event handler to it. I called it trigger alert on the child. So I want this button to trigger the alert function on the child whenever it's clicked. So how we do this? We take this ref, the child alert component ref, access.value on it, and invoke the function immediately. If we delete this and take a look, we actually have all the properties that exposed by Vue on this ref, along with the properties that we exposed ourselves. So we want to invoke the alert function. And the same way, we want to display the number of alerts in the parent component. So we access the number of alerts in the child component using a computed to make it recalculate its value whenever the number of alerts is updated. So let's take a look at the demo. And whenever the button is clicked, we get this alert from the alert component, which is the child component, and our number of alerts also increments. And next, let's talk about slots in view. So why use slots? Why not just use props? Well, I would say slots are one of the strongest features of view because they allow us to pass template fragments to child components, and it just makes our components so reusable and enhances them in a great way. Let's take a look at this example. I have this empty button here. It has nothing on it. And I have a slot component. Let's take a look at it, this is the button component I just demonstrated. It's just a HTML button element, has some classes, and it has two interesting elements here. It has slot and slot with a property name that has a value of text. So a slot, if you don't add a name to it, it's the default slot on your component. And we can add a name to it so we can access it from the parent. Let's see what we can leverage this. Okay, so this is our imported slot component in the parent. And if I type template, so the way to access slots is by using the template. And then we use this hash symbol, and we get the options by Typescript automatically. So we have two options here, either the default or the text. So if you want to use the text slot, let's say I want to add a paragraph, text from parent, and I save, then my button is updated. But it just doesn't stop here. Let's say I want to use the default slot. If I could type. And we can use any HTML element you would want. Like let's use this V icon, MDI, heart. Let's see. Yes, and it works. Of course, we can customize the styles however we want. This is just for demonstration. And now we're gonna talk about the new hot feature in Vue 3.3, which is generic components. So generic components are pretty reusable. They accept a wide range of props to them, and we can use them in many ways. So I ran into this issue, a similar issue at work recently, and I'm gonna demonstrate it to you. So we have this table here. Let's take a look at it in the code. I have this row type. It looks a bit scary, but I'm gonna explain it. It's a generic type that has an argument, which is key, which has the constraint that it extends string. So it's basically an object that has keys that extend string, and the value of these keys are of type cell. So type cell is basically an object that has title and value on it. But on top of that, we get some properties as well on this row type, which is name, has a type cell, and an optional property is children, which is of a type array of rows, makes it a recursive type. And now, next we are defining the headers for our table. So we have name, calories, protein as const. Using the const as const here makes it a read-only tuple. We declare our rows ref and pass it the generic row type with the inner argument as headers, which is going to be our headers that we derived from this type headers. It's going to be a row array. And everything seems so fine now. So we have the name, calories, protein, etc. And we also have a ref that shows the current selected row which is has the value of the first row by default. And now we are importing our table. So our table has property of header, which is string array, an event to update the selected row. It says any here, which it shouldn't. Let's take a look at that. And it says that the type of row is any array. And that is not what we are looking for. So let's take a look at this generic component and figure what's going on there. Since we are using this row type, and it's a generic type, it actually requires an argument. But previously, before Vue 3.3, there was no way to pass this argument. This is where the Vue team got our back and added this generic attribute to the template. Now we can add whatever generic attributes we have. And let's add it, call it T. So let's say the row, just type T. And we also type it here in our event. But it seems that there's some things still wrong. T does not satisfy the constraint string. Yes, because we said here that key extends string. And then we fix this by using the extend string here. And we save. And it seems it's happy now. Let's take a look back at our parent component. We hover over the headers. Okay, I forgot to update the headers. There should be a T array as well. And now we see that the headers is an array of name, calories, or protein, which is our keys or our headers. We take a look at the argument of the update event, which is cool. Now it has the correct type with the row with the desired keys in it. And the rows also have the correct type. And let's say that I want to add a slot on this component. Yes, Copilot. We actually get all the type here. For example, delete, let's say rows, index, dot, we get all the properties fully typed, 14 dot title. Let's save and take a look. Delete frozen yogurt. Yep, and it works. This was not doable before version 3.3, which is I'm looking forward to it. It's still in beta. It's worth noting. All right, so now I'm going to be talking about typing or not typing, leveraging third-party libraries that use Typescript. So let's take a look at some code example. So this is a simple component. I'm using Vuetify, which is a Material UI component framework for Vue. I have this vcard component. Let's just remove this lang.ts. This is how we tell Vue that we are not using TypeScript. And I want to check what properties I have on this vcard. It seems that I only get this HTML properties and these v built-in Vue modifiers. But if we introduced the lang.ts again and do the same thing, well, we get the actual properties that we can pass on these components. So we won't have to constantly check the documentation of our UI components back and forth. So flat, let's say flat, it says its type is Boolean or undefined. I'm just gonna prefix it with these dots here, and let's say true, which makes our card flat. And the same for this button. Let's see what we can add here. Variant, for example. And it gives me the options as well, which is pretty cool. All right, so one final thing I want to talk about is typing routes. For this demo, I'm using this unplugin view router, which leverages the file-based routing for view router. So how does this work actually? If I take a look at my router file, you see I'm not importing any components here. I'm not defining any routes array, which is how we used to do it before I was not using this component. But I'm importing view router from router/auto, and it basically scans the pages folder and generates the routes as I wish, or as I am organizing them here, including nested routes. Let's say I want to change the name. I don't want it indexed, so I just can simply define a compiler macro and give it the name that I wish to here. And using this syntax, the bracket syntax, I'm able to pass dynamic arguments to the routes. And I'm also using this useRoute composable. Let me show you here, which has autocompletes for all the routes in my application. So I am in the users route. So I won't have to guess, is it user, is it users? It just gives me the correct value here. And let's say I want to show the user their route ID, route params ID. So in the template, just can access route.params, and I get what params I have on this route. If I save and I go to our dynamic route, we see we have this ID here. But if I change it, it updates here as well. Yeah, so this brings me to the end of my talk. Thank you so much for attending. I hope you enjoyed it. I hope you get something useful out of it. And this is QR code to the GitHub repo. And in case you want to contact me or ask me some questions, I'm also available on LinkedIn. Thank you.
Yeah, thank you so much for presenting. That was a nice presentation, and it also sparked a conversation about Vue.js and in general, like Joseph frameworks. And we'll discuss that on a Q&A session. But for now, thank you for presenting, and I'll see you in around 30 minutes.
See ya.
Yeah, see you. Okay, without any further ado, I want to introduce our next speaker, who's Dominik Guzy, who is Chief Innovation Officer at Gorion Software House. And we'll be talking about validation, that we need to validate everything and everywhere. So let's take a look at what he has to say.
Everyone. Today I would like to talk about schema validation with Zot in TypeScript projects. My name is Dominik Guzy. I'm Chief Innovation Officer at Gorion Software House. We're based in Gliwice, Poland, and we're doing end-to-end custom software development. Today, we're gonna circle around two main topics: type safety and schema validation. I'd also like to show you a few use cases for schema validation with code examples. Those use cases and code examples will be valid for front-end, back-end, full-stack developers. So I hope everybody will find in my session something valuable for them. Let's start with type safety. Type safety in computer science is the extent to which a programming language discourages or prevents type errors. The history and discussion around type safety in JavaScript ecosystem is long and ongoing. As we all know, JavaScript is weakly and dynamically typed. This, along with type coercion, doesn't provide the best developer experience. The only type safety that JavaScript provides is at runtime level. You actually have to run the JavaScript code to see the type error. And this can lead to bugs on production. And as IBM study shows, the cost of fixing the errors on production is 15 times bigger than during implementation. I think the good analogy here is that writing JavaScript code is like walking in a maze with your eyes covered. You can only spot the wall if you hit it with your head, and that's painful. And this is the biggest reason behind TypeScript. TypeScript aims to fix all of those problems with static typing. And as long as you're using IDEs like Visual Studio Code or WebStore, you're already using TypeScript. There is even a scientific paper that proves that usage of static typing with TypeScript could have prevented 15% of all bugs in public JavaScript repositories on GitHub. On the other hand, the Airbnb post-mortem analysis show that nearly 40% of bugs were preventable with TypeScript. So which one would you choose? Crashing users' web browser or an undulating red line in your code editor? Does TypeScript sound too good to be true? TypeScript can benefit developers in terms of code reliability and maintenance, but it lacks one feature: runtime validation. But fear not, there's always a solution. Let me show you schema validation. Schema validation is a crucial step in the software development process, as it ensures that the data being used in an application is accurate, consistent, and reliable. Generally, it refers to the process of verifying that data conforms to a predefined schema or structure. A schema is a description or definition of the expected format, type, and structure of the data. The process helps detect quality issues early and prevents errors caused by incomplete or incorrect data. A robust schema validation can enhance performance and reduce the risk of errors when developing large-scale production-ready applications. To put it in the layman's terms, you can't always be sure what you're going to get from an input. Let's say we require a number. TypeScript will present an error if you put string there instead. But on its own, it doesn't know if a number is too low or too high to be realistic for your use case. There's a similar problem with third-party API responses. You can, of course, reference documentation to get an idea for what a response includes, but TypeScript can't tell you how to type it. And what happens if there's no documentation, or if you get an error instead? For me, the rule of thumb is that you need schema validation when you're accepting user input or any third-party data. And luckily, in TypeScript projects, we have Zod. Zod is a TypeScript-first schema validation and declaration library. Zod was created by Colin McDonald, who is currently a developer relations specialist at BAM. The term schema here in Zod is used to broadly refer to any data type, from a simple string to a complex nested object. Zot is designed to be as developer-friendly as possible. The goal is to eliminate duplicative type declarations. With Zot, you can declare a validator once, and Zot will automatically infer the static TypeScript type. It's easy to compose simple types into complex data structures. And Zot works everywhere. And the only requirement is to use TypeScript at least in version 4.5 with the strict mode enabled. And that shouldn't be big of a deal, since this is the best practice for all TypeScript projects already. Zot follows a simple, snappy slogan that encapsulates its functional approach. Parse, don't validate. The phrase comes from Alexis King's blog post, and I think it summarizes the approach very well. There are two parsing methods, including safe parse, that doesn't throw an error if the validation fails. Here, in this example, we can see that everything related to schema is prefixed with Z. In this case, we have that Zot string. Zot operates on a couple of levels, and here we just say a primitive, a string. Primitive values are not just limited to string, but provide other methods such as number, begin, boolean, or date. There are also a couple of empty types as well, like undefined, null, or void. Most of user-facing forms, on the other hand, require a couple of data inputs and validation of varying data types. This is where it's better to use objects in Zot. In this example, we're using z.object, which can nest or encapsulate primitives and other objects. By default, all properties in Zot objects are required. And for each primitive type, Zot comes with a handful of specific validations. For example, you can validate if string is an email address. There are also transformations available. I hope we're gonna get there today. The last thing I wanted to mention with this example is type inference with Zot. Zot can infer or deduce TypeScript type for schemas. You don't have to write your types twice, as I mentioned before, which is a huge productivity boost. All right. Since we know all the basics, let's start building things. I've prepared a sample project here. It is a monorepo created with turbo repo that includes a couple of packages and 2 applications. First of all, we're gonna talk about environment variables. We're gonna cover parsing, validation, and autocomplete. I've prepared an env package here. Let me make it a little bit bigger. In that example, we've got a index.ts file, which includes just a config from .env package. And here we've got our .env file. We've got a sample URL, a port, which is a number, and hello world. Let me do a console log with process.env. Oh, we don't have our autocomplete here, but I remember we have hello here. Okay. Let me run that in terminal. I will be using pnpm and filter the env package and run that. We have the world here. If we change the process env to port, we're gonna get a 3000. But if we're gonna use the type of process env, we're gonna get a string. Okay, we want to have that auto-completion, but also we want to coerce the good types here. Let me show you how to write a Zot schema for our env file here. We're gonna import Z from Zod, and we're gonna create env objects. We will have the hello, which is z.string. We will have the port, which is z.string, of course, because all the environment variables are strings. We're gonna convert it in a moment. And we're gonna have our sample URL, if I remember correctly. Yes, indeed, which will be some string. But also, it would be an URL. Okay, let us now pause our process env. And in paused env, we will have hello port and sample URL. Now we can use console log paused env, and we get our auto completion. And we can see we've got the hello. We can see that we've got the sample URL here. And changing this URL to something different will result in an error. Zot error, validation of URL, and we get the invalid string here. It is an invalid URL at sample URL. Let's get back to google.com, rerun the server. We have our auto-completion here. And it's perfectly fine to use this parsed and export it from our package and use that all across the app. It gives us also one great thing. We can coerce a number from that port. And if we use the port here, we can see the 3000. And if we see the type of paused env.port, it is a number, which is a huge win. But that's not the case for everybody. Sometimes we want to use the process.env, and with type inference here, as long as we're using strings all across our env validation, we can also provide something great. We can provide a declare global namespace Node.js. And here we can have a interface called process env. And here's the magic. It will extend z.info, type of our. And now with that code, we can use the process.env, and we're getting that auto completion here. That is the first example. Another thing. The second topic is form validation in front-end projects. For this example, I have prepared a sample form. It is a React application that is built using Vite bundler. I will show you code in a moment. For form handling, we will use React hook form. And for the validation, we will prepare a Zot schema. And thanks to hook form resolver, we will use that to display errors and eventually allow our users to create an account. We will not handle the backend logic here, just the schema validation. Let's see the code. In the code, I've already prepared some values here. First of all, I've created a z.object form schema here, but it's an empty object here. I've also deconstructed the register, handle submit, and form state from useForm hook. This allows us to submit our form. Okay, let me show you how this one works. Putting anything here, we don't get any errors, and hitting a create an account offers us to save that, but also sends us an empty object, because under the hood, the form is not really at all handled. Let's create the schema for this one. Okay, we will start with username. The username, of course, is a that string here. Okay, we know that the username is required and must have at least one letter. Okay, and let's say we will have a maximum of, I don't know, 30 characters for the username. Okay, the second one is the email. It is also a string, but it's an email. And we're gonna have an error of invalid email here. And also, we will have at least one character of length because email is required. The other thing is the password. The password is z.string, and it is first of all, required, but it has to be a strong password, and a good amount of characters in password is 12 characters. Password must be at least 12. Okay. Now we've got that confirm password. This is also a string, which is required. Password confirmation is required. But there's also one more thing. The terms and conditions. User has to accept them. So let's put here terms, and that will be a Z literal. It literally must be true. Okay, and if we want to display a message, we can use the error map here. The error map is a function that can return an object having the message here. And let's say, okay, now we have our schema ready. Let's get back to our, okay, we have that password must be at least 12 characters long. All right, and we've got our object after sending that. But you can see that there's really an error here, but we're not displaying that the password and confirm password do not match. We have to refine that those two have to match. Let's do that with a refine object here. It accepts the data that comes from our from the schema, and we're saying that data password must be exactly the same as data confirm password, and we're going to display that at the path of confirm password, and the message, if they don't match, will be passwords do not match. Okay, let's test it out. Yes, we've got it. Let me put a use securely generated password here. Copy and paste, create an account, and we've got our beautiful object here, all validated. If I put no username here, username is required, of course, at least one character. In terms of email, that is invalid email, but this one is all good. And that's how we handled the schema of that form in React using React hook form and Zot resolver. The last, third example is API validation. Zot really shines in combination with TypeScript Remote Procedure Call, or TRPC, which is a piece of technology for creating fully type-safe APIs. And not only creating them, but also consuming using client that leverages React query from timestamp. But let's not focus on the TRPC part here. Let's focus on the Zot validation of our inputs. Let's take a look into the code. Here you can see a sample TRPC operator that has only one procedure called test. On the other hand, in the index file, we've got a sample express application that is listening on the port 4000. Let me use the call localhost 4000 to see what we've got here. The server is running. Also, if we use the trpc/test, we can see the result data works. Okay, so this procedure here actually is working as expected. Let's now create a procedure that responds with what we input there. Let's create a greeting. A greeting would be a public procedure that will have an input. The input here would be z.string. Okay. This z.string would be nullish, so it doesn't have to be provided. That would be a query that will take into consideration the input here and return a message. Hello. And in case if there's an input here, we're gonna show that. But if it's not provided, we're gonna say world. So we've created a public procedure with nullish input here. And we will display either that input or world. So let's test it out. First, let's use this sample curl localhost 1000 trpc greeting without any input. We're getting the result of hello world. Now, if we're gonna use the input here, and actually we have to escape the characters here a little bit, because that's a JSON encoded input. We have that result data, hello test. But this really shines with combination with the client. As I said, we can create a TRPC proxy client that will wrap our TRPC, and the magic happens right here. We import only the type, so that will be in the runtime. That type will be, that line would be completely removed. Now we're getting the full auto completion. Okay, we can see two queries here. I've got a script that runs client. First, we're using the query without any inputs. The second one, we're going to use the Dominik here. And we can see both works. But now, as we expect, a string, void, null, or undefined. But we've got a number here. So this really bugs out here in the editor. And if we run the client, we can see that we get actually an error. It's a TRPC error. But under the hood is Zot error that we've got invalid type, expected string, received a number. And that's how schema validation works inside TRPC API project, including server and client. I guess that's it. Thank you all for your attention, and we'll see each other and hear each other.
All right. Thank you, Dominik, for this amazing presentation. And without any further ado, let's start our Q&A session. So I'd like to welcome back Ali here and also Adnan. And we have Dominik with us live as well. So hi. I see.
Hello, everybody.
Right.
Hi
so
again.
let's. Okay. We have lots of we always have some questions to start with, and I invite everybody to put your questions in the chat, and we'll be answering them right now. We'll be covering them right now. So I have first question for you, Ali. So you are you do open source, and so there was a question about how can I, and this question, of course, for everyone. How can I make my projects open source so other developers can help without exposing my API? So, Ali?
Yeah, just reading. Maybe we need more information and details about the question, but as an open source maintainer, you can easily publish your project, and it depends on your project is the front end or back end. But if I think you should not be worried about the backend and the API, because everyone can easily monitor and sniff your API and the requests and the backends. So in this way, you should be okay in the let others know the API routes and the details about your networks. Anyway, it is why the most software and projects are using encryptions. For example, Telegram's client software is fully open source, and you can find the client software of the Telegram desktops and even Android fully open source in the GitHubs. But Telegram server is fully secret and private, but they not have any worry and problems for having the client software open source, because they use that encryptions and algorithm for encrypting and make the communication safe. I hope it can help.
Okay, thank you. I have, if anyone have anything to add about like open source and security for that, so please go ahead.
Yeah, just one thing from me, maybe don't put your secrets in your repos. Just that.
Yeah, pretty obvious, but yeah, still need to remember. Everybody need to remember.
There are a
that.
few robots in GitHub which will be automatically let you know if you publish a key or secret, or maybe any kind of the things in a repository. Even if you publish a GitHub API key inside the file, GitHub will be automatically delete the key from your GitHub's accounts, which is really good and safe. By the way, yes, as Dominik said, it's better to keep your key safe.
Yeah. Okay. I have. There was a question that was asked throughout, like Adnan, your session. So I'm not sure, maybe you covered it in your presentation, but it goes like this. We declare a variable with const, which we anticipate it to change. Is it a put using computed? I hope it makes sense because I just took it from the chat.
Yeah, so I think I get this point. So they're expecting that if we declare a ref or a computed with the const keyword, that it will not change. Actually, the ref object itself won't change, but its inner value is the thing that's changing. That's why we get away with declaring the const. I hope this answers your question.
Well, I hope that answered the questions by the person that asked it. Thank you so much. I want to give like a more general question because you touched Vue.js and it really sparked the conversation on frameworks. So can you get, and this is also a question for everybody, if you prefer using Vue or if you prefer using other framework, can you maybe give information, like give your thoughts on if you're using TypeScript and which framework works better, or maybe there are some situation where you can use a different one? I know this is a long question, but I wanted to ask it. So Adnan, because you started with Vue, yeah, can you?
Yeah, for me personally, I prefer Vue because when I first started learning front end, I just started with Vue, and it was pretty simple to learn. First with the options API, the APIs were simple, the documentation was good, and yeah, I just stick with it. So I found no reason to jump to another framework. That's it, from my point of view regarding it. So I think it's a great way for if you're a beginner, yeah, just jump into Vue.
I'm more of a React guy and currently working with Next.js framework. So the types in React ecosystem can be tricky as they are community-based and not made by the React core team. But it's starting to change because there was a huge problems with, for example, mutable refs in React. And when it came to better understanding of React core team, they started to provide better types for that. So React ecosystem changes every day and makes the whole React more type safe every day. So I think we're heading to the right way with the React. And the next JS provides an additional layer. It is framework, so it provides additional layer of type safety. And currently, it is recommended to start a Next.js project with TypeScript. So I think it's also a good choice. But yeah, just it all depends on developers' preferences. So, yeah. They're all good.
Well, yeah. Then at the end of the day, but yeah, it's good now. Like that, basically all major front-end net frameworks now can be used with TypeScript. And so, Ali, what about you? I know you use a lot of stuff, including Ruby, and but
Yeah.
what frameworks do you prefer using?
For the front,
Yeah.
I have a bit experience in Vue.js and even React. I love both, but honestly, I'm not using Angular so much. So it's better to talk mostly about Vue.js and React and not Angular. But anyway, I think community of React, it seems to be bigger. And I don't know why, but it is good. And Vue.js looks like more simpler for fresher and they only can know HTML and CSS and want to start learning Vue.js. And I think it is good and easy if you are going to start to learn Vue.js. But for someone who is fresh and want to start React, it maybe seems very strange to see they are writing JSX and a lot of XML and HTML line inside the JavaScript. And I think for the React, you must to have good backgrounds about the JavaScript. And I think a lot of developers are starting using React.js without knowing about JavaScript, which is really bad because they are writing project and designing things without knowing what is happening. And it can be really dangerous because you are designing something and you don't know about what is happening on the background, and you're not aware the elements where is going to re-render, and the performance of such project when such a developer is working on is really can be dangerous and bad. So my suggestions for the developer for the React will be to learn JavaScript deeply. I'm honestly live a book series about the JavaScript, which is titled "You Don't Know JavaScript," which is really good and nice books about the JavaScript. Anytime I'm starting reading the book, I really find something new in the books, and I think, oh yes, I still don't know JavaScript, and I find something new in the JavaScript, and it's really cool and nice in the JavaScript to find new things after years in the JavaScript. Anyway, so my suggestion is to learn JavaScript deeply, really deeply, before starting with React. But for Vue.js, I think it's not much matter. Maybe you, after learning a general level of the JavaScript, you can start Vue.js. I don't think so. Adnan, you agree with me?
Yes, but I didn't hear the last point you said about Vue, sorry.
Yeah, I just
you
said you agree for the Vue.js, maybe you, or with the general level of the JavaScript, you can start Vue, but for React.js, maybe it is not.
Actually, it depends on which API you're using. So previously, we only had the options API, which was very strict and opinionated. But now with the new API, the setup function, you just write plain JavaScript in your code. So you would need to be more experienced in JavaScript than before to use it. Yeah.
Thanks.
Okay, yeah, thank you for commenting, for sharing your experience and thoughts. Dominik, I have a question for you. So can you give an example of a complex validation scenario that you successfully solved using Zod?
Yes, actually, one of the projects that we currently have under development in my company, in Gorian Software House, we have a multi-step form that is a survey for students. And this multi-step form includes either radio buttons, checkboxes, text areas, simple inputs, and we had to specifically put the schema based on the form that is on the current step of the form and connect it to the TRPC endpoint that handles answering just that one part of the survey. So with and thanks to how simple Zod allows us to define the schema both for the TRPC endpoint and for the front-end form, we can reuse the same schema on both parts of that. So we have a single source of truth that is the schema, and we handle that for each and every step of the form. And this really is a complex validation scenario, but thanks to Zod, it's a breeze to work with.
Yeah, thank you for sharing. I have one more question for Adnan. So can you provide an example of how TypeScript can catch mistakes while writing code in a Vue 3 application, and how this compares writing the same code without TypeScript?
Yes, I showed some examples earlier when the cat updated the type in the backend, and we got notified in all our files that, hey, this type lacks this new property, and we had to update it. And we can achieve this also by checking the files, which is not very efficient, or we can just use npm run type check and we will catch all the type errors across our code base.
Okay, thank you. I have a cheating question, so I'm gonna say it. There was a question that was asked even before we started the first session, and guess it's time to ask your thoughts about AI and what it does for front-end developers, what you're doing for your job. So what are your thoughts? What are maybe your experiences with some tools and in general perspective? So who wants to share something on this topic? Ali, did you want to say something?
I think the front-end roles is about the details and user experience, which is, I think there is no any worry about AI is going to replace to the front-end jobs, because all we can know the front-end jobs and the design job is about the details and user experience, which is really cannot AI do and replace to an engineer at the moment. Maybe in the next years. I not have any kind of idea about the future. And I think we can get help from the AI because there are tons of the package and the AI tools that are helping to the developer at the moment. For example, Google Copilot and a lot of things similar to OpenAI, GPT, and a lot of tools. We can see a lot of package for writing SQL code database, even for backends, and commits AI for writing better commits, and maybe a lot of tools for writing pull requests, merge request text, and maybe a lot of more tools in the moments. But what is matter is it's good for us to getting help from the tools, but we must pay attention where we are going to use AI tools. We must to aware about what we are doing, because sometimes we use the algorithm, we use the code, we use some things that AI generated for us, but we don't know about detail of the code, but we are going to use it in the productions, which has a responsibility for the teams, for the developer, and can be damage to the business, maybe create a lot of problems in the future. By the way, I think it's really, really good to use AI to do the jobs better, efficient in the shortened times, but we need to pay attention and know what we are doing. Yes, I think it is that.
So I would like to share my experience. So I've been using Copilot for the past 10 months now. I mean, it's a great tool. It's like my third crutch. And it's extremely useful for writing tests and the repetitive tasks. But I would not recommend it if you are starting newly with programming, because you need to know what it's generating. Sometimes it does not spit out the right thing or generates something wrong totally. And another tool I've been using, but for side project, is ChatGPT. So I mostly use it to write simple components if I'm working on a side project. And I find that, it still makes mistakes. So you also need to know your thing. And it can be very useful if you want to learn something in detail. And so it can simplify things for you. But sometimes, unfortunately, it also generated some crap. So yeah, it's a double-edged sword so far. It's not at that point where you can just, everything it says is true.
Yeah, totally. I think from my perspective, AI tools are just tools. It's just a help for developers. And I don't think that AI would replace developers, but the developers who better understand and use AI will replace developers who don't. So that's my point of view.
Thank you for sharing your thoughts on this. And of course, this is a complex topic, and with lots of stuff happening throughout this year, at least. And so, I have one question that just came up in the chat for Adnan. How do you verify user authenticated in routes using VJS?
So currently in our front-end application where I work, we use Vue or IDC with Keycloak. So that, and we run route guards before the navigations. That's how I am doing it. We are not using the file-based routing I demonstrated in the show. So, but we can also still use navigation guards with it.
Yeah, thank you. I guess we are right on time to give our attendees a bit of a break. So I want to thank all three of you for joining today for this amazing sessions and for joining this Q&A. I hope to see you on our future events and hope that you also will manage to get something from this event from each other and other speakers. So thank you for joining.
Thank you so much.
Thank you.
Thank you.
Bye.
Thank you, guys.
Yeah, good luck.
See you. Bye-bye.
Yeah. Bye.
Alrighty, so we will go on a 10-minute break. I want once again to remind you that we'll have 5 tickets for tomorrow's senior track for only $99, maybe less. I didn't check, but we should still have some tickets available to get and join tomorrow's senior track of our TypeScript Global Summit. And also want to remind that in September we'll have JavaScript event, and you can grab them for a discounted price. And yeah, we just touched the AI. We'll have the AI in Software Development Conference this July. We are gathering top speakers who are like doing new stuff, using newest tools or representing the tools that are changing the development as we know it. And yeah, and of course Vue.js. Yeah, we touched the Vue.js one. Yeah, please go and register. We still have early bird price for I guess this week only, because the event is actually in around a month, and we'll publish the agenda for the Vue.js event sometime around the end of this week. So yeah, we also have junior track on this event. So if you are new to this framework, we'll have junior track. You can join for free and maybe learn something, maybe try Vue.js for the first time. And yeah, so let's go on like 8-minute break, and I'll give the stage to another moderator, Preston, and three more amazing speakers with their sessions.
All right. Hello, everyone, and thank you to Geekle for that last session where we learned so much. I'm Preston Wallace, Senior Software Engineer at Mountain. I build courses, record online tutorials, and I work in TypeScript every day. And I don't know about you, but I'm so excited to learn in this upcoming session. We have 3 great speakers lined up, including software architects, international speakers, even authors of books on TypeScript. We'll be talking about type safety, tips and tricks, and using build tools like Vite. So the first speaker we have is Stefan Baumgartner, who's a software architect at Dynatrace. Stefan is a man of many talents for sure. He's a software architect working at Dynatrace and also the owner of Odia.dev. He's the author of TypeScript in 50 Lessons, which is a book published by Smashing Magazine. And he's also the author of an upcoming book, TypeScript Cookbook, to be published by O'Reilly. That's an exciting one. He organizes lots of different conferences, ScriptConf, TSConf.eu, Dev1, and Rust Lints. And that is quite a list of accomplishments. So he also enjoys Italian food, Belgian beer, and British vinyl records. Today, Stefan is going to be talking about lies we tell ourselves using TypeScript. Sounds like a fun one. Talking about whether or not we can really trust our statically typed code, whether or not we can even consider TypeScript system strong. This is a really fun talk about trade-offs, workarounds, and ultimately solutions for all the lies we tell ourselves when using TypeScript. So without further ado, let's welcome Stefan to the stage.
Geekle people, I'm Stefan. Welcome to my talk, Lies We Tell Ourselves Using TypeScript. So first of all, you have come really, really far. It's the end of the conference. You have seen lots of talks today, lots of stuff that get you excited about using TypeScript, about all those great features that help you become a better developer. And now I'm here and I want to tell you that I'm sorry. First of all, I'm sorry. This is the part of the conference where I destroy your hopes and crush your dreams, and I'm genuinely sorry for that. So I've been doing TypeScript for a while now, and I do workshops on it, I do talks on it. I've written 2 books on TypeScript. So you can say in the last 6 or 7 years, TypeScript has been a big, big part of my life. And usually I start with this example. This is some JavaScript code where basically every line is wrong. But the JavaScript code does parse. It does run. It just doesn't produce any runtime errors, and it just doesn't work. And that doesn't work because there are subtle mistakes, nuances that JavaScript, trusts values. It's okay with it. And this is a prime use case for using types because, with types, TypeScript can tell you, wait, there's something afoot, there's something wrong. Please look at it. You might want to do something different. But I'm not going to talk about this today. Instead, I'm talking about the total opposite. This here. This is some TypeScript code that, is well typed. It's complete. It compiles, it runs, and it basically just throws errors at runtime all the time. The kind of errors that TypeScript is supposed to prevent. And we are going to dig into the whole example today. Let me move my camera here. It's better for you. All right. First thing first, let's talk about the types. We go all through that line by line, don't worry, but first some context. What are we actually going to do? So we write a function that fetches data from the Star Wars API or Swappy. So if you know Swappy, swappy.dev, it's a RESTful API that you can use for demo applications. It basically maps out the entire system of Star Wars lore with all the characters, planets, movies, whatever. So everything that has any relation to Star Wars is in the Swappy, is in a catalog in the Swappy. So, and the function that we are going to write fetches 2 kinds of data. Either it fetches species, the type that you can see here. It's a nice type that even uses string template literal types. How nice is that? Or it fetches people, slightly different, but in the same way. And here you can fetch for Luke Skywalker, Leia Organa, Han Solo, and which vehicles they were in, which movies they were in, which starships they were in. Fantastic, fantastic API. So that's the kind of data we want to fetch. And then we have some meta information. It's REST API, it's RESTful. So you wrap it in this meta object that tells you the number of elements in your response, a link to the previous or next responses, and it gives you the results under the result key. And this is a generic type. it's matter of T, and T can be, either swappy species or it can be swappy people. Let's look at the code, the main act. Two functions. One fetches data, and the other one concatenates the results to an existing array. And parsing it right off the bat might be a little bit too much, so let's go through it step by step. This is the core of the first function. We fetch some data from the swappy, and we parse it as JSON, and then we return the results. We are not interested in the meta information, just the real deal, the results of the function. We even have some error handling in there. So the developer was smart. They knew that if you call result.json and you don't have an actual JSON output, this whole function might break. So they catch for this error, and then, well, they produce another error, but you could do something like, return an empty array or something similar. Very interesting, we have some function overloads. Function overloads are nice because you can define an API to the outside, one that you actually use, that tells you exactly what to expect if you call either species or people. So we are using string literal types here, like kind is species, the literal string species, and then we get a promise of swappy species back. Or we say, well, we accept people, and then we get a promise of swappy people back. So this is the API that is exposed to our users, and then we have another API that is here for our implementation. Fantastic way to do nice APIs. Perfect. And that was the first function. Then we have the second one, in the end, a simple function that takes two array and concatenates them using the push method. So push ... you can just spread in an array and concatenate it to the list. Alrighty. And in the end, well, we are using our API. We take an empty list and we append data from a call to list entries. Two functions, one fetches data and the other one concatenates the results to an existing array. And that's pretty much your standard TypeScript fare, so actually it's not that bad. We can talk about style or API design, yes, of course, but in the end, it's just code that you or I would write, and many of you might have already written. So this is stuff that is happening in real life. So ask yourself, what could go wrong? Well, actually, I have to tell you, everything can go wrong. And where does it go wrong? Well, everywhere. Every line is just plainly wrong. And when does it go wrong? Well, one by one, because we're single-threaded, brings me to my most favorite JavaScript joke. Knock, knock, race condition. Who's there? I'm sure you get it. Alrighty, let's go for all the problems. Let's see what we can do about them. First of all, welcome to chapter 1, A Tale of Fetch. There's one damned lie hidden in this statement, in the one statement where we call result.json. I'm doing a type annotation here exactly at this position, where I say that what comes back from the result.json call is of type meta-swappy people. And this line only works because the JSON method from the interface body returns any. Any is the happy-go-lucky type in TypeScript. Everything is possible, and if we say that data is of type meta-swappy people, then TypeScript is like, well, okay, whatever. You know best. I just believe what you are telling me. And when you look at this line of code, nothing tells you that what you narrow down to something more concrete, that when you look at this line of code, nothing tells you that this is happening. Nothing tells you that what you do is take something that can be everything and you narrow it down to something more concrete. Because basically, you can write any type in there, and TypeScript would be okay. You can write in meta-swappy people, meta-swappy species. You can write in string array. You can write in promise of response of whatnot. It doesn't matter. Everything goes. And you know what we are seeing here is TypeScript at its boundaries, where the meta world of types that you are creating meets reality. And TypeScript's type system is fragile at those boundaries, which is, mostly I/O, API calls, user input, you name it. And this is where you need to do extra checks to make sure that whatever happens is actually what you intend to happen. As for result.json, we have two possibilities of assigning a type. One is a type annotation. This is what we already did. So let me move that up again. There we go. And the other one is a type assertion as meta-swappy people. It basically does the same thing, but there's a little bit of nuance in there. Where option one is just a happy little accident, something that is just okay for the type system. The other one is an intentional bending of the type system. You are explicit with this type assertion as meta-swappy people. It's your responsibility, and you say explicitly that you want data to be of meta-swappy people. Later on, when you have an error in the application, finding those as calls is much, much easier than finding a simple type annotation. I like to call type assertions to be an unsafe operation, an operation that is as the boundary between your idea of what needs to happen and what the type system is actually able to ensure. And those things happen quite a lot in TypeScript. For example, you have indicators like, well, type assertions, we already had that, or type predicates, where you say, well, this is a particular value, like a number, and you can narrow it down to something more concrete. You can assert that it's just a subset of the bigger set. That's a type assertion, but it's in your responsibility. It's in your responsibility to ensure that this is supposed to happen. Same with assertion signatures, which is basically another way of a type predicate within a different control flow. TypeScript can't figure out if what you're telling it is correct. You need to tell it that this is your intention. And you need to make sure that the function that you're writing there actually works. And all those as and is keywords tell us that something is going on, something that you are responsible of. So you need to make sure that those implementations are actually working. Well, but it doesn't matter because we can simply override it and don't care about anything because any is the hunky-dory, happy-peppy type with any type annotation. There's one type, however, that could help us, which is unknown. Unknown is the cautious sibling of any. Unknown accepts the same values as any, but it doesn't make any assumptions. And we can tell TypeScript to use unknown instead of any at this point in time. And we can do that through a little thing called declaration merging. What I'm doing here is I'm opening the global namespace, I'm opening the interface body, and I say, wait, JSON now returns a promise of unknown. And TypeScript takes this declaration and merges it with all the others. So now I'm creating another function overload, and since it's the last one, TypeScript tells, right, I'm using this one instead of promise of any. And the moment I add this overload, I get a beautiful type error. So this is the function here, and you see the red squiggly line at data. And TypeScript tells me, well, type unknown is not assignable to meta-swappy people. Perfect. Now I need to make a type assertion so I can be sure, well, this is an explicit bending of the type system, or I need to use a validation library like sort or something like that. But I don't swallow types anymore. So TypeScript needs me to do something. All right, the next problem. The theme is dark and full of errors. Let's look at this particular catch clause. It's very curious because, well, arguably a syntax error can happen if I call result.json, but why is there or any? Well, or any is because in JavaScript, basically every error can happen all the time. And you know, in JavaScript, you only have one catch clause. If you come from a programming language like Java or C#, you can catch for each error. This does not work in JavaScript because you have only one catch clause. And second, you can't catch for a syntax error in TypeScript no matter how hard you try. Because in JavaScript, everything can throw. You can throw errors, you can throw objects, you can throw the number 2, you can throw anything, you can throw undefined. A little bit like my 2-year-old. My 2-year-old throws tantrums all the time, and I don't know why. And JavaScript basically can throw any error, syntax error, type error, any number, whatever, what have you. And with everything being throwable, it's just a false assumption in TypeScript to say you are catching for one particular error. There are so many potential problems in the code above that also other errors could occur. This is why somebody snuck in a little any. So the code says, well, it's a syntax error or it's any. That's true. It's either a syntax error or it can be anything. But if you add any in a union with any other type, the whole type becomes any, which allows you to access every property available, even if it's not there. That this code doesn't blow up at runtime is mere chance, and we are not here for chance. The only mitigation for it is, again, going for unknown in catch clauses and do instance of checks. So you can either annotate unknown explicitly, or you activate the compiler flag use unknown in catch variables. Then use instance of checks to make sure you're dealing with the one error you actually want to catch. All right, problem number 3, plenty of problems down there. The metrics overloaded. So I already spoke about the function overloads. They tell me that I get swappy species for the key species and swappy people for key people. And in the code, well, I only return swappy people. But in the signature, it tells me I get species. And in the code, I only return people. How is that possible? This is one of the biggest caveats in function overloading. Those are all the function signatures, and let's see what they mean. I have 2 function signatures. There you go. I need to move myself around again. I have 2 function signatures that expose the usage API. This is what you see when you actually call the function. And one down there, which is the actual implementation. This signature is hidden when you call the function, but it's also what your function body is being checked against. All the TypeScript does is checking if the parameters and the return types from the overloads match the signature of the implementation. Nothing, absolutely nothing is keeping you from returning absolute bullcrap that doesn't make any sense at all. So you can return anything. You need to make sure that what you return actually is somehow in tune with the function overloads. And nothing in TypeScript helps you from preventing you from doing wrong. So either be aware of what you're doing or use maybe a tool like conditional types. So this is conditional types, where I can have a generic type where I do basically the same thing, and I can use that as a function parameter instead of overloads. And with that, since conditional types, I say, well, if the type that I'm getting in is species, then you return swappy species. If the type that I'm getting in is people, then return swappy people. That's okay. And since this type is very complex, so it gives me the same user interface, roughly the same user interface, but TypeScript can't figure out what's going on in there. So you're getting an error here, a red squiggly line, and you get the error that swappy people or swappy species is not assignable to type swappy return. You would need to do another type assertion where you tell TypeScript, well, I know for a fact that this is the correct type. So again, it's just an unsafe operation. You just want to highlight something to be aware that something might go wrong. And if something is afoot, this is where we should look at. It doesn't help preventing all those errors if they happen. It just prevents you from not seeing them. Okay, one more. The unexpected virtue of ignorance, and it's arguably one of my favorites. So I'm having this particular function here, and I see that actually I'd have an error in my slides. So this should be list.push, wait, from not concat.push. Let's assume it's push. I have a function called append entries, and append entries takes a list of people or species, and I push everything from the other array in it. Fair enough. If I'm using push, the parameter list is being passed by reference, not by value, which means that if I'm calling list.push, not concat, I'm so sorry, it mutates list. But look at the actual usage. So I create the list of swappy people, and here I append entries of type species. So what's the type after I call append entries? I just merged swappy people with species. And the type is still people. The type is still people. So I can just enter one of those elements there, call something that is only available in people, and it will break because I actually have an object of type species. For TypeScript, all the contracts are fulfilled. TypeScript says, yeah, within the function, everything is fulfilled. TypeScript tells us it's okay. The problem is that TypeScript can't figure out if the object is mutated or not, which you can argue is actually a problem of JavaScript itself. So what helps here is adding generics. Instead of saying, well, adding the broad type to every parameter, we add one generic type parameter, then can be set to a subset of our original type swappy people or swappy species. We then use T as a type for our function signature. There you go. And yeah, use it in list promise of T. And the thing is, with that, we are able to pinpoint T to exactly one member of the union type. The moment we add list as the first parameter, TypeScript infers the type of list, which is swappy people. And now list entry also needs to return swappy people. Otherwise, we get a type error. And TypeScript tells me, well, the type of promise swappy species is not assignable to the parameter of type swappy people. Fantastic. This is what we want. Okay. Everything mitigated, every potential problem has now a solution. Please enter the final chapter, damn lies in TypeScript. Okay, the story so far. We found 4 problems, but we also found 4 mitigations. So we used declaration merging that allows us to patch assumptions like, well, body.json should return unknown. For error handling, we use instance of checks and the unknown type to help us with error types because it's actually closer to the truth. And then we can use conditional types instead of function overloads to provide a similar API and highlight unsafe operations. And of course, generics allow us to narrow down to specifics. So far, so good. The problem is with every mitigation that I told you, I just told you more lies. Every solution that I had has caveats and has other problems with it. For example, declaration merging. Fantastic, but look at that. I declare an interface called form data, and the moment I use it in handle form, I have access to APIs that I haven't defined. How is that possible? This is because form data already exists as a global type. I merge with the global type, so declaration merging is fun until you accidentally merge with globals, because then your data is just anything. Second, this is my favorite. So I have 2 classes, class R and class B, and they have this do something function that accepts both R and B as parameters. To access the correct properties, I do instance of checks here, So I say if P is instance of A, then access the A property. And this is something that TypeScript can figure out. It knows, well, if P is instance of A, I can be 100% sure that this is of type A. Fantastic. So TypeScript knows that it's not A or B anymore. It's just A. So you're allowed to access this property. And in all the other cases, you can access the B property because if this is A, then this can only be P, all right? Of course it is. So, but then again, TypeScript is a structural type system, which means that you can pass in elements which have the same shape as A, and it will compile. So this here is of type A. It is of type A. It's of the same type as an instance of class A. But the problem is, it's not an instance of A. It's not. It's just of type A. And this check will go wrong, which means that if you pass in this particular piece, you run into the else branch and access B, which is not there. It's undefined. And if you do something with it, it will actually break. So instance of checks are great until you realize TypeScript is structurally typed. Okay, well, and if we talk about conditional types, can anybody tell me what is going on here? I don't know. I don't know what's going on here. And you know what? I wrote this type. I wrote this type 3 months ago. And I don't know what's going on here because it's so complex. It's a entirely different programming language within JavaScript, within TypeScript. If you do something like that, it requires documentation. It's hard to pass. So use them wisely or don't use them at all. Ask yourself if the complexity is worth the benefits. And yeah, last but not least, generics are great until you explicitly make the set wide as it should be. All your solutions debunked again. Okay. Epilogue. Again, folks, I'm sorry, this wasn't a nice talk. You had such a great time learning so much about TypeScript, and here I come, debunking everything, crushing your hopes, destroying your teams. I'm genuinely, terribly sorry about all that. And you might ask yourself, I showed you all the bad sides now. I'm doing workshops on TypeScript. I've written 2 books on TypeScript. TypeScript is part of my life. So what do I think of TypeScript? Seriously, I love it. I love using TypeScript. It's the second best language I've had the pleasure to work with, and I wouldn't want to work without it. TypeScript is not about a sound type system. It's about making you productive, and I can't just argue with the fact that TypeScript makes me tremendously productive. And assume it makes you productive too. And you know what? That's software engineering. You are all software engineers. You're junior engineers, senior engineers. Every line of code that you write is a decision that you make. Every tool or library that you use has trade-offs that you are willing to take. There is no silver bullet. Do you know who also does trade-offs? TypeScript and the TypeScript team. It's an explicit non-goal of TypeScript to be provably sound. They want to strike the balance between correctness and productivity, and this is a goal to make you productive as hell, making all the little trade-offs that come with a type system that sits on top of JavaScript. I mean, come on. JavaScript is a programming language where everything can happen, and TypeScript tries to formalize everything that's going on there to make you productive. The TypeScript team are some of the smartest people I had the pleasure to meet, and I think it's tremendous what they do to fix a programming language like JavaScript that is supposed to go haywire by just looking at it. And you know, I'm not here to tell you what to do. I'm not here for the 5-minute hot takes that go viral on YouTube. I'm here to make you aware that nothing is without caveats. It's about trade-offs, it's about decisions, and it's about productivity. Be pragmatic. Be aware of the trade-offs you make with TypeScript. And use this information to find and choose what's best for you. What's the best way possible for you and your team. No solution is the best thing possible. It's just a solution. It can work for you, or maybe it doesn't. Don't go for hot takes and dogma. And yes, I know that this phrase on that slide is also very dogmatic, but hey, beat me. And with that, I have to say TypeScript is fantastic. It allows us to pick and choose what works best for us. I love it. I wouldn't want to work without it. I want to say thank you for your time. Thank you for spending it with me. And you know, if I might, I'm writing 2 books on TypeScript. One is out now already. It's called TypeScript in 50 Lessons. It's a beautiful book. If you just started out learning TypeScript, it tells you everything that you need to know about the type system. This is the happy path from start to finish to understand how types can help you and how the type system's inner workings work. So this brings you from apprentice to expert, and if you already have some experience in TypeScript, it really leads you to expert class. This is TypeScript in 50 Lessons, and the other one is the TypeScript Cookbook. Will come out in August this year or September this year, something like that, where once you know how the type system works, this one gives you solutions to real-world problems. This is the guide that tells you, well, I have a situation, how do I deal with it? What's the best way to work on it? And the TypeScript Cookbook is full of that. It's 100 lessons more. So both of them should bring you really from apprentice to master, and you have some guidebook for the rest.
All right. Thank you so much to Stefan. I learned so much. And of course, now my hopes and dreams about TypeScript are successfully smashed into tiny pieces. I wanted to remind you all of a couple of things. First, ask your questions in the chat. So these speakers are published authors and internationally requested experts in their field. So you have the opportunity to pick their brain and ask them any questions that might be interesting to you. So I invite you all to write your questions in the chat and have them answered at the end of our session. We'll be taking those Q&A questions at the end of our session. So please do ask your questions there. Second, we do also have a rating system on the platform and in the schedule where you all can vote whether or not you liked the talk, or if you liked it or disliked it. Of course, we hope that you liked it, but we would love it if you could rate these talks so we can gather feedback and improve our future events when selecting speakers and topics and things like that. So climbing off my soapbox for now. Next up, we have Alain Chautard, and he is a consultant at Angular Training. He's a Google developer expert in web technologies, Angular and Google Maps. His daily mission is to help development teams adopt Angular or React and build at scale with the framework. He's taught web development on all 6 continents, He's a world traveler and photographer. I've actually seen quite a few of his videos and photos. Interesting travels. Alain is also an international conference speaker and a published author of several video courses. So today he's going to be sharing with us 10 TypeScript tips and tricks for daily web development. And in this talk, he's going to be exploring 10 lesser known features and tips for TypeScript development that can help us make our code easier to read and maintain. And we're going to be talking about generating TypeScript interfaces, utility types, union types, and more. So without further ado, take it away.
Hey everyone, my name is Adnan, and today I'm going to talk about 10 different TypeScript tips and tricks for daily web development. Even if most of these tips and tricks also work if you're using TypeScript outside of a browser. So as I said, my name is Alain, or just Al. I'm a Google developer expert in web technologies, more specifically Angular and Google Maps. I've been doing front-end development for a long time now, started really in 2011 as a front-end focused developer. And I've been doing a lot of front-end work since then as a consultant, as a technical trainer. My company is angulartraining.com, where I teach Angular, React, JavaScript, TypeScript, and I speak very frequently at conferences all around the world. So that's me. So we're going to get into 10 different tips and tricks. The first one I want to talk about is how to generate type data automatically. Because the thing is, when we work with web technologies, when we work with JavaScript, most of the time our data at some point is going to be formatted as JSON, right? And that JSON string that maybe we receive from a third-party API or from the backend server usually doesn't have the type information for TypeScript. So the idea is to use tools to generate type data, because types are really one of the best features of TypeScript. So we should really use them. So what I suggest to do is use tools such as app.quicktime.io to generate that type data. And this is what the user interface looks like. You load a JSON file on the left-hand side, and with the click of a button, the tool is going to take a look at your code, analyze it, and turn it into a bunch of interfaces with the right types and everything, even using union types or enums based on your preference. All of that gets automatically generated. And if you have 10 different objects in the structure you're copy pasting, you're going to get 10 different interfaces out of it. So very powerful, very interesting, and a huge time saver, because you just get all of that type info in 1 second. So very, I definitely recommend that tool. So that was my trick number 1. Number 2, in the same theme of getting data from a server and doing something with it, very often we have to retrieve information from different endpoints or different APIs. So for instance, we have to make 2 different HTTP requests to build a specific object. And 3 properties come from an object, and the last property, let's say options in that example, comes from another HTTP request. So in that scenario, when we start creating the object initially, we don't have all of the data to put in it. And that makes the compiler unhappy. It's going to complain about it because the options property that we saw earlier is not there. Now, of course, TypeScript allows us to make properties optional. And we could do that. I could say that options is optional, but that's a little bit like cheating. And we want to do better than this. So one option to do better than this is to use the partial generic type from TypeScript. Because when you use that partial utility function, utility type, what it does is that it's going to allow you to have a question object that just has a few properties of the real question object. And that allows you to work with that temporary state, at least as long as you're building that object, and then you can turn it into an actual question in that example. So trick number 3, using union types instead of enums. I'm a big fan of union types, and there are quite a few reasons for this. Enums in TypeScript, they are not that great because they don't bring a lot of features, really. You cannot iterate over an enum easily. You cannot, there's not the flexibility that other languages might have with enums. And I know that I come from a Java background, so I was tempted to use enums in TypeScript, but then I was disappointed that they don't have the same set of features. So that's one thing, not a lot of features. It's just really a list of constants. That's really what an enum is. And on top of that, these enums, they get compiled into a big monster of JavaScript structure, which I put down here as an example. So this code makes your application bigger, right? When you compile the code, when you deploy it, this is going to be there at runtime in the browser. So not ideal because it makes things slower. Instead, what I recommend is to use union types because you get that exact same set of features. You get a type, right? And those don't get compiled into anything, meaning at runtime, this takes 0 space in your JavaScript code. It's not very tiny, it's invisible. So you get all of the benefits of the type checking without the tax of the increased size of your code base in the browser. So that's very important. And one thing that I really like about union types is that you can create types with anything. So here, this gamepad input, up, down, left, right, those are just 4 strings, meaning I don't need to have a class or a constructor or an enum. I don't need a specific object type to fit into the shape of a gamepad input. It's just a string. So that's something that I really like and I believe is very powerful. And of course, you can combine those union types with other things like classes and interfaces and even other union types. So it's not limited to just strings. You can do really anything you want with them. So my next trick number 4, the nullish coalescing operator, or the double question mark. So this is something that's been around for a couple of years now, and it also applies to JavaScript, but TypeScript had that feature a little bit earlier than JavaScript. And the idea is to be able to replace code like what we see here. If value different from null and value different from undefined. Again, something that people who come from Java or other languages tend to still do that in JavaScript. Well, you don't have to, because since TypeScript 3.7, you can do something like what we see down here. Value, double question mark, some default value. Which basically means that instead of doing all of those checks, if it's not null and not undefined, then assign the value, else use a default. You can just use 2 question marks. That's it. And it does exactly the same job. It's a lot faster, a lot easier to write, a lot easier to read. And as always, less code is better because it's going to be faster in the browser. So yeah, think about it next time you use, you have that kind of scenario, think about using the nullish coalescing operator. And I know that JavaScript developers might say, oh, wait a minute, I'm already doing something like this. I'm already using the logical OR operator as to do exactly that kind of scenario. But the thing is, the behavior of the logical OR operator is different in the sense that 0, not a number, and empty strings are falsy values in JavaScript. And so if your value is equal to 0 or an empty string, then the default value would get assigned, which is probably not what you want. Whereas the double question mark operator, the nullish coalescing operator, does the right thing. So 0, double question mark 42, that would assign return 0 in that case, and empty string double question mark 42 would return the empty string. So something to keep in mind, depending on what you're trying to do, one or the other might be a better fit. All right, now let's get to trick number 5, path mapping to simplify verbose imports. If you work on a big application, at some point you end up having lots of different folders, and you have a structure with, you know, nested folders within a folder within a folder. And when you import something from some place, you might end up with, you know, .. /.. or, you know, very long path basically to get to the right place, which works, of course, but it's just a pain to get right and maintain, and it's not pretty to read either. So in an ideal world, it would be a lot better if we could do something like what we see here, import something from shared/shared.service instead of having all of that .. at the beginning. So the solution to get to this is to use a feature called path mapping. It's something you can do in your tsconfig file of your compiler, and in there you can define a bunch of paths. You give them a name, and you specify what they are going to be pointing to. And that way the compiler will know where to find those folders, and you don't need all of these relative very long paths anymore. Okay, now let's move on to trick number 6, which is to use the read-only property modifier whenever possible. So you're probably aware that in TypeScript we can use private, protected, or public in classes and to control the visibility of a property. And sometimes what people do is that they would have a private property and then have a public getter to read it and not a public setter. That way it kind of makes the property read only because you can only get it and not set it. But still, it's not explicit when you look at the code that you want that property to be read only. So in order to make all of this explicit, we have that read-only keyword, which means here it's an interface, so name is public, of course, but we also make it read-only, meaning when we create an object of type person, we assign a name, an age. Later on, we can change the age if we want to, but we cannot change the name anymore. If we do that, it's going to throw an error. The compiler is not going to be happy with it. So that's a great way to enforce that a property is read-only with just one single keyword. A lot easier than any other options available. All right, now trick number 7. And that's another simplification of syntax, which is known as the optional chaining. So this is another question mark to safely access nested properties. So same thing, something I've seen in code over and over again. People would check, is the user defined, and user address, and user.address.city, then assign user.address.city to a variable. So this is verbose. You can make mistakes by, writing that if then else scenario. It's not easy to read, takes space, not ideal. You can achieve the exact same behavior in a way that's a lot more readable using that optional chaining operator. Just question marks like this. It's gonna do exactly the same thing, meaning if user is null or undefined, then city is gonna be undefined. If address is undefined, same thing, city is gonna be undefined. So no matter if any of these pieces is missing, basically, the result is gonna be assigning undefined to that variable, which is exactly what we want, but we save a bunch of if then else syntax in here. So it's a lot shorter, a lot easier to read. And because this is also available in JavaScript, it doesn't make our code any bigger in the browser. So that's also very powerful. So let's move on to the next one. Trick number 8, using type assertions when the type cannot be inferred. So this is something that happens from time to time. We know that TypeScript is very good at guessing the types. It does a very good job at looking at what we're doing, looking at the data, the different assignments we make to variables, and inferring types from that. But in some scenarios, TypeScript just doesn't know what the type of the data is. For instance, here, we read something from local storage. So it's going to be a JSON string, and we turn that JSON string into an object using json.parse. That object could be anything. If we know what the type is and we want to help TypeScript know that, that's where we can use the as keyword to kind of cast that object into a person. And that way, the compiler from there on, if I do user.name, TypeScript is going to know that the user is of type person and it has a name property, so everything is fine. So this is a very good keyword to be aware of. I would say do not abuse it though, because I've seen that sometimes people just try to use it too much and think that it's going to do some magic and automatically change the object into the right shape. That's not the case. You really want to use it only when the compiler doesn't have any idea what the type of the object is. And json.parse, that example, is a perfect one. All right, let's move on to trick number 9. And that's the record utility type to create mappings. This one is very powerful. TypeScript has a lot of different utility types. I think it's something like 10, 15 plus utility types. We talked about partial earlier. Record is another one of those. The idea behind record is that it works like this. Let's say you have a type that's going to have a bunch of values, and you are going to create a new object, like a map, that's going to take all of these values from the initial type and map them to a different value. So in my example here, I have a bunch of currencies, USD, Euro, GBP for British pounds, and I want to create an object. I want to create a type, but then an object of that type. And the object of that type is going to do a mapping from a currency to an exchange rate. So if I have 3 currencies, the object should have 3 different keys. And the keys for these objects are going to match the name of the type that we're basing that map on. So the magic to achieve this is the record utility type, because if I use that syntax and say that my type exchange rates is a record that's going to map currencies to numbers, that's what we are expressing right here, then when I create an object of that type, the compiler is going to make sure that all of the keys are of type currency, all of the values are of type number, and even more important, it's going to check that all of the currencies, all of the different possible types in here are present in the object that we create. This is something important if, let's say later on, a few months later, we come back to that type and we decide to add another currency. Then the compiler is going to do the work for us of checking all of the places where we use that type, and the record here would automatically see, oh, there's a new currency. So the object we created earlier for these exchange rates, it's now missing that extra currency. So that's where it's going to help a lot. It's going to help with type enforcement if in the long run we add or remove new values to the original type. So yeah, a lot more powerful than just using string to number, for instance, because then you would not get any assistance, any auto-completion from your IDE or anything else like this. Whereas this syntax, this utility type is going to do all of that for us. So definitely recommend it. It's a great utility type to be aware of. And finally, I want to get into my tip and trick number 10, which is another utility type called omit. And omit is somewhat similar to partial that we saw earlier. The idea with omit is that you can take an existing type, say person here, and you would create another type out of it. But that type doesn't have more properties than the original interface. It would have less. So here I'm creating a type person without address, which is using the omit utility type. So I'm saying omit person address, which basically means person without address is a person without the address property. As a result, a person without address would have just a name and an email, and the address here would not have to be part of person without address. So kind of a similar use case as what we talked about earlier. If you have objects that you create piece by piece, or you want to just create a new subset of a type with less properties, and instead of creating a separate interface from person, or making address optional in the original person interface, that's a lot better, because now I can create another type where I'm going to say, well, a person remains a person, but in some cases, we're going to have persons without addresses. So we're just going to create that type using that omit utility type, and then the job is done. Nice and easy. So these are all of the tips and tricks that we covered during this talk. The first one, trick number 1, use tools like app.quicktype.io to generate your type information. That's how you can take your JSON data, turn it into a bunch of interfaces, union types, and more that are going to allow you to have your type info automatically generated in just a second and not consume any time on your side. Trick number 2, using the partial utility type to build objects little by little, piece by piece. That way, everything is optional in that object. You can add properties one by one till you have everything in it. Trick number 3, union types instead of enums. We saw that it's better for performance because enums get compiled into JavaScript. Union types do not, and they can be made out of anything, including strings, booleans. So they're very flexible and very lightweight. Number 4 was the nullish coalescing operator. So this is to assign a value if it's defined, or a default value if the input was undefined. All of that with just one operator, 2 question marks, so nice and easy. Trick number 5, path mapping to simplify verbose imports. So no more import ... but just give a name to a specific folder, and that way you can refer to it as you need later on, which gives you a much lighter syntax, much shorter imports. Number 6 was using the read-only properties whenever possible. So use that keyword if you know that we only assign the value once and then we're done. Read-only is going to enforce that and make the compiler fail if someone is breaking that rule. So very important. Trick number 7, optional chaining, the question mark for nested properties. So if you have A.B.C.D, and you want to check that all of these are defined before getting to the value that you need, you would use that question mark in between. So A question mark dot B question mark. And that way it makes everything null safe. And if any of these properties is null or undefined, then the entire expression is going to return undefined. So makes it a lot easier than having lots of different if then else scenarios. Trick number 8, use type assertions, so the as keyword to cast a value when a type cannot be inferred by the compiler. Very useful if you're getting JSON data into an object, and then that object has no type. The compiler cannot guess it, so you would be able to say, hey, this is a person. That object is as person, and that way the compiler knows what we're dealing with. Record utility type to create maps of one type to another. The example I took was the currency, mapping a currency to an exchange rate, or mapping a country to a flag, or I don't know, stuff like this, where you have a list of known values that you want to map to something else. Record is really perfect for this, and it's going to make sure that you do everything right. And the last one, omit, which is a little bit similar to partial in a sense, allows you to define a subset of a type by saying, this is like a person, or this is like that other type with those properties removed from it. So that's also very flexible and can be pretty useful and powerful when you need that kind of flexibility. All right, we covered 10 different tips and tricks for TypeScript that can be used any day, anytime, in any TypeScript application. Thank you for your attention. My name is Alain. My blog is listed here if you want to take a look and subscribe. My Twitter is here. If you have any questions later on, feel free to reach out to me. I'm always happy to help. That's my job. I help people learn web technologies and get comfortable with them. So yeah, feel free to reach out if you have any questions, and enjoy the rest of the conference. Thank you.
All right. Thank you so much, Alain, for that presentation. I learned quite a few tips I'll be using in my day-to-day development. So to everyone, again, I don't mean to interrupt your conference, but I do want to remind you that we want to not miss out on the opportunity to pick the brains of these international experts. So please do ask your questions in the chat. Don't be shy. And I know you're all itching to use that rating system. So please give us some feedback as well in the platform. We want to know what you think about these events. All right, stop preaching, and please do ask those questions. So next up, we have Zaki Mohammed Sheikh, and he is a consultant at Microsoft. He's also a learner, developer, coder, and as he says, an exceptional omelet lover. Knows how to flip arrays of omelets or arrays of omelets. Arrays or omelets or arrays of omelets. Yes. So Zaki will be showing us Vite for TypeScript. In today's talk, he's going to be exploring how Vite can make TypeScript development blazing fast. And to accomplish this, he'll be developing just a silly app, but to explore how TypeScript is jamming with Vite. And with that, I will let Zaki take it away and show us how to use Vite.
Zaki Mohammadiyeh, and this session is all about Vite for TypeScript. I especially want to thank Geekle to provide me an opportunity to take session on this topic, which is a very buzzword right now. And let's understand how Vite can be helping us to develop TypeScript application and our TypeScript journey is more smoother. So before we begin, I just want to introduce myself. I am Zaki Mohammed. I am consultant at Microsoft. I'm a blogger and I'm a developer since 8 years now. And I've been proficient with technologies like backend and frontend, and I've been got a chance to work on cloud also. So let's get started. Today's agenda will talk about the introduction, and then we'll move to the directly to the coding part of it, and then we'll end up with the Q&A session. So before we begin, I just want to highlight my Code Omelette blog. You guys can check it out. It's a coding blog for different technological aspects like C#, Angular, TypeScript, etc. So there is no consistency of it. I post whatever I learned across my journey, and I surely encourage you to please check it out. It will surely help me. Now, coming back to the topic, we'll start with the introduction for Vite. We'll talk about what is Vite basically and why we required it and how it is helping TypeScript to how it's going to help us while we write the TypeScript code, right? So Vite for TypeScript, that's what we are looking for. So what is Vite? Let's answer this question. So it's a build tool that provides a faster and leaner development experience for modern web app project. Okay, so now if more or less, if you just want to summarize it, it's a basically a development server. Okay, so while we develop a front end application or any modern project, real like React, Vue, or Angular, we use Vite so that the development time becomes very faster. So the server starting time and the time to actually see the implemented code on the browser will become way too less. Okay, so right now, if I talk about the current scenarios, if we don't use Vite, we are going, let's say for React, we are going for create React app, and that is using back in the background the Webpack bundlers to bundle the code to serve it to the browser. Okay, so Vite doesn't do all of these things. Vite have its own ideology to we that we have to explore how it is becoming such fast build tool. Okay, so Vite is a French word that is just defining as a fast. Okay, it's just meaning of fast. It comes with a lot of rich features like instant server start. That is the main selling point they are doing highlighting right now. So if you just talk about any vanilla application, it is within 500 ms range also. So the server instantly got start just like any HTML page you open, double click on the browser, just like that. It is like it uses lightning fast HMR, that is hot module replacement. So most of the bundlers now started using this, but Vite is using at a very huge level, and the change you will going to see from your bare eyes that it is really an improvement. Then it is having a lot of rich features, like it is understanding directly the TypeScript inclusion to the actual network tab, and like the actual TypeScript file is loaded to the browser. It's not like it is understandable to the browser, but yeah, it is transpiled to it at runtime, and even JSX support is there, CSS support is there. So many out of the box things are happening with these features. There is optimized build bundling happening, and then there are many typed based APIs, so it is supporting TypeScript also in the background. Okay, so there are a lot of features that you can explore, and let's move on. So why Vite? Okay, so that's a question. So if let's say if you are talking about the in terms of TypeScript, so it will going to surely help us because Vite will be immediate server that will be started. And let's say if we want to explore the TypeScript behavior on the browser, we can use Vite to do our development in a quick way. Okay, so let's talk about the background of it. Okay, how it is working and why it is so becoming popular, right? So if we compare it with the traditional bundling approaches, okay, so let's say parcel, webpack, and roll up anything else. So here we are having a pre-bundling strategy. We bundle the things everything beforehand, and then we are serving the bundled application to the browser. Means then at that time we become server ready. So let's say when you do at any point of time npm start, so at that time entire bundling happens, and then your application available become available to the browser, right? Every time, let's say if I just update the semicolon or if I do some logical changes on the file, any file, so the entire project get rebundled. So if your application is just started and having very lesser module components routes, then it is very quick. But as soon as the application grows, this bundling process will become really hectic and very big. Okay, because you can imagine, like, even though the bundle, the module that is not belongs to you is also get affected. Okay, so that is a, we can say, eager crawling, I can say, preloading strategy, while Vite is providing a on demand strategy. Okay, means nothing is pre-bundled, so you are immediately getting the server ready. Means whenever you do npm start, you will immediately get the starting of your server. Okay, so if your folks are just starting with the TypeScript and having no idea of the npm and bundling thing, then this might little not understandable part. But yeah, so that if you so once you understand the basic flow of npm packages and all, so you will get the idea of this also. So here what Vite is offering is on demand loading. Okay, so it is not doing any bundling while your dev server is running. So it is fully using the features of native ESM, that is native ECMAScript modules. Okay, so here what happening, the server gets immediately started. Now what server will going to run, because everything is now TypeScript based, or TypeScript can't be run on the browser, right? It's TypeScript files. So what it does, it basically transpiles those files, those are required, and the things those are visible right now on the screen, only those things will be compiled. Okay, not the entire project. So only those files will be transpiled, it renders and is displays on the screen. So let's say a route will be rendered, and modules those are related to those routes will be rendered, not the entire application. And everything will be loaded on demand and not loaded on demand. Let's say I don't want, I'm on the login page, I will only require the login components. So that time login components will be loaded. Okay, it's that simple. Now how it is doing this, bringing on the demand files is through the HTTP request. Basically network calls happen from the browser, and the browsers now helps you to do the bundling. So it seems like the browser is doing the taking a job of a bundler. Okay, but yeah, it's basically a HTTP request to get the necessary file and load it while you are develop an application. So this diagram is an official diagram which is there on the Vite website also. Just a tabular comparison, I just kept it over here. So in a traditional bundlers, so we are doing the bundling of the script styles and images and etc. Beforehand, while here we serve them directly. Okay, here it is obviously a slow start, that is eager crawling, while here it is on demand and the fast pace we can see. Okay, then slow updates, rebuilds bundle means whenever we do some changes, the entire bundle entire project will be rebundled. Okay, here using HMR native SMs, we are actually not rebundling the entire application. So here we are not bashing about the webpack bundlers and bundlers in general. We are just focusing on the Vite, what it is actually offering. Okay, moving forward, now how we can use this utility of Vite for TypeScript. Okay, so there is an option, and there is a huge opportunity that we can go for Vite. And while we are understanding TypeScript and we are developing any TypeScript based application, let's say if it is in React or Angular, nothing else, even with the vanilla TypeScript you can use Vite. Okay, so let's say you just started with the TypeScript, so you can if you want to create a full-fledged JavaScript based application without any framework, without nothing else, so you can go for Vite, and you can create a vanilla TypeScript application where you can learn TypeScript plus you can learn the basic JavaScript development also. Okay, so moving forward, here you can see Vite for TypeScript benefits. Okay, so obviously if you are doing a TypeScript based development, you get the type safety, fast development experience because of Vite, quick debugging. There are debugging options also available, I'll show you in a while. No hustle with modules. Now if you have tried to load TypeScript modules directly in the browser and the HTML pages, it have a lot of problems. Okay, it need to be bundled properly, so you might have to end up with any Webpack bundler or any rollup or something like that. Okay, so that your imports become smooth without any hassle. And then power of importing .ts file, so you get the benefits of importing the directly TS files in your code. Okay, so that's the beauty of Vite, that it will going to allow you, which I'll going to show you in a while. Okay, so the approach will be little different here. So let me just move forward now. Okay, so here I'll just going to directly jumpstart my application, where we will just going to see how we can create a basic kind of application from scratch using Vite and TypeScript. Okay, and then we'll explore more about the understanding of Vite, how it is working from the background. We'll even visit the website also. Okay, so let's get started with this. So there are some prerequisites before we begin. Okay, I just want to highlight them, and we can do the initial setup, run the application, debug, and build it. Okay, so let's get started with the prerequisite. So here, if you can see, we required Node.js. That is a must because we required a Node.js version of 14.8 plus or 16 plus. So make sure you have that. Otherwise, Vite will not work properly. Any version of TypeScript is fine. Vite obviously required, and VS Code is the ID that we're going to use it. Okay. So let's directly jump to the coding. I'll take a directory and I'll show you how we can get started. Okay. So this is an empty directory from where we can get started. So I'll just open the CMD over here. Okay, so let's check first which node version we are actually having. Okay, so if I do this, so we are having 16.14.2 version. Okay, so we are okay with that, right? We already seen the requirement that it is having a requirement of using above 16 plus, right? So we are good. So let's do the command. Okay, so there is a command called npm create Vite @latest. We'll just do this much. Okay, I'll show you on the official website also. Let me bring that on the screen so that we can understand like how it is offering and from where I am getting to this part. So if I go to the Vite website, so here it is. We can directly jump to the getting started part of it. So after explaining the things and all, here you can see npm create Vite latest. That's what we are doing. So let's try that. I'm entering this out now. So here, if you notice that we haven't given any application name, right? So let me give a Vite app. Okay, And here you can see a bunch of framework selection options is provided. Okay, so we are going with the vanilla. You can even go with the React and Servlet or Vue also. So I'm going with the vanilla and I'm choosing TypeScript over here. So that is a out of box TypeScript support given just to a starter application. I'm entering in this. Now you can see bunch of useful commands mentioned already over here. So here it is providing first option to go with the within the Vite app directory, then doing the npm install and then npm run dev. You can notice that this happens very quickly, right? And if you go if you see this option is also even provided, and you can see the further commands are there. So this operation was really very quick. We'll understand why it is this much quick, but let's go first inside this directory. Okay, and also if I just open the directory and if I just check what kind of folders things are happening over here, so you can notice that bunch of files are created, but there is no modules, node modules not nowhere to be found, right? So what is happening? It is understanding the behavior of like normally what other package managers does when they create the project or create the folder. It immediately directly goes to install the npm modules also. Here it is leaving that opportunity to us, so you can now do npm I. It is creating the package.json file, but it is not doing the node module installation. It is leaving that to us. Okay, so now you can install it from your end. Okay, then there is a last command, that is npm run dev. So let's directly run this and we'll see on the browser like what happens. So I'll just grab this command meanwhile it is getting installed. Done. Let me just paste this command. I'm running this. Okay, you can see that it is ready. It got ready within 366 ms. Okay, within a millisecond, right? And you can see the port here, it is actually getting executed. So if I just open this port on the browser, you can see our actually working project over here, which is developed based using Vite and TypeScript. And there is a button also that is just a counter button. I just increment that so it will be working. So if I just right click and inspect the element, I'll show you like what we were talking about. So if you go to the network tab, just refresh this, select fetch xhr or any all option also, it's fine. So you can see that even TypeScript getting loaded over here. That is really amazing, right? That is not usually happen with the TypeScript. But if you notice that here nothing like TypeScript is happening, actually JavaScript code is transpiled. So what is happening under the hood? It is actually transpiling to the JavaScript code, but here it is giving us the opportunity to loading everything as a network call, not while bundling. Okay, so at the development time you get a lot of TypeScript file also in the network tab. So let's open this project in the Visual Studio Code and let's get started. I'm just opening this in a VS Code. So let me stop this. I'm going to the code. Cool. So let's talk about this. Now we have got the node modules. Now we have the package.json and there is a source folder available. Okay. And if I just go to the package.json, that is very important file right now. And if I go to this and here you can notice that there are a bunch of dev dependencies. Those are TypeScript and Vite. Okay, nothing else is got installed, and you are getting bunch of scripts. Okay, Vite and then later on these things. Okay, for build and preview. Fine. So that much for Vite. Okay, nothing else is added. Only two dependencies, and you are able to run your application. And other things are like index.html, tsconfig. So if you go to the tsconfig, a generic tsconfig is there, but with the configuration that supports bundling. Okay, so you can see bundler is open, isolated modules is also true, no emit is true, and there are linting support. There are setup of the source directory of it. This is the source directory, and there are some bunch of target that is pointing to ES 2020. Okay, so this much is there for tsconfig, and you can see an index.html file that is outside, and there is a div called app id with the id app, and there is, you can notice that a direct TypeScript file inclusion in the body itself. There is no JavaScript sign of JavaScript, right? Because this is TypeScript based application. Now coming to this app main.ts file, we'll understand and explore like what kind of things are there. Okay, so if I go to this source folder and there is a main.ts file. If I expand this, you can see now there is a code written for style.css. And so even though it is a normal JavaScript based application, vanilla application, but it seems like it's a React application if you have already seen React app. So here you can see the TypeScript files are directly added. The images are also directly added to TypeScript file, while CSS is also added. So there is nothing like a link happening over here for the CSS. It is directly included to the TypeScript file. So that's amazing. That's how you actually develop that's bring you more closer to the framework level development, how what is happening in Angular, Vue, or React, right? So, and obviously the TypeScript supports are everywhere you can see right now. So this is just a existing application which you can check and how it is built up, so that I am leaving up to you guys. You can explore it, but I'm just now removing every boilerplate code and we'll get started from the scratch. We'll develop something and we'll see how it is, how difficult it was to develop something from scratch for TypeScript. Okay, so let's give it a shot. I'm just removing everything and then later on we'll bring if required. I just go with the hello world approach like usually we do. And let me just remove everything from here. So this is all fine. I am removing the div tag also. And let me just remove the counter TS file also. So everything is gone. Fine. So I'll come back to the browser and I just refresh this. I guess I have turned it off. So let me start it again in the terminal. I'll just do npm run dev. Okay. So this again start the server. I click on this one. We got the server running. Okay. Nothing is there because console log you have just done one thing. So let's see whether the console log is shown or not. So if I go to this, we are seeing our hello world over here. Cool. So that much it for just was the starter. And let's write something, build some application. So in the screenshot I have just shown some application over here, right? So that application is just a factorial finder application, just to get started from somewhere, right? So for that I'll go with the CSS library called Pico CSS, just to do the basic so I'm just removing everything from here from the style.css and I'm adding the Pico CSS over here on the style. Okay. Coming back to index.html, I am going with some boilerplate code for my UI. So bear with me. If you are already well versed with the HTML, you can easily understand. This is a very bare minimum code we have written. A form is there, a label is there, and a button, two buttons are there, and a hidden card is there, which is not shown, but it will be shown once the factorial is found. So if I come back to the screen, you can see this like this behavior because the style is not imported right in that main.ts. So you can do one thing, you can import the ts file directly like this. Okay, so just provide the path and just save this. And if you go to the this one, you can see the application is now behaving a little well, right? So that's it. You can even include the css also over here. Now let me just create one file for finding the factorial. So I'll name this file as factorial.ts. And I'll just grab one basic function that is written in the TypeScript format. You can see find factorial, we are passing a number to it, and then it is returning some number. Okay, so it's a recursive function. You can check it out. It's a basic function that will just do the job of finding the factorial. Okay, now let me just bring the boilerplate codes for this one, and we can read through it. Okay, so I'll get some of the bunch of the functions over here. So if you can see, there is a result, article, form, input. So we are just grabbing the input elements over here. Notice that in the query selector, we are mentioning the type of the control also, that this is an element, this is a form, this is input. So likewise, we can get the TypeScript support also. Okay. So, but before we just begin, I just want to show one thing, which is very important. Let's say if I am creating a flag variable called Boolean. Okay. And this Boolean variable is setting to true. There is no problem in this. If you go to the browser, it is all fine, all good, no problem. But let me just assign it to a string value. That is logically not allowed. In the IDE, it will give you an error, but on the browser, it is not giving any error. So is it that TypeScript not supported over here? No, it's not like that. By default, Vite doesn't do the type checking. It does the transpiling of your file, but it doesn't do the type checking. So in order to do the type checking, we have to install one more package that is provided from Vite. So let me install it. It's a package purposely created just to do the type checking, because they are removing the type checking from the normal process, because it will add up extra effort. So it is relying on the IDE or ES linters if you are using it. So they are upfront saying that use any IDE or use any ES linter to solve this problem. Otherwise, the Vite doesn't do the type checking. So if you want to do the type checking, you have to install this as a dev dependency. So we are installing Vite plugin checker, that is also as a dev dependency. Okay, so make sure you do that. Now, if once this is installed, we have to do one more file. We have to create one more file, which is called vite config.js. Okay, so let me just quickly add that. This needs to be added on the root. Okay, this will be just a JavaScript file that is having this feature. I'm just pasting the code for just quick finish up of this session. So here you can see I'm importing the checker, and the checker function is called over here, and we are enabling the TypeScript. That's it. Now, if you just run the application like how it was running before, so let me just stop the server and let me get started with our npm run dev. So let's see whether now it is giving error on the browser also or not. Okay, so here id is obviously giving the error, but not the browser. Okay, so the time little bit increased, but if I go to the go to browser now, let's see. Yep, we are getting the error, right? It is showing that this result is also not being used, this is not used, and there is a problem with the flag variable. It is not in a correct type safe format. Cool. So now it is giving the proper warning, and even for the warning also it is giving you error like. So nothing is tolerable, right? So let's get back to the code. I'll just complete this code. Like I'll just create bunch of uh, handlers. Like let's say when user clicks on the find factorial button, there is a button. When user click on this one, we do need to do something, right? So let's create that handler. So I'm just creating two handlers over here on submit. So there is a method called on submit. So what we want basically, so if you can see the types in script essence is everywhere. So we want to get the value whatever inserted. We just check for the error checking. If it is not provided or something like that, we then do the find factorial function call, right? So let me just do this, import the factorial file, and that's it. And then we are removing the card and then showing the result. This is on submit. But yeah, let's grab the code for the event handler. So I have to attach this to some event handler. Okay, so now if I save this and I go to the browser, I'll just provide phi and find factorial. It is giving me 120. Okay, so this is working fine. Cool, no issues in that. So if I even not provide anything and if I do this, so it is giving me this one. But what I want, I just click on the reset. I want to reset the form, plus I want to get rid of this card also. So I'll just write a very basic handler for the reset button. So I go over here and I just paste this code. On reset, I just want to set the attribute to be hidden also, and the default functionality will be same. So I'll just grab the code over here, this much. So this is the code that we are looking for. The reset will also should also work. So if I go to this and if I do 4 factorial is 24, and if I reset this, the card is also gone and this also got refreshed. So this much it for the development. Like we are getting a TypeScript support. We are now able to full-fledged develop something from scratch for the TypeScript, right? So that's how we do. And what left is about the debugging and the building part. Okay, so let me show it quickly. So let's say if I want to do the debugging for it, I want to see immediately run this, and I want to understand like how I can put a breakpoint or something like that, right? So you have to do one thing. You have to go simply to the IDE window called run debug, go to the debug URL. But before doing that, you make sure you change the port of your uh, serve when your file is actually got served. So make it 4000, and just go to this one, go to the debug URL and provide your debug URL from here only. Let's say my debug URL will become http 4000. Okay, so if I run this, you can grab the localhost from somewhere. Let me just quickly grab it from somewhere. I don't want to type it again and again. I'll grab it from somewhere and I just provide it to this debug URL. Okay, so I have provided the 4000 URL, and here it is showing me that make the launch JSON file also. So I'll just made it. So now if I run this, let me just put a breakpoint somewhere. Okay, I'm making a breakpoint over here. Okay, let me just restart this for now. Okay, I'll try to run this again. So this immediately starts a window, okay, for us. Okay, I don't know what happened. Okay, let me run. Sorry, I haven't run the terminal over here. So let me run an npm run dev. Okay, so now it will going to serve on port 4000. Let me start this also. Okay, your application is running. Let me just press 4 and find factorial. Now you got the debugger. Okay, now you're on this line and you can see bunch of variables on the left side also. Let me just do the F10. You can see the value which is coming as 4. So simple as that. You can do the debugging. Just provide the URL of yours and then it will start doing the debugging. Let's end this session with the build command that is there over here. Let me just run that. So right now we know that this is all good for the while we are developing the code on the dev environment, right, for the developers. Now let me just build this code how it looks like. So here there is a command called npm run build. It does the same thing. Now it uses the bundler. Okay, now it uses the roll up bundler that is there in the background, and it uses it to bundle the application. So here you can see this folder is generated, and they are providing one more feature that you can even preview this build version using the preview command. So if I just do this, my application is now running, and this application is the bundled application, not the one which is serving the TS file. So if I go to this network tab or something like this, and if I just refresh the code, here I'll get the JavaScript file, not the TS file. So this is how your application will look like on the production. Okay, so coming back to the slides, I'm just wanted to wrap up this session, and you can see this commands I have already shared on the slides. You can check it out. All the necessary thing to run the application, we require to do this, and run dev, and then debugging, we require to add a VS Code launch file. That's it. And building application, we have seen build and preview command, right? So I'm waiting for the Q&A, and I'm looking forward some good questions so that we can have an interactive session on this one, right? And just please consider following me on this channels, and hope you enjoy this session, and have a great day.
All right, wonderful. Thank you, Zaki, for that talk. And I'm going to invite back to the stage a few of our speakers here, Stefan and Alain and Zaki. And yeah, so we have a few questions lined up here. So first one is for Stefan. Where can I buy the PDF version of the TypeScript in 50 lessons? There you go.
Oh, thank you very much. Fantastic. So you can buy the PDF, EPUB, and MOBI versions also on Smashing Magazines. So the book is being released by a very small publisher, Smashing Magazine. They are doing mostly design books. It's one of the first programming books that they have. And they have a carefree package where you can find the PDF, EPUB, and MOBI versions, all, I guess, for around about 15 to 20 euros, I guess. But don't pin me down on that. It has been a couple of years already. But yeah, thank you for buying my book. Thank you for buying my stuff. That's fantastic.
Wonderful. All right. So the next up is a question for Alain. What is the difference between A equals value, question mark, with this A value, or operator, some value?
Oh yeah, that's a great question. So the double pipe is just a logical OR. So it was designed to work with Booleans initially, but because JavaScript kind of considers a few things as truthy or falsy, it used to kind of work in many scenarios, but it's not perfect. So the short answer is you should be using the double question mark, really, because that's really designed for that purpose. Check if something is null or undefined, else use a default value. Where the other one is going to do mostly that too, but there's some cases like empty strings, a number 0 or stuff like that, that's not going to behave exactly the way you would expect. So if there's just one thing to remember is just use a double question mark, because it was created for that purpose of, is the value defined? If so, use it, else use a default. So that's really the one we should be using from now on. Yeah.
Awesome. Great. And this one is for Zaki. So what might be some drawbacks of using Vite?
Okay, a great question, because everyone is just talking about the best stuff, right? Okay, so what I have personally observed that it is not providing, first of all, the direct approach for TypeScript, because it is restricting the type checking for obvious reasons. It is just doing the transpilation. Okay, the type checking, we have to go with the one more plugin that we required, and it little bit adds up the timing for running the application. So that is upfront I have found. Later on, most of the thing is it is doing on the servers for the developers only. So the production build and all those things are still taken care by the other third-party packages like Rollup and something else. Okay, so they have to work on that area. So not as a drawback, I can say, just missing piece, I can say right now.
Okay, awesome, great. Yeah, it's always good to not just give the pink and rosy picture of everything, right? Okay, so here's one for Stefan. So you mentioned that in JavaScript, everything can throw an error for any reason. So when catching errors, do you recommend writing explicit types for the error itself, like the type of error?
That's a very good question, because it's a very tough question. So the thing is, in fact, you can't prepare yourself for catching the right thing in JavaScript, because there might be some hidden API that throws anything, or maybe a type error that's happening, or a syntax error from a module that you're loading remotely in some way or form. So doing this throw error, catch error patterns that from programming languages like Java or C#, that's kind of not possible. So I usually say, if you are using try catch, or a promise where you have the then callback and then the catch callback, always prepare for the biggest set of possible values, which is unknown, and also go for unknown and not for any, because TypeScript will require you to do a couple of extra background checks if this is really the one type that you're looking for. And then either go for instance of checks or check for certain properties so you can do control flow analysis, that you can narrow down the big set of all types to smaller types, like is this a string that is being flown, or is this an instance of type error, instance of syntax error. If you want to have your own layer of errors on top of it, I would suggest looking into the Axios library. It's a small library that handles fetch for you in different platforms like the browser or Node. They are throwing Axios errors, and they have added a couple of very interesting methods to it, or functions to it, where you can check if the thing that you pass in is actually the error that they expect it to be. Doing property checks, checking for internal properties that you just attach to the Axios error. And then they use type predicates to say, yeah, this is right, this is the one error that you've been looking for. And this is, in my opinion, a much, much more robust way of dealing with errors than trying to, have to strike catch patterns that you know from other programming languages. Or just don't write any buggy JavaScript code. It was just
right. That's the real answer, right? Don't cause errors.
Don't cause errors.
Yeah. Great. Awesome. Great. Okay, so another question for Alain. You mentioned that people tend to use the as keyword when performing type assertions. Could you elaborate, maybe some examples of when it should not be used, or alternatives?
Yeah, sure. So when I see it used, sometimes people use it as a replacement. So let's say they declare a variable, and instead of saying variable column type of the object equals blah, 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 they don't declare the type here. They just do the assignment and then as something, which is not the way TypeScript was initially designed to be, right? You don't have to do a cast type assertion if you're just declaring a variable and you know what the type is. So that's one scenario where it doesn't make sense to do this. And basically the idea is you don't want, what I've seen done too, and that's really cheating, is people take an object that doesn't have exactly the right shape and they try to make themselves believe that it's going to work. So they cast it in something else. And then they're going to say, oh, well, we just have the 2 or 3 properties that we're working with. So that's plenty enough. It should work. Well, yeah, if you're lucky and if you know what you're doing, but it would be much better to have a specific interface. If you want to use a subset of an object, just a few properties, then just create an interface for that and say, I'm dealing with that temporary, object with just 3 properties. It is of that specific type. Basically the type system is great, and we should not try to work around it. We should use it as a friend, an ally, more than anything else. So using the as keyword, usually, I do a lot of code reviews, and when I see it used in those code reviews, typically people get it not wrong, but they tend to abuse it maybe 80% of the time. So there are other alternatives. You can create your own interface if you want to do something that's really more like a cast. And if you know the type right away, you can declare your variable of that type. You don't have to use the as keywords. The only example, really, the one that I mentioned in the talk, is if you read something from local storage or you do a JSON parse, then of course you get something that's a plain object, and you have to say this is of type X or Y. So in that scenario, the as keyword makes perfect sense. But in other scenarios, you can use other tools. So
100% agree. So thank you for saying all that.
If you have anything else to add, Stefan.
No, I don't have anything to add, because that was just perfect. So I like to see the as keyword always as a hint that an unsafe operation is happening. It's like if you stumble upon in your code, look out, here's something happening. Here you are bending the type system to your will, and this should be used very intentionally. And just like Alain said, in all the other cases, a type annotation is just what you want. But here it's like, oh, wait a second, something is happening, look out for, and you should be able to find those situations later on, because you're possibly going to look at code much, much longer than just the moment that you're writing it.
Exactly. It's an exception. It's a last resort when you don't have anything else available.
Great. Awesome. So this next question is for Zaki, and I'm not sure if it's a typo or what. I don't know if you can understand what is VVTE. I was trying to Google it. Is that a thing, or maybe they meant to type VITE, Vite, and NX. Does the question even make sense to you?
Not much, maybe, or we can say, is it a difference between Vite or some other traditional Webpack bundlers or any other bundling tool, I can say. So if it is going in that direction, then I can say, yeah, the comparison is straightforward. So it's just a, I can say, approach difference over here that Vite is doing. So if we compare Vite with any other existing bundling tool, they are doing the pre-bundling kind of approach, like on initial let's say if we talk about lazy loading or initial loading, right? So it's kind of same thing. So they are not doing initial bundling, they are doing on demand bundling, and here they are smartly choosing browser to do that. So instead of having any tool to do this, they are relying on the browser, and that is the, I can say, upfront difference between traditional and Vite, if we want to compare them. So I'm not sure about what next. I have to check. Then I can answer properly. But yeah, if we are just comparing with the Vite, because right now I can say Vite is the only candidate right now that is doing in this way, and we have to go along with it a little bit so that we can find more pitfalls and areas. Those are gray for this one. But yeah, though right now React, Vue, and all these things are actually marrying with the Vite, and they are providing their servers with the enabled with Vite. And recently Angular is also launched. They are also having in the version 16 an experimental support for Vite. Oh, that's something like a game changing thing for Angular also. So yeah, I can say.
Okay, wonderful. So here's one for Stefan. You mentioned that declaration merging can lead to accidental merging with globals. Is there an example that you could share of when this has happened, or it might happen, or how it can be resolved?
Yeah, so actually the one that I had in my slides was actually an example that comes from a real world project where a friend of mine was writing interface form data because that was coming in from a form. And they wanted, after the parsing, those were the properties that they were expecting to have. And form data is actually a global type that includes properties that come from a submit, so from a submit call, and you intercept the submit call, and then you can, have a map where you can get and set different values. And they were confused because they were just adding form data as part of a do something function in an argument, and then there were all those other properties appearing, and they didn't know where they were coming from. Yeah. So this was ripped directly out of a real world example, stripped down so it fits on the slide. But it was interesting. So if you don't know the difference between an interface and a type, and you have those globals, maybe also because you added some third-party libraries that pollute the global namespace, because that is what we did 10 years ago in JavaScript anyway, where we didn't have a module system. We just slapped in everything in the global namespace, and we're going for it. And there's still libraries out there that do it like that. And it can just happen that they pollute the global namespace, the type namespace, and that you need to be aware that, well, maybe there's an interface already declared, and it doesn't cause an error. So if you just rely on types for your inner system, or for everything that you consider within your boundaries, then you get an error the moment you're writing a type that already exists as a global interface, and then you can say, oh wait, that's great, I need to keep that in mind, and I need to check that out. But other than that, so I'm a huge fan of declaration merging because I constantly bend the opinions of everything that has come from the standard type definition files, because I don't know, I like a little bit of anarchy in my type definitions.
Great. So another one for Alain, and I think we have a code snippet here that can be shared. Great. So in the enum type here, we receive a hint of possible variants. Is it better than united type?
So let's see. So you have a union type, left, right, up, down. You have the enum, left, right, up, down. And then check union, data equals up, returns data, check enum, blah, blah, blah. Is it better? Ends of possible variance. So I'm not sure what you mean by possible variance. So the point I was making in the talk is that if you have 4 values like this, a union type is going to be very lightweight in the sense that it doesn't get compiled into anything. So your application is lighter, especially if you're working for the web, right? If that code is meant to be deployed and run in a browser, then the unit type is more performant because it doesn't get compiled into anything. So you get the benefits of type checking without the downside of increasing the size of your production code. The enum here would be compiled into something that's bigger than you expect. So that's my point. I like union types because for 2 reasons mostly. 1, they're super light. They don't get compiled into anything. And 2, they can be just strings like this, which in JavaScript in the browser is perfect because we deal mostly with strings, right, on the web. And being able to just assign a string to a variable and still have a type associated to that, I believe is great. The enum forces you to use, enum type.left. So you have to use an object. You have to use a structure that's not as flexible as a string and typically requires a little bit of extra work as well. So that's why I really like union types. They're both easier and more performant to use. That said, an enum doesn't hurt from time to time. You can still use them if you want to. And so I guess the question was about, we can receive a hint of possible variance. This also works with union types. So if you use a good IDE, WebStorm, VS Code most likely does that too, and probably others. As you type on your keyboard, it's going to suggest all of the possible values no matter what. So the IDE doesn't make any difference whether you use one or the other, usually.
Great. Wonderful. Yeah, and thank you to whoever wrote that.
No
beautiful code snippet example. So here's one for Zaki. Do you feel that Vite is opinionated or not?
Okay, it's a tough question, I can say. So it have its own certain set of rituals that we have to code in that way. So it is a little bit opinionated and not fully, I can say. It is actually reducing a lot of layers from upfront that we when we start a project. Okay, what I have personally observed that when we start with any project, or let's say any spy application or any application, we go through a lot of rituals and ceremonies. Like we go with the npm minute, and then we get bunch of files, node modules also getting. So Vite is doing all of this thing, but just it is doing on demand and slowly, not beforehand it's doing. Okay, so some of the things it is actually reducing, but ultimately if you are doing some enterprise level application, you have to stick to the core things that Vite is offering and what kind of capabilities it is having under the hood. So yeah, it is slightly opinionated. Once you start doing the actual work, then you can see that a lot of things are we have to do as per the suggestion that is provided by Vite, and the way it is providing the developer support and all. Okay, so bunch of packages we can find, and we have to include them as our application grows, that I have personally observed. And they are also doing in a lot of areas in the unit testing and debugging areas right now. So they have their own unit testing framework and all. So that I can say they are slowly going through this opinionated area, that they are controlling the things. Now I don't know in future whether every project will have the Vite unit test casing and Vite kind of the tools and all, so that we have to check. But right now it's if you are having starting just like how React is offering, right? You can scale it up to the enterprise level also, but you can narrow it down to the very small applications also without having much things. It's up to you, like how much things you want to add and how much proficient you want to make it.
Okay, good answer. All right. And then this one is for Stefan. What's the significance of the parrot on the TypeScript cookbook, or really the other animals? Like, what's the story there?
It's a fantastic question. So I have two answers to that. So first one is the official O'Reilly answer, because they've started using animals, I guess in the late 80s, when they were releasing the first in a nutshell pamphlets, where you had just a couple of in a couple of infos to a certain Unix command like set or awk or whatever. So they were just trying to teach you it very briefly, and they just put on a couple of really ugly apes, like the big apes with the huge, or the small apes with the huge eyes. I forgot the names, but they are very significant, and you still find them cluttered throughout the O'Reilly page. And they found out, so they were basically the O'Reilly CEO back in the day was talking to his neighbor who was a designer, and they were like, "Yeah, I have an idea. Let's just slap in some really ugly animal," and with that, people suddenly see this book over all the other books in the bookshelf. And this was the original idea of the animals. Talking about the parrots on the TypeScript cookbook and on all the other TypeScript books. So I guess the TypeScript book by Boris has a deer on it. I'm not entirely sure. The TypeScript books by Dan Vanderkam and Josh Goldberg, two of my O'Reilly fellows, have already birds on them. And I got a plum-headed parrot. And so it's in the theme with the birds. And I don't know why they've chosen birds. That might be one reason, but I'm particularly, and that's answer number 2, particularly happy about having a parrot, a plum-headed parrot there, because my Twitter handle and social media handle for the last 10 to 15 years has been that parrot after the Monty Python sketch from the 70s.
Really?
So I don't know if they planned it out like that they just wanted to hit it home with another parrot on the cover. But you can't believe the moment I saw the cover, I was delighted. I was frantic because it was just nailing it, just having like making the dead parrot story come full circle finally. and that's why it feels really, really good. And I haven't sent the colored cover yet, so they are going to create one in color that is going to, I don't know, I will get it probably next month or so, because we are now entering production phase, so it can hit bookshelves in late August, early September.
Wow. Yeah, congratulations on that one.
Thank you very much.
And wonderful backstory on the animals on the O'Reilly books. Great.
Yeah, so I never know if it is coincidence or if they just wanted to hit it home, but yeah.
Great. So this is the last question in this for Alain. When using the omit utility type, are there any potential issues or drawbacks that developers should be aware of when omitting properties from a type?
Not really. So the idea with omit is you have an object that you know has most of the properties of another type, but some of them are removed. And you don't want to create a brand new interface that's going to say, hey, we have 8 out of 10 of this, and just copy paste those properties. So you're just going to say, it's the same as this guy, but with no address or no something else. So it's a nice and easy way to do it. I would actually say that it's more a benefit than a drawback. I don't see anything negative about it, really. I wonder if my colleague speakers have anything negative to say about omit, but from my perspective, it's all good. It's actually better than other options, especially because if you base your type on another one, if the other one changes, then this one automatically gets updated as well, in a sense, right? If you add a new property to the one you're basing the omit on, then it also applies to there. So to me, it's a better option. But I can't think about issues or drawbacks using it.
Yeah. The only thing that I could think of would be maybe that it's if you wanted to create a different type and then you started changing that type a little bit, you change the original type that was being extended from, then it might cause issues when
you can get to a side effect.
Typical inheritance problems.
Yeah. Mm-hmm. Or if you take something that has 10 properties and you use omit to remove 9 of them, then maybe it's not a good idea.
That's a good point.
Yeah, just like any tool, right? Any tool can be used in a very wrong way. It's just a matter of common sense, I would say.
Yeah. All right. Well, that about sums it up. Thank you all for speaking. Those were some wonderful talks. And thank you all for coming to join the talks today. And that, I believe, that ends the day. So we'll see you all tomorrow.
Thank you.
Bye-bye.
Bye.
Bye. Thank you. Bye.
All right, sorry for the delay. Let me just wrap this live stream. Thank you, Preston, once again for moderating, for joining for a second event. And yeah, we'll see you. We'll see you tomorrow. Yeah, sorry, I needed to double check that. So yeah, we'll see you tomorrow. And yeah, so I want to wrap this up by reminding everybody that we have senior track tomorrow. I guess most of you who are here have already tickets for that. But if you don't have, please go ahead and check the schedule and take a look at the offer that we should still have like a ticket or two for you. I'll need to send you the link once again. Please leave your feedback on the talks that you liked. So if you just joined, for example, if you'll be watching the previous sessions, please go to our schedule and there is a like button that you can click if you like the session. I would also remind you that we have more events. We have lots of TypeScript and JavaScript events and not just that. So reminding you about this offer that we have TypeScript tomorrow. Reminding you that we have a JavaScript event this September that, of course, will have even more speakers and lots of different stuff on like JavaScript, Node.js, and definitely some React bits. And we also have UGS this June. So definitely the topic that was caught upon in the chat, and definitely we can continue discussing Vue.js on this event in a month. And last but not least, the AI in software development conference in July. We are really excited for this one. We have lots of people interested and interesting speakers, new experience for us and for everyone. Of course, this is a new, very hyped area that we obviously jumped into. And yeah, we're looking forward to what we can show. We're considering having this as a series, and because there's so many stuff happening that we definitely could not cover in a single event. So we'll be doing these, and we'll be doing more. We'll be having AI and software architecture events. We'll have in AI and analytics events. So you can find information about all of these on the Geekle.us website. We have an event calendar. Please go check it out. And so for now, I want to thank you all for joining, for watching these 6.5 hours of live stream. And tomorrow we have at least the same amount of content and even better topics, even like more advanced level for people to learn something. But for now, I'm signing off. Thank you for joining, and I'll see people tomorrow. Bye.